introduce you to, drumroll please, a 14-hour Python extravaganza for absolute beginners. And guess what? It's absolutely free. Yep, you heard that right. I'm making this course absolutely free for you guys. If you don't know where to start, or maybe you have started before but you get lost along the way, this course is perfect for you. I'm going to take you guys from A to Z with lessons, live on coding, as well as project-based learning. Are you new here? Welcome to the family. This is a Code with Josh special. Think of this as a pre-module to my masterclass, but it's going to be the most important module, or the most important 4 minutes of this course, because I'm briefly going to explain how this course works best. I've spent months working on this course in the spring of 2023, and I want you to think of this as the first version of this course. It's not going to include everything of Python. Nope. It's going to do something so much better. It's going to build in a structured way on each lesson, and as we go through, all your knowledge is going to compound along the way. I want you to think about learning, and learning how to code like telling a story. And in this course, I'm here to show you how to tell that story. Here's how you can milk this course for all it's worth. To give you guys a better overall learning experience, I'm literally paying to host this course. Yeah, that's right. And it's still 100% free. I'm not getting paid anything for this. I just want to prove that education can be free if done correctly. And that's why I'm hosting this course for you guys. Now, what's in this hosted course that's still free for you? Well, you get an organized course structure that's so much easier to follow along with, as well as my handcrafted Python starter pack that I've specifically made to pair with this course, so it goes perfectly with it. Anytime you're stuck, you can use this book to help you as you approach the tasks in the course. You also get my new PDF Python book that I've made, and it has 51 useful Python hacks that you can incorporate into your projects and use in anything you're trying to build. It's going to make this so much more fun. On top of all this already, the key component is you get a group, a community of like-minded learners that you can engage with throughout the course and learn with to hold yourself responsible, or if you have questions, right? All of this is 100% free for you guys. I want us to be able to create and grow together. Now, I am going to be in the chat, in the community, active, helping you guys in your learning journey. But my ultimate goal for this is, over time, you guys will be able to help each other out, help new people, welcome them in, and help them get started in their Python journey. I'm not hosting this course for nothing. Head on over and check it out. It's completely free. If I see you guys are using the platform and engaging, enjoying this stuff, this free education, I'm going to continue to host it, right? Because the goal of this as well is to reach more learners who wants to learn coding. But it's also to prove that education can be free if it's done correctly, and you know where to start. All right, we're about to get started. Please, guys, give this course some love. Hit the like button and subscribe so this course can reach more learners around the world who are ready to start their Python journey. If you're ready, I'm ready. Let's dive in, guys. Welcome to the course. It's Josh from the future here. I just tried uploading the video, which was a 14-hour course. The course still is 14 hours, alright? But because I'm a smaller channel, I think YouTube is only allowing me to upload 12 hours at once, which is annoying. I don't ever want this to happen again with all the future courses I have coming very soon for you. So do me a favor and subscribe so this doesn't happen again. But I'm going to link right now part 2 to this course, and you guys can head over to part 2, which is also in the channel, once you get through the first part of our course. Alright, enjoy. Hi guys, and welcome to our course. Before we jump in with the first lesson, I've made this video as a quick course structure and an overview of what you can expect in this course and what is the best way to possibly go through this course. In these next few minutes, you are going to learn some tips and tricks for our course. Going through this course I have broken down to a level to make it easy for everyone to understand. Each module will have a lesson and also live coding in VS Code. And it's broken down to where you can get comfortable in that one topic before we progress on. If you don't have a strong foundation in anything you do in life, eventually as the years go by, it's going to crumble. This course is designed to build you a strong foundation. If you've experienced programming before or you've played around a bit with Python, you can feel free to skip around. But I do recommend you go through each module to gain a deeper understanding. As you go through this course, work on side projects from outside of this course. Create your own and use what we're learning in our lessons to implement that in your own work. As you go through, I have created challenges within VS Code. We go through our lesson material, then jump into VS Code. In VS Code, pause the videos in the beginning, read through my challenges, and try to complete these on your own. If it takes you 5 minutes, if it takes you 30 minutes, it should be challenging, and this is how you will progress even faster as we get more advanced in the course. All the lesson material and all the slides that I will be showing you throughout our course, I have included for you, so you do have access to these at any time. Use these as your notes, which you can go back through, read, and understand on a deeper level if there is a challenging topic. Any needed material that you need to complete a project, I have also included in our course. Once you get to that module, specifically Pygame, you will find files with images and audio as well as additional notes to help you understand what we're trying to achieve, and you can use these in your own projects. But feel free to bring in your own material from the outside of this course to use in these projects as well. Building a strong foundation. I've touched on this before. What we're going to be looking at in the course is in front of you now. We will go through. I have structured this course in a way that it builds on each lesson. We will work with operators and the basic Python functions, which we will use in every lesson of this course. We will spend time working with conditions. A computer only understands true and false. That is what conditions are. We will focus on ways to repeat our code with Python, and we can use loops to do this. And a big part of our course will be creating your own functions, which we can reuse in your application. We'll spend some time diving in and working with modules in Python, as well as working with classes and inheritance, which is a more advanced topic, as Python is what we call an object-oriented programming language that'll come to life in these modules. We will work with defining lists and ways to go through our lists. And to bring everything together, you will be building multiple applications in a module called Pygame. I've chosen Pygame because it is one of the best ways that we can use everything we've learned in this entire course all within one application. So taking what we've learned from the beginning of the course all the way to our more advanced topics and tying them together. I look forward to seeing you guys in our first lesson. All right, guys, great. So before we get started with the introduction to the Python course, anything like that,
I need to make sure that your environment is set up on your operating system. So if you have a Windows or a Mac, we need to make sure that you get Python installed and we have a code editor. All right. So first things first, just head over to Google, all right, and you guys can just search out for Python. And we are going to go to the first link, so python.org. All right, so here we have a few things, but this is where all the Python documentation is held and also where we can download Python as well. So what I'm interested in is we have these 4 subsections: Get Started, Download, Docs, and Jobs. I'm interested in downloads, and I want us to click on the latest version of Python, which will then take us to a page that looks just like this, okay? Don't worry, if your numbers are not the same as this, that's fine, because there could be a newer version of Python that comes out, and we will also learn how to upgrade Python in our code editor at a later stage. Once we're on this page, we are going to scroll down to the very bottom to where it says Files. Now, here are the downloads. If you are on a Windows, it's recommended that you use the Windows installer 64-bit. If you are on a Mac, you can use the Mac OS 64-bit. All we need to do is click this link, and in the top there, we see it downloading, okay? Once Python is done downloading, I want you guys to double click on that and go through the steps of installation. It's just checking a few pages and clicking install. I'm not going to do this as I already have Python on my system. That's Python, okay? Next up, we need a code editor. Now, our code editor, there are plenty of free options, with the popular 3 being Sublime, Atom, or VS Code. Now, in this course, we are going to use VS Code, or at least that's what I'm going to be using as well. And VS Code was created by Microsoft, and it is used by software companies all around the world to create projects and collaborate together. Once you search on Google for VS Code, you can click the first link that says Visual Studio Code, and you'll be taken to their main page. On this main page, you will see a box. Now, I am on a Mac, that's why it says Download Mac Universal. If you're on a Windows, it should automatically change to Windows. If not, you can choose the drop-down box and you can choose the stable download for either Windows or Mac. I'll click that, and just like before when we downloaded Python, at the top it is going to start downloading. Once it downloads, open it up and go through the steps for installation. Once it's installed, I recommend creating a shortcut and putting the VS Code icon on your desktop or even in your toolbar at the bottom of your screen. That way you always have it and it takes you right into VS Code. If you can't find it, it's most likely in your applications folder and you can find for it there. Okay, I am going to jump in to VS Code and we are just going to look at the basics of understanding how VS Code works. I'll see you in the next intro. Alright guys, here is the setup for VS Code to introduce you guys to it before we jump into our lessons. Now, once you open VS Code, you will see a Get Started page, and this pops up every time you open a new project in VS Code. Now, I don't ever use this, so I typically start off by closing that page. Okay? Now, on the side here, you see a draggable bar. Okay? So currently it's out. Now here is where we structure all of our code files. All right? And at the top, you can create a new file or you can create a folder to also store your files. If we create a new file, which we will be doing a lot, I will click New File and we need to give it a name. So typically your main file in Python is called main. Once we have a name, you must give it an extension. So, as example, if it was JavaScript, you would end in .js, right? If you were doing C++, you would end in C++. Because we're doing Python, we will end all of our files in .py. And you can click enter, and it creates a page, a file where all of our code is going to go. Okay? If you wanted to create another one, you would just do the same thing. Okay? And this stores all of our files. You can do two things to access this bar. One, as I showed you, is you can drag the bar away for more space. Or, I'm on a Mac, I can do Command B, and that hides it, and Command B opens it. Okay? Now, when we run our code, okay, it will run in the terminal. And the terminal is actually on the bottom of VS Code. So there's two ways to access it. Three, really. Okay? One, you can drag up from the bottom, and it presents all of this: problems, output, debug, console, terminal. Okay? We are interested in the terminal. All right? And just to check that you have Python installed, what you guys can do now actually is I'm going to type Python 3 -- version. And it's going to output the version of Python you have. Okay? If this doesn't work, I'm going to guide you how to get Python on VS Code as well as an extension. The other way to close your terminal is Command J. Right? That opens and closes our terminal. I'm going to put very brief code here just to show you. Okay? When we have code and we want the code to run, in the top right of your screen, you see a play button, right? A triangle. If you click triangle, that is going to run your code in the terminal, and you can see your output. Everything on top, don't worry about it, okay? It's not very important for now. You want to look directly after the bottom line. You would see your output there, okay? For now, I'm going to close my terminal, trash my terminal, and then jump on in here. Now, you're going to see a few things. So I have mine set up to my preferences, all right? Now, to get you set up, we need to get a few extensions onto your VS Code. Over on the sidebar, there are a bunch of tools. One of them, like the Tetris blocks, is your extensions, okay? On this extensions panel, I would like you guys to search out for Python, okay? It's going to search, and in the top one it says Python, and it has the Microsoft verified check mark. Click on that, and I want you guys to click install, okay, to get this into VS Code as well. Then, if you try to run in your terminal Python 3 version, if it didn't work the first time, you will see a version now. Now, I do have a few more extensions that I'm going to cover in case you guys want them as well. As you can see at the top of my screen, I have the Python icon, and that is a special Python extension that just puts the icons into our files. As an extension, you can search for VS Code icon, and it's going to be the top one. All right, so VS Code icons, it's verified by the icons team, and you can download this. And this will give all of your files that same picture for your extension. Another popular one is I have on Python indent, right? So this is going to automatically indent our code as we need it. So if mine looks a little different from yours, it's because I have this and you don't. You are welcome to download this as well, okay? This extension is by Kevin Rose, Python indent. Just click install, okay? It'll be added to your VS Code. Now the last one is I have a theme. So a theme, right? If you check here, see how print is blue, or if I say if this, right, I get these different colors. Okay, so your colors are not going to match mine, and that's because I have a theme, which is a color template for our Python code. If you don't want a theme, that's fine. It's going to work the same way. If you would like a theme, over in your extensions, you can search for themes. And there are a slew of themes, okay? You can go through and you can just check out the themes, experiment with the ones you like, okay? If you're looking for my theme, I am using Synth Wave 84. Okay, I am on this theme here, all right? And you can install that, and then our colors are going to match as well. Okay guys, our setup is complete. I will see you guys in lesson 1 for our first official lesson. All right guys, welcome to lesson 1 of our Python course. And this is 0 to knowing. And we will go through Python on a fundamental level to get you guys to have a deeper understanding of what's happening so we can implement our knowledge into creating projects. Now, as I go through this, I am going to go through this at a slower pace so I can break everything apart to have you understand on a deeper level, but also on an easier note too than just jumping full-blown into Python. If we don't understand the foundations and the fundamentals, everything we learn and progress into is going to crumble and fall apart. It's just like building a house. To build a house, we need to have a strong, sturdy foundation, which is going to allow that house to stay standing for decades to come. Python is the same way. Now, I am going to go over first 3 important rules that we face with programming and Python. These rules will apply to everything we do down the line. Let's take a look. All right, so our first 3 important rules, okay? We have the first one, which is the rule of beginning, or the beginning rule. And the first command of our code is written at the top left. So it's just like a book. In English, we read left to right, top to bottom. And this is very important with code as well. Our first line of code, our first command, is going to go in the top left of our code editor. Number 2, the rule of order, our order rule. So, commands are executed or ran in the order they are written. So, just like a book, we read top to bottom. Python is going to interpret that the same way. And it's going to run our code line after line, top to bottom. Whatever we want to run first needs to go at the top, and so forth. And our last rule is the rule of styles, our styling rule. How do we style our code to effectively work how we want it to? Now, a few important things to note. Replacing lowercase letters with uppercase is not allowed. For the time being and going forth throughout our course, just make everything lowercase. There will be special times where this will change, but for the time being, everything we write is lowercase. A space or a comma can break our code, okay? We don't want to use spaces and commas. We just use for separating data types, which we'll talk about later. So let's not use space or commas, and let's keep everything lowercase. These are the 3 rules we will use going forward. Okay, great. Now that we understand these 3 rules, I can introduce the first function, the first real piece of code that we're going to talk about. Now, if you've ever done research on any coding language, this is usually the first thing that's introduced. We have here print, okay? And print is a pre-programmed function that's already ready to use. It's a special Python word, a special Python function that is ready to use out of the box. And for now, a function. We will look at these pretty much every lesson we have. And long story short, a function is reusable code, okay? It's code you can use wherever in your program and reuse it. It's going to do the same thing. Now, a function, okay? Notice our function has its own color. All functions will have their own color, okay? One set color in our code editor. And after a function, we always have a set of parentheses, okay? That is how we identify that it's a function. Inside print, in our first example, I have text. Now this text is actually called a string. Okay, so a string is just text, and a string is inside a set of quotation marks. If I were to print this, it would output the following: hello world, just like text. Okay? Now in my second example, I have the same thing, except this time you see that the comma is now black. It's a different color. This comma is not a part of our string. It's being used to separate 2 types of data, both of which are strings, okay? And it would output in the console, in our code editor, hello world. Now, it's important to note, a comma is going to create an automatic space in your output. Okay, so if you notice here in our first example, we have a space that we typed. In our second example, there is no space before or after the words, but because we have a comma to separate these strings, it is giving us an automatic space. In the third example, okay, I've printed off I am 55. That would output into our code editor the same results. I am 55. Okay? I'll introduce this now. This 55 is not a number. It is a string. We cannot do any mathematical problems with a string. It's a string because we have it enclosed inside our quotation marks. Okay, it's a string. Now moving on to our last example, you can see that these are different colors. A string is going to be one set color, okay? And an integer or a number is going to be another color. These do not have quotation marks. They are 2 different integers which we have separated by a comma. If I print this off, if I output this to our code editor, it's going to output 78 and 6. Okay? Going forward too, okay, for the time being, we only want to use double quotes for our text, for our strings. Okay, so notice that everything I have is using double quotes. And this is going to help us reduce any errors we have in the future. Do you have to use double quotes? No. Can you use single quotes? Yes, you can. Okay, but for the time being, it's good practice. Our strings are in double quotes. All right, let's take a look at a few operators we can use in our print statement and just doing operations throughout our program. Okay, so going forth, all right, let's take a look at our mathematical operations. Okay, so in Python, if you use the Shift 8 or the 8 key, you get your multiplication symbol. Okay, if I take two integers, I can print off their output, right? So 3 times 9, I would get 27. Okay, we can use the plus sign for our addition. 23 plus 4 would give us 27. And I can also use the subtraction sign. 36 minus 9 would be 27. Our division sign is going to be the question mark key, the slash, okay? That is for all division. So 54 divided by 2 would output 27 as well, okay? Now, if we're working with strings and integers, okay, these are different types of data. To separate different types of data, we can use a comma, which we put between the two. So for example, I print my grand total, and my grand total is going to be 25 times 4. In our code editor, we would get grand total of 100. Okay? Now, we cannot see that these are different data types. But if we try to use them, we would get an error. Okay, so we can print off two different data types, split by a comma, and do a mathematical equation in one, and the other one being a string or just text. Let's take a look at a few more that we could use in our programs. The next three, okay, so going forward, we will use two of these, okay, regularly. And one of them not so much, but it's still a powerful tool to use that we will use in more advanced programming. Okay, so print. We have our percentage sign, and this is really called remainder of, or in technical terms, modulo. Now, what remainder does is it puts the final number into our first number. It's almost like division, right? And it's going to give me whatever it's left with, right? So 2 goes into 20 an even amount of times, but you're left over with 1. That is producing our output of 1. Okay? Now, we can do division or a quotient, but we can round it down so we don't have a decimal. If I say 22 divided by 3, you're going to get 7 point something. It's going to be a decimal number. We don't want the decimal. I want to round it down, right? So ideally, right, 21 divided by 3 is 7. 22 divided by 3 is a decimal number. I can remove the decimal by using 2 slashes. And finally, our last one is our raising to the power. Okay, if we want to raise to the power, we just need to use 2 multiplication symbols, and that would produce our output of 64. Okay, doing math in Python. So I don't know how you guys were taught in school, all right? In school, growing up, we learned this. Specifically, this phrase was taught. Please excuse my dear Aunt Sally, okay? Each of those words symbolizes a step in mathematical operations. So our P is for our parentheses. E, exponents. M, multiplication, division, addition, subtraction. Now, Python executes mathematical problems in the same way. It's going to start with all your parentheses, then it moves to our exponents, to multiplication, and so forth. All right, so if you're doing a longer mathematical problem, remember this rule. Great, guys. Okay, so going forth, let's jump over into VS Code and take a look at how we can use print in running this as actual code. I'll see you there.
Hi guys, I hope you're getting immense value from this course I've put together for you. Just a reminder, remember, I'm not getting paid anything for this entire course. So to help me out, you guys can head over to the platform that I'm paying to host for you and utilize it, engage, get higher quality content from me, and get all those guides. It's still free, absolutely free. It's the first link in the description, right? Head on down there. That really helps me as I release more of these courses to help you guys go from A to Z in Python. And I mean, if you really don't want a course, that's fine, okay? It's still free. I don't know why you wouldn't, but if you don't, okay. The first link in the description, I'm gonna give you guys that handcrafted Python guide that I made because that guide I made for this course. You're not getting the most of the course if you're not using the guide. It pairs perfectly. That's also the link in the description. You don't need to go to the platform, just head there and get the guide. All right, I hope you're enjoying this content. If you are, please do me a favor, click the like button and subscribe as I have weekly content out dedicated to helping you grow. All right, back to our lesson.
All right, guys, and welcome to VS Code. Going over the slides that we just introduced, we are going to practice using the print function to print out different data types, and we can use some of our mathematical operators to conduct math problems, or to solve them, I should say. Now, at the top I have a note or a comment. I am going to be talking about this later in the course. But if you guys want to add notes, you can put a hashtag before something, and this becomes a note, or what we call a comment. Now, I'm going to print off a few things. So, I'm just going to print off a string that kind of just says, hello everyone. Now, we use it by using our print function, okay? And remember, a function is always followed by parentheses. Inside here, we put what is known as an argument, something for the function to use, okay? So, what I'm going to just say is I'm going to put a string using double quotes, and I'm just going to say, hello there, everyone learning, okay? Now, notice that this is the first line of code, and it's also on the left of our screen, following the rules we learned in Python. If we click run, right, the play button in the top of our file, we are going to see our terminal open and it should output our string. The top part, as I mentioned in the setup, we can disregard that, and we are going to look directly above the last line, which is where we find hello there everyone learning. Right? So that's Python talking to us. That's it putting out an output for us. Okay? Great. Let's try to print off a few things now. So let's say we have an item and we want to print off the cost. Okay? So I'm going to print out two things to show us. If you see this text box, okay, now sometimes it's annoying. Other times while you're coding, it is going to be helpful to you. It can explain what goes inside here if you forget. So let's say we have an item cost, okay, and that's going to print off in one line. And in the other line, I want to print off a calculation. So how much is the item? But let's say we're going to give a discount at the end. So initially, right, let's say I have 25 times 4. So I have 4 items, they're each valued at $25, or you have 25 items and they're each valued at $4. Before I run, just to make sure we have space in our terminal, I'm going to put a hashtag before print, which turns it into a note, and Python is not going to read that. If I trash my terminal, and I'm going to run it again so it clears things up, you can see I have item cost, and it says 100. Great, okay? But let's say we want to give a 20% discount, okay? I want you to think, how could we do that? Well, remembering our steps, please excuse my dear Aunt Sally, or the way that Python runs a math code or a math problem, it starts with parentheses. So I'm going to actually put these inside parentheses because I want Python to run that first. Now we need to give a 20% discount. So this is basically like 100 times, and a 20% discount off of 100, you would be paying $80. So if we multiply this by 0.08, that's going to give us our 20% discount. If I run that again, you can see our updated item cost, $80. Great. All right, so remembering that if we want to get the discounted price, the updated price, we would multiply this by 0.8. If you wanted to get how much off, you would multiply that by 0.2, which is worth 20%. All right, we are going to make up a new one here. So I can close my terminal for now. I'm going to come down, and we could put this together in the same print function or print statement. So I have my print, okay? So let's say you want to send funds, or you want to send a transaction to someone you know. All right, so be creative here, okay? And I could say like funds to send, and then I'm going to go over one outside of my string, because remember, this is all text. I now have a new data type, so I'm going to insert my comma. Our commas are used to split our data types. And then we can just put a few numbers here, right? So let's say 200 times 5, right? Plus 600 divided by 5, plus 750 minus 75, right? So it's going to output funds to send and then a number here. If I run it, before I do, let's turn these off just so we can see an updated terminal. Run it, and we get our output. Funds to send, 1,795, right? And all of that is done in one line, remembering we use the comma to split those types. Pretty cool. All right, I'm going to do a few more of the unique operators. All right, so we had one called remainder of, or modulo. So let's start off. Let's say print. Now remember, remainder of is going to give you the amount that's left over after division is done. So if I did something like 57 modulo 3, now does 3 go into 57? Well, if it does, I should get a 0. If not, I should get how much is left over. So we run it, and you can see that it says 0, which means 3 does go into 57 the correct amount of times. If I were to change that, right, and say 57 modulo 4, then we should be updated and left with 1, right? So here's how our remainder of is functioning. Now, our remainder of is only going to ever be 0 and 1, right? In the first print example, we do have a remainder of 0. In the second print example, we do have the remainder of 1. Okay, and the last one that I'm going to play around with here is to show us the quotient, or specifically the rounded down, right? But let's just first do our division as a normal division problem. So Let's use the numbers 30 divided by 9. And this is going to output a decimal number, right? So 3.333, etc. Right? But I don't want that decimal, right? If we wanted to revoke the decimal or take that away, we could use 2 division signs, which gives us the rounded down. I run it, and now you can see that I'm left with 3. It takes away the decimal that's left. All right? So, I want you guys to play around before you move on to the next lesson. All right? Get creative, print things out. All right? If you got hobbies, it's fun to use hobbies to use in your code. It's something you're already passionate about. So print off a few things, combine data types, right? So just like we did here, do some cool problems, and I will see you guys in lesson 2. Hi guys, welcome back to lesson 2. In the last lesson, we introduced the print function and how to use mathematical operators to output things to our terminal in Python and VS Code. In this lesson, we are going to be talking about variables and what a variable is and how to work with them in Python. Let's take a look. So, a variable. What is a variable? Long story short, a variable is a name that holds a value. I'm going to say that a lot, okay? But a variable is a name that holds a value. It's a data element that has its own name, and we use variables when we work with changing data. So think numbers here, all right? These are where variables come into play, even with strings as well. So, how do these look? Now, when we define a variable, we essentially create a variable. And remember, a variable holds a value. It's equal to a value. To create a variable, we give it a name. Now, remember last lesson I mentioned everything is lowercase. Let's keep that trend here. A variable's name should be lowercase. It must not start with a number, okay? And it cannot have any special characters like hashtag, the $sign, exclamation point. No. Let's keep it with lowercase. And then we need to set the value of our variable. So down here, I have an example, okay? And I have 2 variables. My first one is called years, and it's equal to the value of 2. The second variable is months, and this is equal to the value of 6, okay? Now notice, these are both numbers, right? I'm working with a type of data. This data can change in the future if we want it to. Now I could run my print function and I could use our different data types. I have strings with our numbers, our variables. If I print off, I've had this job for years, years and months, months. Ideally, what that's going to put out in our terminal is I've had this job for 2 years and 6 months. Right? It's not going to print the name of the variable. It's going to print the value of that variable. All right. So when we set the value of the variable, we need to use what we call the assignment operator. And really what that is it's just an equal sign, okay? We start with our variable naming, we insert our operator, and then we give it a value. So if we print off our variable, print years, it's going to print off in our terminal 2. All right, so it is important to note, so as we get working with these, you will see why this becomes important very quick. The equal operator can change the value of an existing variable. It can change the value of an existing variable. So just remember, Python reads top to bottom, just like a book. All right, it's going to run the first line, it's going to run the second line, and the third line. If our variable changes, it cancels the pre-existing variable. Right, so check this out. I have 2 variables, right, but they have the same name. So in line 1, I say years equals 2. But later on down the line in my code, I have now years equals 5. I have changed the initial value of this variable. If I print off years, this time it's going to output 5 in our terminal. It's basically going to cancel the first variable of years and say, nope, not that anymore. It is now equal to 5, and that would be our output. So when it comes to naming, okay, I've briefly mentioned this before, but we're going to talk about it once more, all right? You can use letters, digits, and underscores, okay? So let me slightly rephrase that. You must begin with a letter, okay? It has to start with a letter. You can use numbers then anywhere in the name of your variable. And if you want a space, you can't use a space, but you can use an underscore as your space. And a variable's name cannot be a pre-existing command or other special word in Python. So the one that we know now is print. You can't call a variable print, all right? Any other function or operator we learn with Python, you can't use that, all right? So be creative with your variable naming. Now, speaking of being creative, let's talk about good names and bad names for naming our variables. So I've put together this chart. I have good naming conventions and bad names as well. Let's start with the bad names. So in these first two, all right, p equals 25, num equals 8.46. Now, if your code is really short, it works, that's fine. But generally speaking, these are way too generic. When you have to read back through your code, or another developer is reading through your code, this does not help him or her, right? We want to be very specific for our variables. In this other example, I have a variable called number of airports in America. Yes, that's very specific, but that is far too long. Imagine having to type that out every time, right? It takes time, it's too long. But you can see here that I am using underscores as spaces, right? That's good practice. Now, a few good names. Which names are going to be effective for us in our development career? Well, I have a variable called last name. That's very straightforward. I understand what that means. And it's easy to read because I have capitalized the second word in that variable. I don't even need an underscore. Last name equals Gates. That's perfect. It explains what this variable holds. My next one, I have item cost. And this time I've used an underscore, right? That's great, right? Item cost is equal to 99. Or even amount sold is equal to 222. These are good names. Other programmers are going to be able to read your code much more easily, right? And these names actually explain the purpose of your variable. All right, so far, we've really been working with two types of data, or different data types. Now, a variable can hold any type of data, but so far we really know three, right? But we've only introduced them as two, okay? So the three data types would be an integer, and an integer is a whole number. A decimal, which in Python we would actually call a float, is a decimal number. And the first data type we introduced, right, is a string. And a string is just text. All right, so take a look at the chart I've put here on the bottom. All right, we have some integers, we have some floats, right, our decimal points that we're getting in there, okay? And then all of our strings, right? So remember, even though these are numbers, we can't do anything with that because they are a string. They're still text, okay? And I'm still using good practice here to where we are using double quotes in our strings. All right, so working with numbers as a value, okay? This is where our variables can become very powerful. So I love travel. I like taking trips. Throughout our course, you're going to see a lot of my challenges and tasks I give you relate to travel and things like that. Okay, so in this example, this code calculates a passenger's flight fare. Okay, initially we created a variable called base fare, and we set that value to 155. I have another variable called the num of bags for the number of bags, and that's 2. Now, later down the line, I take base fare and I changed its initial value, right? When we do that, the first one pretty much becomes non-existent. Python is not going to read the first one. In my fourth variable, I create one called total, and this holds our mathematical operation, right? Because base fare is equal to 205, and then I'm multiplying that by 2 times 0.75. If I print off total, in my console, I'm going to see $307.50. If you need to pause the video, that's great. Pause the video, read through this brief code example to truly understand what's happening here. When you're ready, let's head over to VS Code and put variables to use. I'll see you guys there. All right, guys, here we are in VS Code for lesson 2. In this lesson so far, we introduced the topic of variables. And remember, a variable is a word that holds a value, okay? Now, on the screen, I have put 3 tasks or 3 challenges. If you're up for a good challenge, I want you guys to actually try to pause the video, read through what I have, and give it a try on your own. Be creative for the value of the variables, unless I have stated otherwise. If you want to give it a try, pause the video here. All right. I'm going to jump in and I'm going to do the first one to start off with. I'm going to clear up some space, okay? And I'm going to start right here, okay? So, in the first one, now I like traveling. So a lot of the tasks in here are going to be related to travel because I want you guys to be creative with your code and use your hobbies or your passions to help carry you through. And that makes it more fun and it piques your interest. So, in number 1, we want to create 4 variables for traveling. I want to have a flight cost, insurance, passport, and baggage, okay? And then we want to create a variable to calculate all of those added together. And we can print off the total cost with strings and variables. Now I've added a note. There are 5 people traveling. Okay? So, let's kick it off. Let's create our first variable. I will call it flight cost. And let's say the flight cost per person is $455. Okay, be creative. We have insurance, and the insurance per ticket is going to be $19.99. All right? Everyone needs a passport, so passport cost. Now, the last time I applied for a passport, I believe I paid $110, so let's just say $110. And then I want a variable for baggage. And let's say everyone's bag costs $45. There we go. I have 4 variables. Each of them's value is a number based on the variable name. Now we want to add these together. How can we do that? Well, a great way to do it is to create a new variable. And the value of this variable is going to be all of these added together. So we can take flight cost plus insurance plus passport plus baggage. All right? And because these variables are all numbers, it's going to add those together. But I did say that there are 5 people traveling. So I basically want to multiply this by 5. And to do this, right, I'm going to use parentheses because I want Python to add those together before we do any multiplication. I can then multiply that by 5. All right, let's print it off. Let's print it off, and let's say something like the total cost, and then we can add another data type, and we can add our total variable. If I run this, let's run it. And here we go, in the terminal. Total cost is going to be $3,149.95 for a family or a group of 5 people with all the same costs. All right? That is us using variables to our advantage, adding them together, and then we're able to multiply that value before we print off the total. Okay, I'm going to close my terminal. I am going to put a hashtag before my print that turns it off, so it's not going to print every time. And I'm going to move down here to the next problem. All right. In number 2, we want to make 4 variables for ticket price. But hear me out. One of these variables is for the number of adults, and one is going to be for children. Then I want to create 2 more variables. One variable is the adult price per ticket, and one is the child price per ticket. We can then calculate the total of all of these. And we want to print off the total with strings and also our variables. Okay? So let's say you're going to Six Flags. All right? And we're going to have the parents. So adults, there's going to be 2 adults. Okay? And the children, there will be 2 children. So my 2 variables with the value of 2 in each of those. Now, the adult price for a Six Flags ticket, let's say, is $55. And the child price of a ticket is going to be, let's say $27. Okay, so we have 4 variables. We got ticket prices and we got the number of people going. Let's now do some math, and we want to find out the total. So ideally, we want to find out the adult total, which is going to be the number of adults multiplied by the adult price. And then we're going to add that together with the number of children multiplied by the child price. Okay, so take a minute, read through, see what's going on here, and then we can print off. We can print off like 6 flags total, and we can insert our total variable. When we run it, we are going to see our output here in the terminal, and the output is going to say, hey, for the day, the 6 flags total is going to be $164 for everyone. All right, so that's us now taking variables, multiplying them together before we add them together. Nice. All right. Let's do our last one. I'm going to turn this off. I'll close my terminal, and we will get down to our last one. Okay. In our last challenge, a resort offers the normal price of $500 per night. A family wants to stay for 1 week, but the resort is offering a special promo of 30% off. We want to print off the last minute trip price after this special promo. All right? So, how many variables are we going to use here? I want you to think about that. All right? I'm going to start this off with price, and I'm going to say price is equal to 500. Okay, I'm going to say days, and a week is 7 days, right? So they're going to stay for 7 days. Cool. Then we want to get a total. So there are 2 ways, right? You could make a variable for total and then have a variable for discounts, which I'm not going to do to keep it shorter, right? More fluid, better readable code. So let's say our total is equal to our price times days, right? But now I want to give 30% off. So what is their new total? Now an easy way to look at this is I'll just say 100 times 0.7. Right? That would give you the value of 30% off, which is going to be 70. Well, the same thing applies for us. I can multiply total by 0.7, and that is going to give us the updated price after a 30% discount. We can then print off special price, and we can say total. We can run our terminal, and in our terminal, we are going to see that we have a special price of $2,450, right? That is the price after the promotional discount. Great, guys. We have now looked at variables and using them. Now, remember, a variable can be a string, a number so far, right? So what I want you guys to do, be creative as usual, all right? Come up with some of your own examples and play around with using variables. I'll see you guys in the next lesson. Great, guys, welcome back. Here we are in lesson 3. In the last lesson, we introduced variables and how to work with variables. But now the question becomes, how do we gather data? How do we enter data, right? And specifically, imagine we want to gather data from a user. So how can we do that? That is the topic of this lesson. Let's check it out. So, you guys so far know one function, print. We are now introducing the next function, which is called input, right? And keep in mind that input is followed by a set of parentheses. And this allows for a user to enter data, right? Python basically asks the user a question, and we can use their answer as a variable value. I'll say that again. We can use their answer as a variable value. Okay? So, what are the names of my two variables? Well, our first variable is last name, and our second variable is city. Last name is equal to input. It's equal to our input function. And right here, it's giving us some text. It's giving us a clue, right? So, hey, enter the owner's last name. The same thing happens for city. We are collecting an input, and we're saying, enter the city. Okay, so city is going to be passed down just like before to our print. In last name, that value is going to be passed down into our print as well. So for last name, if we enter Smith, and for city, we enter Seattle, that is going to print and output in VS Code, the owner in Seattle is Smith. Right? So we can use the input function to collect data. It's actually going to ask us a question, and we can use that value. So, how do we set this up? Okay, so generally speaking, okay, input needs a variable. That's not always the case, but for the time being, input needs a variable. Right? So our variable is password. And password is equal to input. Whatever we put inside input, now it must be a string, but whatever we put inside here is basically placeholder text. It's a hint for the user for what they should type in, right? Imagine you log on to your laptop, right? And you click forgot password. Sometimes a hint is going to pop up, and it's going to help remind you what you should type as your password. Well, input works the same way. All right, so this could result in a few errors, okay? Now, what are my two variables? Well, if you said extra and total, you'd be correct, right? So extra is equal to input, and we want to enter the price of extra add-ons. All right. Now, the value of input is a string. Okay, so whatever you input inside here, it is going to be a string. Extra equals string. Okay, it will not be a number. So in this next line, total equals 1,000 plus extra. That's going to throw me an error because a computer can't add together an integer and a string. That's adding together two different types of data. We cannot do that, okay? We won't get the error, of course, until we print it off, okay? But we can't add together two different types of data, right? We need to convert the string values into integers before we can do any math. All right? So the key takeaway here is input is going to be a string, not a number. All right, so now the question becomes, how do we convert? Well, I'm going to introduce two new functions now. We have the int function, which allows us to convert a string into an integer, and we have the string function. And this allows you to convert an integer into a string. So stop right there. So far, we have learned 4 functions. What are they? We've learned print, input, and now we are looking at int and the string function. That is 4 new functions, okay? And we can use these to switch between numbers and strings. So here is our exact same code, right? We set off by creating a variable called extra, and the value of extra is whatever we enter as the price of add-ons. But that is currently a string. I can now use extra again. And basically I can say to Python, hey, extra is now equal to an integer, right? And I can pass the variable extra down as the argument of what goes inside my int function. And this will convert that string into a number. So now in our variable total, total equals 1,000 plus extra. Extra is now a number, okay? So for example, in our input, if I enter 10, 10 is converted to an integer, and it's basically saying total equals 1,000 plus 10. And I can print off total price, and it would print off total price is 1,010, just like so, okay? Although we will be focusing on the int function, all right, you should be using everything we're learning so far to create your own problems and tasks in VS Code. Okay, so string, right, that converts an integer to a string. It does the exact opposite of what the int function does. All right, guys, let's head over into VS Code and implement our input as well as our integer and string functions. I'll see you guys there. All right, guys, here we are in VS Code. Now, so far in this lesson, we introduced how to gather information from a user. And we learned how to convert to numbers and strings using the integer function and our string function. So, before we jump in, all right, remember, if you want to create a new Python file for every lesson, that's great. Just go over to our Pages tab and create a new file with the Py or Python extension. Now, I have on the screen here 4 tasks or challenges that we're going to complete here. If you guys are up for a good challenge, you can pause the video here, read through these, and try to complete these on your own using what we've learned so far. If you want to give that a try, pause the video here. All right, I'm going to kick this off with solving the first one. And I'm just going to give a bunch of spaces to clear that out so we can focus on the first one. So, what I want to do is I want to collect 3 pieces of information from a user. I want their first name, their country, and their city. Then I want to print off something similar to John lives in Seattle, USA. All right? So, let's create 3 variables. And remember good naming conventions. So I want to collect their first name. I'm probably just going to call it first name. Now, I can't have a space. Okay? Remember our underscore. So first name is going to be the value of input. And our input is going to be a string. So enter the first name. Cool. Number 2, I want to gather the country. So country is also equal to input. Okay? Now if you're getting these boxes, okay, sometimes they're very useful. and they can help you see what needs to go inside the function. Okay? Most of the time I click away so you have more screen space, but give them a read to see what goes inside and if you find them helpful. So here I can say enter a country, and lastly our city is going to be enter a city. Cool. Now that I have our three variables, we can make our print statement. And I can print off, well, I don't want to start with a string. I want to start off with our first name, separated by a different data type, because it is. And I can say lives in a city. And I want to have a comma in it, so I also need to make a string comma. And then I can say country. Now for readability, I've added spaces between these. Do you need to have spaces? No, you don't, okay? If we run it, what I'm going to see is my first question pop up, and our first question is enter your first name. So I will say Josh. Enter a country, well, Thailand sounds nice right now, so Thailand. Enter a city, let's say Phuket. You can see in my output, Josh lives in Phuket, Thailand. Do I live there? No, I wish I did. Okay? And that's combining our input values, our variables, and our strings to complete our output. Pretty cool, huh? All right. I'm going to trash my terminal, and I'm going to turn these off by highlighting them, Command/. And I can move on to the second problem. Let's give a bunch of spaces here. There we go. Okay. All right. Let's take a look at our second problem. In this problem, we want to create two variables to gather more information. One variable is going to be the rental price of a car for 1 day, and the other variable is going to be the number of days to rent. We can then create a total variable that is not really going to add these two, right? So technically, it should be multiply these two. Multiply, right? We want to multiply those, okay? And we want to print out their total cost. So, their total cost. Well, let's create our two input variables. The first one is going to be the rental price per day, and that is equal to an input. Okay, and I can say enter the price per day. Then we want to find out the number of days to rent. So our input, number of days to rent, like so. Once we've collected these two pieces of information, we can now multiply them together. So our total, what is the total equal to? Well, it's equal to our rental price multiplied by our days. Okay? If I print this off how we want it to look, and I say total car price, and we say total, right? We should see the output, total car price, and the total we want to see. Now, before I run this code, is this good code? Are there going to be any problems in this code? If so, what are they going to be? Well, let's find out. I'm going to run it. And our first question is going to pop up. Enter car price. Let's say $100. I want to have the number of days 3. Oh, we get an error. Okay? If you caught the error, great. Okay? You were learning during the lesson. All right? If you didn't, that's fine too. Our error, right? It's a type error. We can't multiply strings together. Our inputs are strings. We can't do that. We need to convert these to a number first. So, remembering how we do that, I can take our rental price and I can say, hey, Python, rental price is now equal to an integer. And I can do the same thing for days. I can say days is now equal to an integer of days. When we run this again, now that we have numbers as the value of our input, we should see a much more appropriate response. So let's try 100 times 3. There we go. Total car price is $300. That's great. That's what we wanted. All right, so we use the int function to convert our data types. We used our input to collect that from a user or from you. All right, moving along. I'm going to comment these out, okay? And we are going to move on to the third task. Let's give a bunch of spaces here. There we go. So, in our third one, we want to create 3 variables for shipping packages, okay? A user can enter the weight of 3 packages. And we're going to create a variable that's going to add these variables together. Once we've done that, we're actually going to give a 20% discount off the shipping weight. So remembering, if I enter 100, I want to give 20% off. I would multiply that by 0.8 or 80%. And that would give the updated shipping weight. Okay? So, in order to do that, we are going to create 3 variables. So, package 1. Package 1 is equal to input. And I can say, enter the weight of package 1. Okay. Now, it is good practice to type it out, but we are going to have 3 inputs that are very similar to each other. So, let me copy that. And I'm going to paste 2 times. Now, our variables cannot have the same name, or else we're just updating the value. We don't want that. So package 2 and package, not FN, package 3. I'm also going to change our inputs for the readability so we're not getting confused. Right? Great. Okay. And remembering from the last task that these are going to be numbers. So all of these need to be converted to an integer. So package 1 is now an integer. Package 2, we also want to make an integer. And package 3. Okay, our values we need to change to make sure the variable names match. Great. We've collected our information, we've converted them to integers. Now we can do our total variable. Now because we're going to give a 20% discount, let's do the addition first. And we can say package 1 plus package 2 plus package 3. Once Python has done the addition, we can then multiply by 0.8. Great. Now we're looking to print off. So we want to print off like shipment total and our total, just like so. Let's run it. Let's watch what happens. I'm going to scroll down so we just see the code. I'm going to run it. Our package weight 1 pops up. Enter the weight of package 1. Let's say 25. Package 2, 20. Package 3, 15. There we go. Shipment total after our discount is going to be 48. Right? 25 plus 20, right? 45 plus 15 is going to be 60. 60 with a 20% discount is 48. Very nice. Let's close the terminal. And I'm going to deactivate these. And we're going to work on our final task. All right, let's delete. Let's clean this up. All right. So in the fourth and final task, we want to create a user ID for a person. All right? We want their name, their age, and we want their user ID number. But I'm giving you a user ID. Okay, so their user ID number is 786417. And we want to convert everything to a string and print off their information. Okay, so by doing this, right, we're kind of using the string function now. So I'm going to say user, and let's just say their user ID is basically their name. Okay, so, or let's be creative. Let's say enter username. Okay, their age is going to be an input, and I'm going to say enter your age. And finally, their, let's say, ID number is equal to 786147. You can see the different types of data, right? So my numbers are different. I said to have a number. Before we can print this, we need to make sure our ID number is now equal to a string. Like so, okay? Now age, right? Initially we need to collect the age. It's going to be a string. So because we want to make sure everything is a string, I don't need to convert this to a number, right? It's naturally going to be a string, okay? So what we can print off then is we want to kind of just welcome the user, okay? So I'm going to say welcome. And instead of using commas to separate the data types, because all of these are strings and I want to have some periods for my punctuation, I am going to actually put a space inside the strings. To separate my data types, I'm going to use a plus, right? If you use the comma, that's fine. A plus, you can do this as well. But the only difference between the plus and the comma is a comma automatically gives you a space, a plus does not. So I'm going to say welcome, what did I say? User, okay, plus, I want to welcome the user, and it has a period after the user's name. And I'm going to say you are, space, plus age, plus, we want to have now their user ID. So your ID is ID number. All right, let's give the final one a try. So our user ID, let's say Crazy Apple. Age, let's say 35. There we go. Welcome, Crazy Apple. You are 35. Your ID is this number, this now string. Now, the punctuation is great. The periods come directly after the sentence. That's what I was going for by using the plus instead of our comma in our print statement. All right, wonderful, guys. Okay, play around with input in our two new functions, which were also integer and string. Try to create your own. Remembering, go around your hobbies if you're stuck on what to do. I will see you guys in the next lesson. All right, guys, welcome back to lesson 4. In the last lesson, we worked with how to collect data from a user using the input function and how to convert that input if we need it to be a number. We used the int function, and we also looked briefly at the string function. In this lesson, we are going to be talking about nesting functions, which allows us to create shorter and cleaner code. Or simply put, it's when we put functions inside of each other. Let's take a look at an example and the two things we need to look at in order to do this. So, nesting, right? You're going to hear me say that a lot. And really, it's just putting things inside of each other, okay? But we need to know two things first. One, which functions can be nested? And two, how do we nest them correctly, right? What's the correct order? In this example, you can see that input is inside of the int function, right? So height equals an input that's going to be automatically converted to an integer for us. Okay, what we've been working with, right, is we have returned two types of values. We've been working a lot with print. Now, print returns no real value. It's a value that you and I can see as the developer. Whatever it prints in the terminal, we can't do anything with that, okay? It's just a readable value. The other things we've been working with return a usable value, okay? So for example, our variable time is equal to input, right? And it asks us to input a time. Whatever we type in there is going to be a string. I can use that value stored in time to do something. In the next example, cost is equal to cost1 plus cost2, right? Assuming that these have already been converted to numbers, cost is going to allow me to use its value, which is a number, to do something. In the last one, we have not used this function yet, but we will. Len. Len is short for length, right? So length equals the length of whatever is inside here, right? So currently it's a string, right? And it's going to tell me as a number how many characters are in that string. So for example, take this string time. The length of time would be 5 because time colon. Our colon counts as 1 as well. It would return a usable value, which would be 5, that we could use. So, why is all this helpful to us? What can we do with it? What's the power of this? Well, let's take a look at an example, and an example we've used before, right? So height. Now, we haven't used height in the problems that I've had before in VS Code, but we've done very similar things. In the top part, initially we start with saying, hey, height's a variable, and its value is an input, whatever we enter. The value of height is going to be a string. We then pass height to a new variable, and what we say is, hey Python, height is now equal to an integer, and we convert that, which then the value of height is now an integer. We have done this in 2 lines of code, but there's a better way. On the bottom here, we have created a variable, same as above, called height, and its value is equal to input, but our input is being automatically converted to an integer in the same line. In this code, it does the same thing as the above, but instead of typing out 2 lines, we have 1 line of code. Let's take a look at a more deeper example, a longer example of how this works. In our code example, I am trying to find the cost based on the number of days that we stay at a place. Okay, so on the left is what we've been working with. Okay, I have a variable called cost that starts off as a string, and then we pass that down and we convert cost to an integer. I have a variable called length, and that's going to be the number of days we want to stay. We then convert length into an integer. Because cost and length have been changed to numbers, that allows us to do our mathematical problem. Total equals cost times length. I can print off total. That is going to print off a number for us. But the same code of 6 lines of code is better done, more efficient, and does the same thing here on the right in 4 lines of code. We create 2 variables, which we have cost and length, and both of those are being converted to an integer as soon as we input that value. We do the same thing, cost times length, and we print off the total. Okay? This code is being better used because we are nesting. What is nesting? Putting things inside of each other, or in our examples here, putting functions inside of each other. Here's another example. Now in the previous slide, I introduced very quickly length, or the len function. Now in my example, I am trying to find the sum of the input length based on the number of letters. Okay, so we have our 2 variables, word and color. In both of those, we are going to enter a random word and a random color. What we do then in the next 2 variables, length 1 and length 2, is that value is equal to the length of the variable word. All right? So if in the random word, if I say hello, how many letters is that? H-E-L-L-O, 5. Length 1 is equal to 5. Length 2 is equal to the length of whatever we said for color. I can then do my mathematical problems adding together length 1 and length 2. Okay, the same code is on the right, but instead of having 6 lines of code, once again, we've done it in 4 lines of code. Now, this code, if you didn't catch, is going to throw me an error because we don't have a variable called length 3, right? We don't have that. But ideally, you could create a variable called length 3 equals len input, enter a random food, and it would do the same thing. We are putting input inside the length function. So all it's doing is it's collecting the length of whatever we enter, and it will allow us to print off the same value. So how many letters do we have in total? All right, so very briefly, throughout my code, you've seen me do a few things. I've given you guys not necessarily projects yet, right? But I have typed out problems on VS Code. I've asked you to stop the video and actually try to code them yourself. Now, all of these in VS Code were gray text. Now, these gray texts are called comments, or basically just notes in your code. In Python, there are 2 ways to create notes. The most common way is putting a hashtag in front of your text. This just tells Python, hey, skip this. And this is known as a single line comment. If you have multiple lines or a paragraph explaining what you're doing, yes, every line you could put a hashtag symbol, or instead using 3 quotes in the beginning and 3 quotes at the end is more appropriate for a multi-line comment. Okay, so in this example at the bottom, I have a variable cost, and cost is being converted to an integer, and then I'm just going to print off the cost times 0.2, right? How much did we save? But in between the two, I have created a comment, a note in my code. Going forward, everything we're going to be doing, I highly recommend that you guys make notes throughout your code. Like I've said before, use VS Code like a notebook. Okay, let's head over to VS Code and actually put nesting functions to use to create shorter code. As a bonus, take the code we did in the last lesson. Don't delete it. Take it and shorten your code. Shorten it to nesting your functions. I'll see you guys in VS Code. Alright guys, welcome back to VS Code. In the lesson, we talked about nesting functions, which is basically putting things inside of each other. I have taken two of the code tasks from last lesson and put them here. I want us to go through and try to refactor this code. How short can we make this code knowing what we know now? Try to pause the video here and give it a try. All right, I'm going to start off with the first one. Okay, so refactoring. So as you can see here, I am converting the input rental price to an integer. I am going to delete that, and we can just go int, and at the end here, we can put a closing parenthesis, right? Don't forget you need one at the end, right? Because a function has a set of parentheses. For days, I can do the same thing. I can delete days. I can go up here and I can just say, hey, you are also going to be a number. And I can do that like so. Now let's give that a try. So I'll turn this one off real quick. I will run our terminal. And you can see on the bottom. So let me trash that. That's better. Okay, just clean it up a little bit. Price of car per day, let's say $45. Number of days to rent, let's say 6 days. There we go. The same output, right? Total car price of $270. All right. Okay, so I was able to refactor that by taking away 2 lines. Okay, let's give the other one a shot. Okay, so in these 3, right, we are just converting those inputs to numbers. We don't need those, right? There is 3 lines gone. And for each of these, I can just go int input. That's our first one converted. For our second one converted. And for our last one converted over to a number. Now, I could even go one step further here. Currently, I have it in 4 lines. I could actually take this and I could actually print that out. And that would mean there is no need to have the total variable. I've actually shortened that one to 4 lines. Now, it is good practice to keep that variable there, right? Just for the readability purpose, to understand, to see what's really happening behind the scenes. But you could make that shorter and have our same output. If we run our code, we will be asked for 3 weights of the packages. So the first weight, let's just say 45. The second weight, 35. The third weight, 25. There we go. With our discount, the shipment total is going to be 84. Pretty cool, right? Okay. I have 2 challenge tasks for us to try to work through. Okay? You guys can pause the video here because, guys, it's always great to try these on your own. I've broken them down. I've written them out. Try to use what you know, implement your own programs, and use the terminal as like a helper. If there's any problems, it's going to occur and tell you in your terminal. Try to pause the video here and work through these 2 exercises and see how it turns out. All right, what I'm going to do is I am going to work through these. So I'm going to give a bunch of space here. All right, in our first exercise, I'll even put more space. There we go. Clear the other question out. We want to create an expense tracker. This tracker needs to collect the income from the user and collect their different types of expenses, such as food, rent, and any other extra income. Or should I actually rename this to expenses? All right, because that's what we're trying to do, right? And then we want to get the total amount left after all these expenses and print off that remaining total. So the first thing, we need to collect an income. So creating a variable, it's going to be an integer and it's going to be an input. Okay. Now this input, we can enter your income. Okay, so I've gotten the income. Now we want to collect 3 more inputs. One for food, one for rent, and let's call the last one extra. Okay. Now all of these, we could type these out. Okay, to save a little time, I'm just going to put these 3 here. Okay, and let's just change the string values. So enter your food expenses. We can call the next one enter your rent. And enter, let's change that to any extra expenses. There we go. Okay. We can now subtract these from our income variable, right? So the best way, right, is to store this in its own variable. So we can create one called, once again my spelling, remaining. Let's say remaining is equal to our income minus food, minus rent, minus extra. Okay, and then when we print this off, okay, our string will go here. So you are left with, and we will put you are left with remaining. All right, so our variable remaining is going down to be printed off. Let's run this program. And we're asked for our income. So let's say you make, I don't know, $2,500 a month. You spend $450 on food. Your rent is $800. And any extra expenses, you put back $300 for that. That shows we are left with $950 after our 3 expenses from an income of $2,500, right? So what you can do is any other code you've been making, go back and try and refactor it, or even create a few of your own problems. You could do expense tracker, trip tracker, anything that takes an input and we need that input to be an integer. So try to create a few of your own. I'll see you guys in the next lesson. All right, guys, welcome back to lesson 5. This lesson is going to be a little bit of a longer lesson, and we are going to be working with conditional statements or conditions. Now, a condition in Python, or any language for that matter, is checking if something is true. If it is, we want to do something. Otherwise, if it's not true, we are going to do something else. Now, it's important to note, a computer only understands 2 things, ones and zeros. And I want you to imagine the number 1 as true, and the number 2 is false. So really, a computer is just checking for conditions which allow us to run code. Great. All right, so as I mentioned, a condition can either be true or false. This is known as a Boolean value, and a Boolean value is either true or false. But this is also a logical expression. We are using logic to check if something is true. And if it is true, we want to do something. Otherwise, we know it's not true. We are going to do something else instead. Let's take a look at a brief example of how logical expressions work. So, in this example, I am checking if our variable available tickets is greater than the variable sold tickets. If it's greater than sold tickets, then we would get true. So, take a look. How many variables do we have here? 1, 2, 3. In variable 1, available tickets is an input that we are converting to an integer. In variable 2, sold tickets is doing the same thing. It's an input that we are converting to an integer. Now here's where it gets good. In our third variable, I have called enough. Enough is equal to this: available tickets greater than sold tickets. This is a logical expression. If available tickets is indeed greater than sold tickets, and we print off that variable, you can see the output in our terminal is going to be true, right? So imagine we enter 100 as the number of available tickets, and we also enter 75 as the tickets sold. 100 is greater than 75. That would give us the Boolean, the output of true. Okay, so working with conditions, we use many different operators. These are conditional operators. These are logical operators. Now, everything on the bottom, you guys know. We've learned this. We have been using this. Everything on the top, these are our new operators when working with logic or conditions. If you need to take a minute to pause here, do so. We start off with, just like in school, we have the alligator, right? The alligator mouth is what I learned with it, right? So greater than and less than. We can also check if something is less than or equal to. Or, right? So only one needs to be true. We have greater than or equal to. And here's a key point that is going to throw a few errors for you. In a condition, we always use two equal signs to check if something is equal to something else. Two equal signs. And we can also check if something is not equal by using an exclamation point with our equal sign. Two more operators we have when working with logic. We have these two special words in Python, okay? We have and or. Okay, so and is just like English. If I say, I like pizza and ice cream, it means both, two things. So we use and for when two conditions need to be true at the same time. They both must be met in order for our code to work correctly. Then we have or. Or is also just like English. If I ask you, do you like pizza or ice cream? I am looking for one answer. I am looking for one of those to be true. We can use or when only one condition needs to be true. So, take a look at our code example at the bottom. I have my variable available tickets, just like in the last slides. we are converting this input to an integer. So number of available tickets. You can enter a number. Then we have a buy more variable, and its value is a logical expression. So it's going to print true if available tickets is less than 75 or available tickets is greater than 500. Now I know what you're thinking. Why would you buy more tickets if you had 500 tickets? Great question. All right. This is just to show us here how a logical operator such as and or can actually function. Right? So this needs to be true or this needs to be true. They do not both need to be true, just one, because we're using or. If we had the logical operator and, then both of those must be true in order for the value to be true. All right, what we've just looked at is the intro to conditions. Now, how do we really check if something is true in Python? Well, we need to create and structure conditional statements. So, as I've mentioned, right, a condition only runs if an expression is true. Now, this is the code that we will be using here shortly in VS Code. And we can start off with our keyword if. Whatever comes after if is known as the expression. Inside. Now, what do I mean when I say inside? So, let's take a look at two things. We start with if, we have an expression. After our expression, we use a colon. All right? And then everything after the colon is inside of our condition. And specifically, you could do two things here. One, you could use the spacebar 4 times. Or what I find easier and what I use is press the tab 1 time. That automatically puts you where you need to be. Okay? If you use a colon, which you need to, and you click the enter or return button, it's automatically going to put you inside the condition. Okay? So, if this is true, this code inside is going to run. All right? Now, we are putting things inside of each other. Think of our last lesson. What did we talk about? We talked about nesting, putting things inside of each other. Okay? So, every conditional must start with if. All right? That's a condition. If we only use if, that's fine. But sometimes we want to have other code that would run if that is not true. That is where this comes in. All right? If I'm starting my condition here, so if this is true, run this code. Else, run this code instead. Else is like saying otherwise, right? So if the first condition is not true, it's obviously false. We would run this code if that condition was false, all right? When working with conditions, everything is nested or everything is inside our condition with 1 tab. Our conditions always end with a colon. We put that after if, we put that after else. When we click enter, it'll automatically tab in where we need to put our code, which is going to run when that condition is met. Take a pause here, screenshot here. Remember, you do have access to all of my slides that I'm showing, so use these as you're working through your problems and tasks in VS Code. All right, here's a condition in action. Okay, so in my example, the user enters a type of music. If the user enters rock, Python replies with AC/DC. Anything else entered, Python replies with Eminem. Okay, so I've clearly put two very different types of music. I've put 80s, AC/DC, rock and roll, and I've put modern day rap with Eminem. Okay, so if we start off with collecting input from a user, we have our variable genre, which is going to be an input. And Python is going to ask us to enter a music genre. I can then begin by building my condition. And I can use my variable in the condition as well. So what this is saying, right, is if genre is equal to rock, then we print off AC/DC. Otherwise, we print off Eminem. Now, I'll change the wording of this to help break it down more. If input is equal to rock, okay, that's what genre is. Our condition is checking if the input, which is named genre, is equal to rock, then we print off AC/DC, else or otherwise we print off Eminem. So in my music genre, I enter rock, then our output in the terminal is going to be AC/DC. Remember, key thing, if something is true, when we're checking for that, we always use two equal signs to evaluate that condition. Okay, so let's take a look at this in the reverse, right? So remember that the exclamation point and equal is to check for something that is not equal. So imagine your iPhone, you're entering your password. Your iPhone knows what your password is. Anything else, it's not going to allow you to pass. So in this example, it's sort of working the same way, right? Password is the variable that we created that is going to ask us input to enter our password. And what our condition is saying is if password is not equal to 7753, then we print incorrect password. Otherwise, we entered the correct password. It would say, welcome back to your account. Let me reword that. All right, so password is being used here in our condition. Whatever I enter into password is being passed down to our condition. So if our input is not 7753, we print incorrect password. Else, it must be 7753. We can print, welcome back to your account. So check out my example on the right. If I enter 9983, the input is not 7753. I entered something else. It's going to output in the console, in our terminal, incorrect password. That is how I could use the not equal operator to check if something is not equal to something else. All right, that wraps up our slides on conditions. Now, we need to go and implement this and use this. Let's head over to VS Code. I'll see you there.
Hi guys, I hope you're getting immense value from this course I've put together for you. Just a reminder, remember, I'm not getting paid anything for this entire course. So to help me out, you guys can head over to the platform that I'm paying to host for you and utilize it, engage, get higher quality content from me, and get all those guides. It's still free, absolutely free. It's the first link in the description, right? Head on down there. That really helps me as I release more of these courses to help you guys go from A to Z in Python. And I mean, if you really don't want a course, that's fine. okay? It's still free. I don't know why you wouldn't, but if you don't, okay. The first link in the description, I'm gonna give you guys that handcrafted Python guide that I made because that guide I made for this course. You're not getting the most of the course if you're not using the guide. It pairs perfectly. That's also the link in the description. You don't need to go to the platform, just head there and get the guide. All right, I hope you're enjoying this content. If you are, please do me a favor, click the like button and subscribe as I have weekly content out dedicated to helping you grow. All right, back to our lesson.
All right, guys. So here we are in VS Code. Now, in the lesson, what we're working with is conditions, right? And remembering a condition is checking if something is true. If it is, we do something. Otherwise, we do something else, right? And a condition is, other cases, is going to return the value, right, of true or false. So I've actually put together 4 problems, all right? And we're going to look at the first 3 right now. Now, here's the part of the lesson where it's best, if you're looking for a good challenge, to pause the video and actually read through these and try to code these out using the previous slides to help you and everything else we've learned so far. All right. Now, we can actually start off by coding our first problem. I'm going to put the other ones away because I don't want to see them right now. So in the first program, we want to create a discount program. And we want to ask the user 2 different questions. In the first question, we're going to ask which type of trip are they taking. And in the second question, I want to ask for the expected trip cost. Then we can create a condition. If the trip is a business trip and the price is $1,200 or over, we want to return true. Otherwise, it's going to return false, right? And then we can print off if the customer gets a discount or not. Now, we don't need to create a conditional statement for this one. We can use that as a value for our variable. Okay, so let's code this one out. I'm going to start off with number 2, right? I want to ask the user a question. So anytime we are getting data from the user, we are using our input. So let's call this variable trip type, right? And that's going to be our input. Okay, so ideally here, I want to ask the user, is your trip business, leisure? That's not right. Leisure or personal. Okay. And ideally, right, we want to convert this to lowercase. Okay. So whatever the user enters is going to be projected as lowercase. Right. That's what we introduced at the beginning of this lesson. Right. Lower, we have our upper, and we have our capitalize method. Okay, in order to ensure that whatever we enter here is lowercase, we can use our lower method. Okay, next up, we want to get a price, right? And we know that the price is going to be an integer, and it's collected through input. So int input. I am nesting my functions. And right here, I could say something like expected trip cost. Just one space. Looks cleaner. All right. Now we want to basically get a value. Okay. And it's either going to be true or false. Should we give this person a discount based on these requirements? Right. So if the trip is a business trip, and the price is $1,200 or over, we can return true. Otherwise, that is going to return false. So we can do this through a variable, right? And if you make a variable, call it whatever, right? So discount, I can check. So I can check if trip type is equal to business, right? So this is the same thing as saying, right, if we did that, okay? But I want to keep this as the value to my variable, okay? And, okay, it's a logical expression because two things must be true, okay? So, and our price is greater than or equal to 1,200, okay? So if both of these are met, we will be output with true. If one of them is met and the other is false, we will be outputted as false. Okay, so if I try to print this off here, right, and we say like customer, let me get the box away, receives a discount. And I can put my two dots. And then I'll put in the variable of discount. Okay, so I'm going to run this 2 times to show you if it's true and if it's false. Okay, let me run my terminal out. Okay, here's our first question. So let's ensure that the first one, and just to show you, right, I'll do uppercase business. Trip cost, 1,000. Boom. So, although I entered business and it was converted to lowercase, the first condition is met. But the price was less than 1,200. So it produced the results of false. Okay? Let me run the program again. This time, we'll do business. And we will say 1,500. Now both conditions were met. Okay, the trip type was business, the price was 1,500. So our customer receives a discount, true. Okay, and so that's our first type of condition. I can store that in my value. All right. Now let's spend some time actually creating these conditions. Okay, so I'll cancel that out. I'm going to bring up my other one, and I can just go out for this one. We don't need that. All right, so in the second problem, what we wanted to do is we want to allow the user to enter a special discount code. If the discount code is equal to, you can create your own, but I said winter 23, then we give a 20% discount. Otherwise, we want to say the code is not valid. Okay, so here's creating our first actual condition. Okay, so I'll create a variable. This can stay lowercase for now. And its value, right, is going to be input. Okay, and I can say enter your code here. So here is where we're collecting information. Now we want to create our condition. And I'm going to say if input is equal to our code, we want to do something. So if code is equal to winter 23. Okay. Now remember, in our conditions, when we're checking if a value is equal to something, we use 2 equal signs. And we always end a condition with a colon. That way, when you click return, we are automatically tabbed inside our condition. Okay? I'll run it a few ways to show you the errors that would happen. Okay, so anyways, if we print this off, okay, you get a 20% discount. Okay, cool. Otherwise, else, I can print off something else. And I can print off, you don't get a discount. Okay, So let's check out the code working how it should. And then I'm going to show you a few possible errors we'd get. So enter your code. I will say hello. Boom. You don't get a discount. We run our code and we enter the correct code. You get a 20% discount. Right? Now, a reason for the colon, right? So I delete the colon. I run my program. Boom. Line 28, we get a syntax error, and it says, hey, Python was expecting a colon in this position, right? Another popular error that we could get is called an indentation error. So here we go. Indentation error. It says expected an indent block after the if statement on line 28. So after the if, it expects an indentation, right? And that's why our colon is so important. It automatically indents that for us. If we have if we have one equals, I run it, right? I get a syntax error, and it says maybe you meant two equal signs. Well, we did mean two equal signs. Cool. Let's trash our terminal. I can just turn off this. I can keep my code because it's not going to ask for anything. I am going to go down here to our third problem. Okay. In the third problem, we want to create a program that recommends a trip type. Gather the trip cost from the user. And if the cost is less than $350, tell the user to go on a staycation. Right, a cheap trip. If the cost is over or equal to $350 and less than $1,000, we can tell them to go on a road trip because they got some funds. And lastly, if the cost is over $1,000, tell them to catch a flight to the beach, right? Because, well, they have some money for a flight, all right? Important note here is I want to end. So no matter what, it doesn't matter what trip you go on, I want it to print have fun at the end, okay, or print off something, okay? So let's gather the trip cost from the user. So I can say cost. It is going to be an integer, we know that, and it is going to be an input, okay? And then our hint, right? So our hint would just be enter your trip funds. I don't know. Enter your trip funds. Okay? And then we can go forth and make a bunch of conditions. So if the cost is less than $350. So if cost is less than $350. Oh, that's $250. I said $350. Then we can print off, what do we want to print? I'll just say go on staycation. So go on a staycation. Cool. If the cost is greater than or equal to $350 and the cost is less than $1,000, right? So both of those must be true in order for this to run, right? Our print statement here. So we can print off go on a road trip. There we go. Okay? And then our last condition is very similar to the first one. If the cost is greater or equal, okay, to 1,000, then I will say something like pack your bags, catch a flight. Oh, do you see that? So I just, first off, bags. Type that on the outside there, so I'll just cut that, paste that inside, pack your bags. Now, the note I said, right, is no matter what, I want to print have fun. So anything outside of the condition would automatically run next. Okay? All of our current print statements are only executed if that condition is met. if we have a normal print statement here on the outside, it's going to run no matter what when that condition ends. So have fun. Okay? Now let's give it a try. Let's run our code. I will scroll down here. All right, so winter if code is not defined. All right, I will deactivate that. Turn that off. Okay, run it again. Enter your trip funds. All right, so let's say I have $650 available. There we go. Go on a road trip, have fun. I enter 1,100. Pack your bags, catch a flight. Also, have fun. And finally, you have $80. You shouldn't be doing much. Go on a staycation, have fun. All right, so our conditions are checking if each of these are true. If one of them is true, then we are going to print off that print statement, that print function. Cool. All right, let's move on to our last one. So the last one, you guys can pause the video here if you want to give it a try, okay, which I recommend you do, right? Practice, find our errors. Okay, so in this problem, we want to create a program that gathers bag weight in kilograms and also either domestic or international from the user. So are they taking a domestic trip or an international trip? If the weight is less than or equal to 18, then the price is $25. Otherwise, the price is going to be $75. Then we can check if the destination is a domestic or an international destination. If it's a domestic, I want to add 300 to the price. Otherwise, add $750 to the price, and we want to print off our estimated cost. Now, you might be thinking, if you've already got started, well, I didn't create a variable called price on the outside. That's right. We're going to do it slightly differently. Okay, there's two ways to do it, all right? But I'm going to do it the shorter way, which is how it should be done. Okay, so let's create two variables. The first one will be bag weight, and bag weight is going to be an integer, right? Because I need to find the weight of the bag. So I'll say here, enter weight in kg or pounds, okay? And then our other one, right? I want to get a destination. So our destination is going to be a string. Okay, and it's gonna, or a user is either going to enter domestic or international. So I'll just say enter domestic or international. Okay, cool. Now we can go through and we're gonna do the first check. The first check I've actually put here. If the weight is less than or equal to 18. Okay, so how can we do this? Let's create a condition. So if the bag weight is less than or equal to 18, okay, then my price is going to be 25. So I'll just create a variable here, and I'll just say price is equal to 25. It can be done within the condition. Else, it must be over 18, and I will just say price is actually going to be equal to 75. Okay, let me scroll down here. There we go. So our code, remember, runs top to bottom, and it's going to execute those lines in order. Our first condition is being checked, and it's assigning a price value to if you're under 18 pounds or kilograms, and if you're over that threshold. Now we want to check if our destination is a domestic trip or an international trip. Okay, so let's create another condition. We only really have to check one because otherwise it must be false. If, what do we have here? Destination is equal to domestic. Then I want to say our price, right, is going to be 300. I want to add 300 to the price. Now, I'm going to show this in two ways. In the broken down form, our longer format, I could say price is now equal to the current price plus 300. Okay? Let's use an elif as a bonus here. Okay? So I'll say also if destination is equal to I'll keep good practice here, international, then I can say my price. Now the other way to do this is instead of just repeating yourself, price equals price plus 300, I can basically say the current price plus equals 750. And that's the shorthand version. It takes the current price, it adds 750 to that, and it just equals that value. Okay? And then I'm also going to put an else, and I'm just going to say else print spelling error. All right, and that's kind of our condition there. Okay? Now this could be done without else, right? So I'm going to print off for now, and I'll show you what I mean. Okay, so I can kind of print off something like ticket price. And we can print off, well, I just want the price variable, okay? We can run our code. Let me give us some space here. Enter weight in kilograms, let's say 23 kilograms. I am taking a domestic. Well, I can't spell, which I should have just let that go through to show you. Right, our ticket price is $3.75. Okay, I run it again. I enter 14, and I'm going to say international. Our ticket price is $775. Now, let me do something like 14, and I will say DST. Spelling error. Okay, so what's happening is it's keeping the ticket price of $25 because the bag weight was under 18. But it's not adding on the ticket price because it's only reading for domestic or international, right? Now, we could do this slightly different. I could take away this, and I could just say else. Price plus equals 750. So you either enter domestic correctly or anything else entered, it's automatically assuming it's an international trip. We can run that just to check, right? And I'll run it a few times to show you what I mean. So I enter 25, I enter international, right? So 825. Okay, if I run that again, and let's say 10, and let's say Apple, see, it's automatically triggering the else. Okay, so I could type in anything, and that could present problems in the future, right, for like spelling errors. I could type in anything, and it's going to assume I'm taking an international trip. All right, amazing. So we just worked through 4 conditional statements. All right, get creative. Find a hobby you like and use that hobby and try and create your own conditions. Right? If you're an avid skier, do something that relates to ski slopes around the U.S. If you're an avid, motorbike enthusiast, try and create conditions around a hobby. Right? It's easier to create these if we're doing it around something that interests us. All right? Amazing work, guys. I will see you in the next lesson. Try a few problems on your own. I'll see you then. right, guys, welcome back to lesson 6. In the last lesson, we worked with conditions, remembering if and else, right? So if something is true, we do something, otherwise we do something else. In this lesson, we are going to be talking about nesting conditions. Now, do you guys remember this, right? What did we do here? Int input, right? We nested. And remembering that that means putting things inside of each other. So input is inside of int. That number is converted automatically to an integer, right? Now, in this lesson, we are going to be talking about how we can nest our conditions. But first, I would like to introduce to you guys 3 new functions that we will use throughout this lesson. These are 3 special string methods. A method, for now, is just a function, okay? It's another style of function that we will use at a later stage, but for now, just remember it's a function. And the question becomes, how do we convert an input that's a string to all lowercase or all uppercase? Well, we have a few ways we can do that, okay? So these 3, dot lower, dot upper, and dot capitalize, these are the methods that allow us to do so. And the dot lower function, that converts the input to all lowercase. So even if a user enters all uppercase, the output will be converted to all lowercase. The upper function does the exact opposite. If you enter something as all lowercase, it converts to uppercase. And the last one is kind of a bonus. We have capitalize. And capitalize will capitalize the first letter of the string. But if you have multiple words, it's not going to capitalize every word, just the first word in that input. Okay? Few things to note. Okay, the first thing is a method, it has a dot, it has a period before the function. And you can see here in all of these, right, I have a dot. Now, a method must be linked to a variable to work, which means the variable would come before the method. And we're going to take a look at this in the coming slides. Great. Remember this? I'm going to come back to this, okay? So we have lower, upper, and capitalize. But let's take a look at how nesting conditions actually works. So here's kind of like a flow chart that I've created. If you guys want to pause this, I highly recommend it. Okay, so pause it, read over it, screenshot this, okay? Now, on the outside, okay, here's the outside, if my line was straight. We have our condition, if, else. And we worked with this in the last lesson, right? So if this is true, then we run the code inside. But the code inside is also another condition. Okay, so let's take a look at over here, right? If this is true, if the first one is true, then it checks if this is also true. If it is true, then we can run the code that's inside this condition. Else, that means that our if was false, right? And we would run this code instead. Now, what happens if this first condition is false? We don't enter and check the second condition. We skip right to else, and we would run this code instead. What this is it's a condition inside of a condition. we check for our first expression. Is it true? If it is, then we check if the second expression is also true. Right? Now this becomes a very powerful tool, especially going forward. Once we approach our first project that I'm going to give you here in a few lessons, we will be using this as an instrumental part in completing that project. Okay, let's take a look at how this can work in action, in theory. Okay, so take a look here. I'm going to read through our example, right? So if the user enters beach, then Python replies visit Thailand. If the user enters anything different from beach, Python will ask the user warm or cold. If the user enters cold, Python replies with a Japan ski holiday. Anything else, Python replies with a mountain holiday to the Rockies. Okay, so let's start at the top. We gather our input. Okay, now you can see how I'm using the lower function. It is linked to our input. Right? So whatever I enter into input, it will automatically all become lowercase. And we want to make sure it's lowercase, especially when we're checking for a condition, because all users could enter something different. We want to keep it neutral, so we're checking every input as lowercase, for example. So our destination, we want to enter a travel destination. If our destination is equal to beach, we can print off visit Thailand. Otherwise, else, we did not enter beach. That means we are going to ask the user for another input. It's an input inside of a condition. And we're asking the user, would you prefer warm or cold weather? So if, now notice that this if is inside our else. Okay, it's nested inside. And if you forget how to nest, it's one tab or 4 spaces. So if dream is equal to cold, we would print a Japan ski holiday. Otherwise, you must have entered warm, then we would print a mountain holiday to the Rockies. I want you guys to guess, what is our output to the console going to be? Is it going to be visit Thailand, a Japan ski holiday, or a mountain holiday to the Rockies? Now, I know some of you said a mountain holiday to the Rockies. But why? Right? Why is it going there? When really I entered cold, right? I entered cold, so ideally input is equal to cold. It should be saying a Japan ski holiday, but instead it's saying a mountain holiday in the Rockies. That's weird. It's not weird, actually. We entered capital C for cold. We forgot to make our input to lowercase. In the condition, we're checking for cold, and all of that's lowercase. So in theory, Python is actually printing off the correct answer for what it's told to do. We need to make sure our input is lowercase. By adding our .lower method, our function, it converts cold to lowercase, and that way our condition is now going to print a Japan ski holiday. Okay, here's kind of all of our logic, right, of what's really happening here. Okay, now there's one more that I want to introduce for conditions. Okay, this is known as elif. Okay, so right here is elif. Now elif, it just means also if or else if. okay, if we're breaking that down and translating it to English per se, right? So if this is true, run this code. Else if this is true, run this code. Otherwise, neither of the above are true, we can run the final code. Now, the only two that accept an expression is if and elif. Else, we don't need to have an expression. In fact, we can't put an expression. Okay? Else, if the above aren't true, then it's automatically going to run. Okay? It's important to note that elif is always in between if and else. Okay, so over here, it must come after if because a condition always starts with if. And it must come before else because else is always at the end if needed. Okay, so sometimes we can have if and elif without else, that's fine. But the golden rule here is elif must come after our if. Okay, let's see that in action. Here would be using a full condition in action. Okay, at the top of our code we have our price input, okay, which is automatically being converted to an integer. We have our days spent is also being converted. Okay, so now notice what we have here. In our condition, I'm checking if our days spent is greater than or equal to 3 and also less than or equal to 5. Remember how we worked with our logical expressions. We have and. And means two. It means both must be true. Okay? If this is the case, we create a variable and we just say the price times 0.8, right? That is basically giving you a 20% discount because I'm multiplying the price input, price, by 0.8. Also if, else if, the days spent is greater than or equal to 6 and less than or equal to 9, then in that case, we get a 75% discount. Well, let me rephrase that. It's not a 75% discount. I am multiplying it by 0.75, which means it would be a 25% discount. Okay? Otherwise, for all other days spent, there is no discount, and we just print off or return the price we got. Okay, here's a flow chart of how that's going to break down and work. Okay, so screenshot here, pause here, whatever you guys need to do. Okay, but it's the steps going through our program to get to the end. Okay, we check if our input was 3 to 5. If yes, we apply a 20% discount. Okay, our next condition, elif, checks if input was from 6 through 9. If it is the case, we can apply that 25%, and then any other input, then this is returned. We just print off the initial price that we entered into our program. Cool, guys. All right, let's take a look in VS Code now how we can create nested conditions with Python. I'll see you guys over in VS Code. All right, guys, welcome back. This has been a big lesson so far. What we have introduced is nesting conditional statements. Now, remembering nesting is when we put things inside of each other. So, for this lesson, when we put conditions inside of other conditions. Now, as always, I have 5 tasks or challenges here on my screen. I want you guys, if you're up for that challenge, to pause the video, read through, and really give this a shot, okay? And try to use everything we've learned throughout the course so far and our slides to help you through this and to solve these problems. If you're up for that challenge, pause the video here. Okay, I'm going to dive in. And to begin, I'm going to zoom in now. Okay, and I'm going to give ourselves plenty of room. So, number one, our first task is we want to ask a user if they want to watch a movie. And if that user says yes, we are then going to ask them what genre they want to watch. If they say comedy, we are going to tell them to watch the Hangover trilogy. I still love those to this day. Otherwise, we're going to tell them to watch the new Top Gun movie. If they don't want to watch a movie, then we're going to tell them to watch a TV series. Okay, so the first thing, we need to ask a user if they want to watch a movie. So let's create an input, and let's say, do you want to watch a movie? Great. Now we have our input. We can now create that condition. Now what's going to go inside our condition? What are we checking for? Well, we're checking if our input movie is equal to yes. Now, going with good practice to ensure that every measure is taken, we are going to convert this to lowercase, right? Because yeah, you're creating the code for yourself now, but in the future as a programmer, you're creating it for users to use. We can't anticipate what the user is going to enter. Is it going to be uppercase, lowercase, capitalized? By using lower, we are ensuring that no matter what they enter, it will be converted to lowercase. So, if they want to watch a movie, we are going to ask what genre they want to watch. And we can also collect this through input. And I can say enter a genre. Cool. Now that we have their genre, we can check if that genre is equal to comedy. Okay? And just like before, let's just make sure that no matter what, we are safe. Lowercase. Okay? So if they enter a comedy, we are going to print off watch the Hangover trilogy. Cool. Otherwise, else, we are going to print off to watch the new Top Gun. Cool. And that brings us to our final one. If they don't want to watch a movie, we need to tell them to watch a TV series. So I can come to the outside under my initial conditional statement. And we can say else. And I'm going to print off watch a TV show. Just like so. We have our code done. Let's put it through the checks. So, putting it through the checks, I'm going to run it. Do you want to watch a movie? Yes, I do. What genre? I'm really going for action. We should see Top Gun. There we go. Watch the new Top Gun. Good. If I run it again, do you want to watch a movie? No. Watch a TV show. There we go. Okay, read through our condition. Check what we did. Experiment with your inputs. All right, nice. So there was our first one. I am now going to come down. I can take away all this. I'm going to come to number 2, and we'll give ourselves some nice space again. Okay, we want to ask the user if they want a hotel or resort. If they want a resort, we want to ask them the max price they're willing to spend per night. So let's start off with accommodation. And let's say that's our input. Let's say resort or hotel. And let's ensure that everything is lowercase. All right, let's begin that condition. So if our input is equal to resort, we then want to ask them a max price. So price, that's a number. So let's say max price is equal to int input, right? I am nesting my functions. I'll say enter price per night. Cool. If max price is greater than or equal to 350, I want to do something. We want to print off, and we want to tell them to go and book at the Six Senses Resort. So book at Six Senses Resort. Else, their budget is under 350. We can tell them to book at Four Seasons. Book at the Four Seasons. Great. Now finally, if they don't want a resort, we are going to put our else, right? Otherwise. Because otherwise, we want to tell them to book at the Hilton. So go to the nearest Hilton. Okay? So look at that. We are nesting our conditions, and I'm asking for additional inputs as well. Let's run it. Let's see what happens. So in our terminal, I am going to say resort. And I'm going to say, how much do I want to spend per night? Let's say 200. Book at the Four Seasons. If we run that again and I enter something over 350, so 400, book at Six Senses Resort. Okay, that's us using our nesting on two levels, our functions and also our conditions to evaluate what the user has input. All right, that was number 2. Moving along, I'm going to come down here. I'll take away some of this space and I'll give us more space. Okay, there we go. So, number 3, we are asking the user for 3 different prices for 3 different products. Let's start off with that before I get carried away. Okay, so let's say item 1. We are getting the price. So I'm going to do int input, right? Because we need to get the price to do any type of equation. So enter the cost for item 1. Now, because these are very similar, all right, I have 3 products. I'm going to take that and I'm going to paste it 2 times. We need to ensure that our variables are set differently, and then our placeholder text, we also want to give ourselves a better hint. Okay? So now I'm going to check for 2 things here. Okay? But I can't really give discounts until I have the total of all the items. So before we start any condition, I'm just going to add these items together. Like so. Okay. If the third product is the most expensive, give them half off their total. So, we need to figure out how we can determine if the third item is the most expensive. And to do this, we will use a condition with logical operators. So, if item 1 is less than item 2, okay, and item 2 is less than item 3, that means item 3 is the most expensive. Okay, so I have 2 conditions, both of which must be true because I'm using and, right? Then we can take our total, and we're going to say, hey, total is now equal to total times 0.5, because that would be half off. You could divide that by 2 as well. Okay, so we have that. And then I can just print off, I'll say discount. There we go. All right. If the first product is the most expensive, we want to give them 66% off. All right. So how can we do this? Well, let's create a new condition. And let's say if item 1 is greater than item 2 and item 2 is greater than item 3. All right, so if item 1 is greater than 2 and item 2 is greater than 3, then we can take our total and we can say, hey, total now equals total times, we want to give them a discount of 66%. What do we multiply that by? That's a lot off. I'm going to multiply that by 0.33. Right? That gives us our discount after 66%. And I can print off, once again, discount. All right. Finally, at the end of that condition, I am going to print off their total. So total, and I'm going to print off their total, like so. All right, that's a lot happening there. Let's run it. Let's watch our code work. Cost of item 1. Let's say the cost of item 1 is 400. Cost of item 2 is 300. See how I'm going down here? There we go. I get a big discount, right? Because our item 1 was the most expensive. Okay, so what we got is our discount. Okay, I'll run it again. Let's say I'll do it in reverse. 200, 300, 400. There we go. I also got a discount. Okay, so 4, 5, 6, 7, 8. It would be 900 originally. I am getting a discount. And our above one, it would also be 900. But this is a pretty sharp discount we're getting. All right. Let me close this out. I'm going to turn these off. And we can solve and move on to number 4. Alrighty. So, for number 4, we want to get a cost of an item in the current time in our form from a user. If the time is from or between 7 to 9, then they get a 20% discount. And we want to tell the user their new total. If the time is from or between 10 to 6, there is no discount for that, right? Early bird gets the worm. And then any other time, we need to tell the user that, hey, we're actually closed. So I'm going to get a cost, and I'm going to say cost is equal to int input, right? And we're going to say enter the price. Your strings can be anything, right? And then we want to get the hour. And I'm going to say int input here. Now I can just say enter the current hour. We got to think about this now, right? Because parts of the world we use 12-hour time, and then other parts are 24-hour time. When programming with Python, it's best that we just use 24-hour time, okay? Because then that makes it significantly easier on us and our conditions as well, right? So if you don't know 24-hour time, bring up a quick Google search of it, okay? But I'm going to use 24-hour time for this. So if our hour is greater than or equal to 7, or, well, I'm not going to say or, okay, because or does what for us? Or is going to check that only one is true. But in order to apply that discount, they both must be true. So if our hour is less than or equal to 9, that's the sweet spot for our discount. I can take my cost and I can say, hey, cost is now equal to our cost with a 20% discount. And then I can print off my total. So total. And you can see here that these dots, my colon is meant to be inside. Okay? And I'm not going to have my total per se, right? But we do want to see our total. But our total is actually held in the cost of our input, right? So our cost. All right. Can you guys do the next one on your own? Yeah, let's try. Okay, so I'm going to do it with you. If you didn't pause there, that's all right. So if our hour is greater than or equal to 10, right? And our hour is less than 6 p.m., which is 18 in 24-hour time. Well, we're not going to give a cost discount, right? They just pay standardized pricing. So print total, and then we can say cost. Okay, now what we've introduced as well is I want this all to be one condition because I am going to have an else here. So instead of saying if, I'm going to say also if, elif, right? And then else, any other time, we need to tell the user that, hey, the store's closed. The store is closed, like so. Let's make that nicer. There we go. Okay, so one big condition. Let's check it. So the cost is $20. The current time is 8 a.m. Boom. I do get a discount. That's awesome. Okay, I save $4. That's 20% off of 20. If we run it again and I say $20, but my time is going to be 1 p.m., so 13, I still have to pay $20. I'm not getting a discount for that. Great, guys. This brings us to our last solution, or should I say our last challenge. Now, here we go. Our last challenge. We are going to gather a review from a customer. And the rating can be 1 being terrible and 10 being the best. If that rating is 9 or 10, we want to thank them. Also, if the rating is less than 9 but more or equal to 5, we are going to ask the user how can we improve. And we're going to print off what they said and also that we will work harder. Any other rating, which is going to be less than 5, we are going to say we are sorry to hear that. Okay, so let's get a review. Review. And because we are going to do something with this, we are doing our int input, so enter a rating. Okay, so if our input, which is review, is greater than or equal to 9, we are just going to say thank you so much. Thank you so much. There we go. Also, if the review is less than 9 and our review is greater than or equal to 5, we now want to ask how can we improve? So that's another input. So I'm going to say, let's call it improve. If I can spell right. Improve is going to be an input. Okay, so how can we improve? There we go. We are going to print off what they said. So you said, and we can print off improve, not import. And we're going to print off and say, we will work harder. Good. And then our final one, else. We got a terrible rating. okay? If we got a terrible rating, we want to say we are sorry to hear that. So I'm actually just going to take that from my notes, and that's what we want to have here. All right, so we have a condition. Inside our elif, we are asking for additional information for how can we improve. Let's give a rating that's going to trigger our improve input. So let's say we give them a 7. Enter a rating 7. How can we improve? Let's say the food wasn't that good. There we go. You said the food wasn't that good. We will work harder. Right? That's great. I tried again, and I'm going to say 10. We get thank you so much. Okay? So guys, spend time, read through the code that we've just made. Nesting is a very important topic that we are going to use throughout this course. Challenge yourself now in this lesson before we get too far ahead. Create your own conditions and create your own nested conditions. With our project that's going to be coming up here in a few lessons, an instrumental part of creating it is going to be using nesting and conditions. I'll see you guys in the next lesson. All right, guys, and welcome back to Lesson 7. In the previous lessons, we have worked with everything from collecting data to conditional statements and variables. Now, our next 2 lessons, we are going to be talking about loops in Python. And long story short, a loop is a way to repeat code until certain conditions are met. Okay, so when you hear loop, I want you to think about repeating code. Now, there are 2 types of loops. And the first loop that we are going to look at is called the while loop. And basically what the while loop does is while something is true, we repeat. All right, while something is true. Let's try and remember that. So, looking at how the while loop is set up. All right, here we go. Now, while something is true, we want to continue to run the code. And the loop only quits running when it becomes false. All right, so here is the setup for our loop. You can see our operator while, and then after comes our expression. Just like in our conditional statements, we have an expression. So while this is true, this code keeps running. And this code, all right, is inside our loop by 1 tab. Anytime I say inside, that means 1 tab. All right? And at the end of our expression, just like in our conditions, we have a colon, 2 dots. All right? We use these throughout programming. So far, we've used colons with conditions and now with loops as well. And then the first thing that's outside the loop, that is going to run as soon as the loop becomes false, or we break outside of the loop. Now, the while loop is really good for what we are going to be doing, and it's good for games or programs that require repeating until something becomes false. Here's an example that I've put together. Okay, so in this example, we are asking the user for a password. If the password entered is not equal to password 123, the code is going to repeat asking the user to try again. Once the user enters password 123, our loop will break or end, and it's going to print welcome to your account. Okay, so we start off, we have an input. and then I can pass my input variable into my loop. So while password is not equal to our set password, I am going to continuously print you entered a wrong password, and I am taking the initial variable password, which is input, and we're putting that in our loop. So every time this loop runs, it's asking us for an input if we don't enter the correct password. So how many times can this loop run? Well, it could run forever, right? It's going to keep repeating until we enter the correct password, right? Because while password is not equal to password 123, we are going to repeat the code that's inside the loop. As soon as we enter the correct password, we are going to print welcome to your account. Okay, so initially, if I enter the password Rambo321 ! We would get you entered the wrong password, try again, and here is where you would type another password because try again is input. As soon as we enter the correct password, so password 123, right? When I try again, I enter my correct password, we unlock the print function, which is going to tell us, welcome to your account, right? So initially I enter Rambo as my password. I then try again and I enter the correct password. We get welcome to your account. Pretty cool, huh? It's a way for us, we could create an authentication system, for example, kind of like here, or we could do a lot of other things with our while loop. Let's take a look at another useful tactic while working with this type of loop. So, take a look at this example. Read through the code, and I'm going to go through the example. The user will enter the cost of each item, right? And that's done here in our variable cost, which is int input. It's going to be an input that becomes a number. While the user does not enter 0, the code will continue to run. Once the user enters 0, the code will stop and take the total variable and multiply it by 50%, giving half off, right? So we have cost, and if we want to end our loop, I've put here 0 to end. So while the cost is not 0, we will repeat the code inside here. Okay, so by entering a few numbers, what do you think our output in the console is going to be? Okay, try thinking about that through. Now, before I move on, I'll cover a few things here. I have a variable called total. And total is what we call a counter variable. Its job is to keep track of numbers and increment or decrease as we go through the loop. So every time this loop runs, total, which was initially 0, I am adding whatever number I enter in cost to total. And then I ask for a cost again. And this process repeats until we break away from this loop. So let's take a look at it broken down. So here we go, okay? Total. Total is a counter variable. And what we're doing here, okay, this plus an equal sign, this is the same thing as saying total equals total plus cost, right? So total plus cost is now the new total. Total is now equal to the original total plus the new cost I have entered. Okay? So Once we enter 0, our loop breaks. Our loop will end. Initially, I will print off the grand total and whatever our counter variable is holding. Then I can take my total and I'm going to give a 50% discount. So I'm multiplying the initial total by 0.5. That's 50%. And I could print off my total with discount. So for example, if we enter this loop and I start off and I say the cost of the item is 5, then I enter 10, then 4, then 7, then 20, then I enter 0. 0 is going to stop my loop. All of these numbers added together, that gives us the total of 46. So every time this loop runs, initially, the first time the loop runs, total is 0. But I enter 5. So 0 plus 5 is the new total. This counter is now total equals 5. My loop runs again. Total is 5, so total plus 10. 10. That's the same thing as saying 5 plus 10. Total is now 15. And this process repeats until we enter 0. That breaks our loop. All right, in our final example, we also have a counter variable. Our counter is try, and try's initial value is set to 1. I want you guys to imagine you're taking an exam, and there is a question on there with a multiple choice answer. You can either answer A, B, C, or D. While input is not equal to C, so the correct answer is C. If you answer anything else, we enter our loop, and the loop is going to run. So it doesn't matter if you answer the correct answer on the first try. It took you one time to get the correct answer, right? So it's going to print off, it took you one try to get the answer. Tries, right? But if you get it wrong, then try, I'm going to add 1. So try is now equal to 2. We print wrong answer, and we are going to pass our input back into the loop, and it's going to say try again. I enter another wrong answer. Try, which is 2, I now add 1. So try is 3. We can try again through our input. Once we enter the correct answer, which is C, our loop is going to break. And we are immediately going to run the first code outside of our loop. It took you 3 tries to get the answer. And it's going to print off the number of times it took you. Right? So a counter variable is very powerful. It allows us to keep track of how many times a loop has run. All right, let's head over to VS Code and put loops to use and see how we can use them to our advantage. I'll see you guys in VS Code. All right, guys, and here we are in VS Code. In this lesson, we have introduced the concept of loops, which is repeating code in Python. And the loop that we're looking at now is the while loop, right? So while something is true, we can repeat a certain task or code. On the screen, I have created 5 tasks that we are going to work through here. I want you guys to read through these and think about how can we implement code which is going to allow us to run these programs. As always, if you're up for a good challenge, pause the video here and give it your best shot. Okay, I'm going to start off with number 1. So I'm going to zoom in, and I'm going to give us a bunch of space for our code. Okay, number 1. We want to create a mini-bot that accepts messages. The loop only breaks once the word done is entered. Every time the loop runs, we want to print off a message that says, "We got your message." So, right here, once the word done is entered, that means we need to collect an input. So let's start off by saying a message is equal to an input. Okay? And we can just say here, enter your message. Cool. Now we can use our while operator to begin constructing our loop. So while our message is not equal to done, we want to begin. Remembering our colon at the end of the expression, and we want to be inside the loop. So the loop is going to print off, "We got your message." We got your message. And then I want the loop to keep repeating. So because the only way to stop the loop is if we enter done. But right now, all that's going to happen is it's just going to print this off. We want to take our input and we want to put it at the end of the loop. So it's going to ask us again. All right? If I were to run our application, we are going to see, enter your message. Hello. We got your message. And it's asking us again to enter your message. Hello, Python. Apple. Enter your message. Done. Right there. We just broke the loop. Okay, we exited our while loop. All right, because we entered the word done at the end. Great. Okay, that's our task 1. I'm going to turn off the loop. I am going to bring up our next challenge, and let's give us some space here. All right, here we are in challenge 2. In this challenge, we want to create an account login. Now, the user actually has 2 passwords, either which can be entered to gain access to the account. Once the user enters the correct password, we want to greet them with, "Welcome to your account." All right, so we are actually going to be checking for 2 passwords, which means we are going to be using a logical operator. Do you guys remember the 2 logical operators we introduced? We have and or. And or. So let's start off and let's say passcode. And let's say passcode is equal to an input because we need to gather that from a user. And we can just say enter your passcode. Now that we've collected a passcode, I can introduce my while loop. And I can say while my passcode is not equal to, you guys can create your own passcode. What I'm going to say is 1, 2, 3, 4, and passcode is not equal to 4, 3, 2, 1. So I only need to enter one of these correct to be let pass. Okay? We are going to continuously ask for another passcode if we don't get them correct. All right? So instead of saying enter your passcode, I'm going to say try again. Okay? Now the first thing we want to run once we get out of the loop is going to be our print. And we are just going to print welcome to your account. There we go. Okay, so we have 2 expressions. And only one of these needs to be true, okay, with our and, because we are using our not equal operator. I'm going to run our code. And my first passcode, we will say 5555. Try again. 4355. Nope. 4321. Welcome to your account. Okay, I'll run it again and I will use the other passcode to gain access. 2345 1234. Welcome to your account. All right, so that's us using two expressions and a logical operator in our loop to check for two different passcodes. Pretty cool, huh? Okay, that's our second task. I'm going to close my terminal and on to challenge 3. Okay, so let's take a look here. The first 3 people to book are gifted with 20% off. Now, for every person, we want to print off congrats, that person's name, and also you saved 20%. Once 3 people have gotten this discount, we are going to print all done. Okay? So, how do we keep track of how many times our loop has run? Well, remember, we looked at counter variables, and a counter can store how many times a loop has done its job or ran. So I am going to create a counter, and let's just call it counter. Initially, it's equal to 0, right? And this is a variable, it's equal to 0. So I can say while counter is less than 3. I want to do something. Okay, so because Python starts on 0, I am saying, is it less than 3? Right, so 0, 1, 2. That is going to be 3 times it's going to run. Each time, we want to collect an input. So enter your name. Okay, we are collecting that input. And for each person, we want to print off congrats. Congrats. I will print off their name, and I will print off you saved 20%, like so. At the end of my loop, we need to increase our counter by 1 because the loop ran 1 time. So counter, which is initially 0, plus equals 1. The counter variable is now equal to 1. On the outside of my loop, I can print off all done once the loop ends. So, when we run this, we will get 3 names. I will enter my name first, Josh. Congrats, Josh, you saved 20%. Enter the second name, Sally. Congrats, Sally, you saved 20%. And our last name, let's say James. Congrats, James, and also all done. Right? So every time that loop is running, we are keeping track with our counter how many times it's ran. Once that counter hits 3, or technically 2, we will end our loop. It only allows for 3 to enter. Okay, so using a counter becomes very powerful. I can store data and I can store how many times the loop has done its job. All right, let's turn off this loop, close my terminal, and we are going to go down here to challenge number 4. So in this challenge, okay, a user must enter a programming language. So you have to think input. But they only get 5 tries. If the user enters Python, we want to print off how many tries it took them. Okay, so there's actually a few more to this than meets the eye. So we want to do a few things. The first thing is I want to counter, right? So I can call it tries. Now, I'm also going to be checking if they entered Python, which is going to be a string, but we don't know what this string is going to be yet. I know it's going to be an input, but we don't know yet. So I can say code equals an empty string. Okay, so I am going to give it something, not yet. Once we enter this loop, I can say while tries is less than 5, just like before, and code is not equal to Python. I can then start. So this loop is going to run no matter what, because initially tries is less than 5, so it's going to run. And our code is currently blank. It's an empty string. Now inside my loop, I can take my code variable that we already created, and I can alter this and I can change it to an input now. And I can say enter a programming language. Okay, so here I'm collecting that. Every time this loop runs, okay, I am going to take tries and I'm going to increase it by 1 to see how many times it takes. Okay, that's kind of our loop done. Now we need to check if that user has entered Python. So if code is equal to Python, then we want to print off the number of tries it took them. So it took you tries. Like so. Okay, so I'm going to enter my loop. Okay, and currently tries is less than 5 and code is left blank. I'm going to enter the programming language and I'm going to increase tries by 1. Now, we need to change one small detail, because currently, even if you get 1, so, okay, let's run our code. So, we are going to be prompt with enter a programming language. We are starting right here with our input. Initially, I will say Java. Okay, it asks me again. I am going to say JavaScript. Maybe that was it. Nope. Okay, I'll try Python. Python, right there. It took you 3 tries, right? It's storing how many times we did that. Let me try it again, but this time I'm going to enter Python as the first one. Python. Now, obviously, try is not spelled correctly, right? But it is keeping track of I did get it on the first try, right? So using counters to our advantage, and then we're using a condition to check what did we enter and outputting our counter value. Amazing. All right. In our next challenge, we want to create a train ticket booking program. That's a mouthful. The program begins when the user enters 0 and ends when the user enters 1. For every new train ticket, we want to print off the train ticket number. So for example, ticket 1, ticket 2, ticket 3. And we want to print off which number of ticket it is. So let's create a variable called train tickets. And let's say train tickets is an input. So enter 1 to book or 2 to end your booking. All right, that'll prompt us to do something. Now, I need a counter variable. Okay, so I'm just going to say I equals 1, right? Because no matter what, if you get a ticket, you have the first ticket. We aren't starting on 0. So I'm going to say I equals 1. While our input is not equal to 2, right? Because 2 ends the program. Then I am going to check if my input is equal to 1. Okay, so take careful note now. I am now nesting, We have a condition inside of our loop. So, if this is the case, the first thing I want to do is I want to print off the train ticket. So, train ticket, and I am going to convert here, right? We have a string. I want I to be there. So whatever my train ticket is, ticket 1, ticket 2, ticket 3. Then we can take I and we can increment it by 1. So I plus equals 1. Remembering in our loop that I am just going to take my input again and I am going to put this in my loop. Now this does not need to be in our condition, but it does need to be in our loop. We can run it. I'm going to enter 1 to book, so 1, train ticket 1, 1, train ticket 2, 3. Now I'm going to end it. There we go. We ended our booking. We broke out of that loop right there. And you can see that I've gotten 3 train tickets, 1, 2, and 3. All right, guys, that's great. So we just worked through 4 problems with our while loop, and we also used our counters in these loops as well. Let's head over to the next lesson, and we're going to introduce the next loop. If you're not feeling confident with the while loop, try to create a few of your own programs, all right? Practice, 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 especially as we get with nesting inside of our loop. This is going to come in handy as we get into our first project. I'll see you guys in the next lesson. All right, guys, welcome to lesson 8. In the last lesson, we introduced loops, which is a way to repeat code. And the first loop that we looked at was the while loop, right? While something is true, we repeat that task or that code. In this lesson, we are going to be looking at the second loop. And the second loop is called the for loop. Or what we can do with this is literally for every element in this variable, we can do something with that, right? We can do something with each element. So, taking a look at the for loop, there are 2 paths that we can go on, okay? A popular use of the for loop is going to be when we use it to search for something. And here we are going to introduce a new operator, in, right? We are going to check if something is in a variable. Or another path we can go down is we can repeat a loop a certain number of times. And to do this, we can use the range function. This range function works very similar to a counter variable in the while loop. It is essentially the for loop's counter version. Okay? A for loop, we can iterate or go through every item in a data type, such as strings, lists, dictionaries. We have not introduced these yet. When we start working with lists and dictionaries, this is when the for loop becomes really powerful. So, here is our for loop structure, okay? We start with our keyword for the loop for, and then we have an element. An element is basically a local variable, a variable that I can only use inside this for loop that we create here. So for element in sequence. A sequence, what are you searching through? Is it a string? Is it a variable? Is it another type of data? That is what we would put in our sequence, right? So for example, a variable, right? So for every element in my variable, name. It's going to go through our variable and check every element in that variable. Let's break that down even further. So, on the left, we have the code, the introduction that I put in the last slide. This is the Python lingo. Now, let me translate that for you, okay? So a literal translation of the Python lingo would be, for every element in my variable, I want to run this code, right? And the first code that's outside of our loop is going to run when we end our loop, just like in the while loop. Whatever's outside is going to run immediately after. So if I am going through my variable name, for every letter in name, it's literally going to start with J, and it's going to go through J, A, M, E, S. It's going to go through every letter, and we can do something with each letter. So, take this for example, okay? I will break this down and translate this further, okay? Initially, we have a variable username. Username is input, which means we are going to input a username. I also have a variable called invalid, and the value of invalid is a string, and it is all the special characters on your keyboard, right? So I'm going to enter my loop, and basically I'm going to start going through my loop. For every letter in my input username, if the current letter is in my invalid variable, I'm going to print this character is not allowed. And I want to print the letter that triggered my if statement, my condition. So Python is going to go through my username. My current username is Josh #123. My for loop is going to run J. Is J inside invalid? No. So it's going to go J, O, S, H. It's going to get to hashtag. If hashtag is in my variable invalid, it's right there. This is going to trigger my print function. It's going to print this character is not allowed, hashtag. Right? So Python is going through every element inside our username. Username is what we are checking through. Letter is our element. It is a variable we created that's only used inside the loop. For every letter in username, if that letter is invalid, we print off this character is not allowed. Right? It's getting better, it's getting cooler, all right? So we can go through something and do something with every element inside any type of sequence we have. A string, a list, a dictionary, a variable, and this is where it becomes very useful to us. All right, so here it's broken down, okay? If you guys want to pause here, read through exactly what's happening, do that. All right, then finally, how do we use range with our for loop? Well, here we go, okay? We start our for loop off just like we did before, and we have an element, for element in, and then we finish with our range, right? Now notice you saw on the last slide and on this slide, we're working with a loop. We have our colon, our two dots. everything after this 2 dots is going to run, right? So for example, if I enter in the range function 5, this is going to run 5 times. After the 5 times is up, our loop will break, our loop will quit, and this will be the first code to run as soon as we end. Range can be used 2 ways. Range can take one integer, one number, okay, and it's going to run that number of times. We can also give range 2 numbers separated by a comma. So our range would start on this number and it would go through until this number, right? It basically creates a list of numbers starting at num, and it goes from num1 plus 1, num1 plus 2, etc. All right, here are 2 examples how I can use range. I'm going to start on the left. I have for I in range 5. This code is going to run 5 times. Every time it runs, it's asking me to enter a number. And then I print off that number. So number added 1, number added 2, number added 8, right? Whatever number we enter is going to be printed off here, and it's going to print off 5 times. Once we've repeated this code, we are going to immediately print all 5 numbers added. On the right side, here we go. So, once again, guys, I am using I. Now, in programming, doesn't matter what language you're in, I is a very popular element name that's used by many programmers. It's used for counters in while loops. It's used for elements in for loops, right? And I, it literally means index. And index is the same as saying the current position of something, right? So we start off by gathering the number of passengers through an input. So how many passengers? We are converting this to an integer. For I in range passengers. So if I enter there are 5 passengers, the range is now 5. My loop is going to run 5 times. Every time the loop runs, we are asking for the last name, and we are printing off hello and that person's last name. Once our loop ends and we break, we can print off passenger manifest updated. Okay, so take a look at how the range function can work, how it's beneficial to us, okay? And for now, we are going to head over to VS Code, and we are going to practice using for loops in 2 ways. The first way is going to be going through a specific sequence. And the second way is going to be how we can use the range function to our advantage. I'll see you guys over in VS Code. All right, guys, here we are in VS Code. In this lesson, we introduced the for loop and how we can use the for loop to iterate through a sequence like a string or a variable and check for a specific element in that variable. We also introduced the range function as well. Now, the first 3 challenges will be us using the for loop to iterate through a variable. And the final 2 challenges are going to be us using the range function to complete these. If you guys want, pause the video here, read through these tasks, and give these challenges your best try. Okay, I'm going to get started here with number 1. So first off, I'll create some space. Okay. Now, in the first one, we want to create a simple passcode checker, just like we looked at in our slides. So we need to gather an input from the user, and we want to loop through that input. And if that input contains an invalid symbol, we want to print off that that is an invalid symbol. So let's first begin by creating a variable called passcode. And this variable is going to be equal to input because we are trying to gather their passcode. So enter your passcode. Now I can start my loop. The element name, it does not matter which you call it. So for example, for I in passcode, we can call it that. To break this down more, I'm actually going to change I to letter. Okay, so for every letter in passcode, I'm going to loop through it. If letter is invalid, I want to do something. But you notice that invalid, it's going to give me an error because we don't have a variable invalid yet. What do we want to be an invalid character? Well, let's create an invalid variable. Let's say invalid is equal to literally all the special characters at the top. There we go. So if the current letter is invalid, we can print off that this is not allowed. And I'm going to print off the letter that is not allowed. So let's run this. And I'm going to enter an invalid passcode. So for example, let's say Apple exclamation point. So first off, Apple is missing a P, but that doesn't matter. It's your passcode. It could be anything. What really matters is right here. It says this is not allowed, and it has an exclamation point. If I run that again, and I say 1, 2, 3, 4, 5, $, it says this is not allowed. It looped through 1, 2, 3, 4, 5. It got to the $, and it saw that that letter is invalid. And it's triggering our print function. This is not allowed, and it has the letter. Right? This tool is going to become very handy going forward, especially as we start working with other data types. All right, so for now, I will turn that off. I'm going to close out my terminal, and we are going to go here to number 2. All right, guys, in the second challenge, this one's interesting. We want to create a program that counts the vowels in a word. The program will take an input for a single word, and we want to loop through that word and check for any vowels. At the end, we will print off the number of vowels in that word. Going back to the last lesson, we looked at what we call a counter variable. And in this problem, we are going to use a counter variable to keep track of the number of vowels. So, to get started, I'm going to create a variable called vowels, and I can say A, E, I, O, U as my vowels. Now, I also need the constants, and I already have these here. Okay, so all the letters without, well, our alphabet, without any vowels inside. Okay, now that we have that, I can collect an input from the user, right? And what we want done here is we want them to enter a word. Okay? And outside this loop, we are going to keep track of the number of vowels. So vowel number. And initially that's set to 0. We don't have any vowels yet. Now we want to loop through this word. So I'll keep it similar to the last one. For every letter in my word input, if that letter is in my vowels, then I want to increase my val number by 1. And I can say else if the letter is in constant, then I don't really want to increase the val number. I can just say 0, right? Is that necessarily needed? No, but it's a way to break down the problem so we can interpret exactly what's happening. I am now going to print off here, and I can say there are val number in the word. So there are 3, let's put in vowels here, vowels in the word. Very nice. Let's run the program. I will try this a few times. So the first pass through, I will say airplane. There are 4 vowels in the word. Okay, cool. Let's try another one. Let's say diner. There are 2 vowels in the word, right? So it's looping through that entire word, and with our condition, if elif, we are checking if the letters are in vowels or if the letters are in constants, right? So here we are nesting as well, putting conditions inside of our loops. Awesome. Okay, I'm going to close that out, and we are going to move on to our third task. All right, in the third task, now this one could be quite useful. We are creating a program that checks for a valid phone number. If the program contains anything besides a number, print off invalid phone number, and we want to break the loop or end the loop. Now, break. I'm about to introduce something new, okay? So this works very similar to the first task, okay? I can get a phone number, okay? And this does not need to be an integer, okay? So it can be a string because we are not doing anything mathematical with this. We're just looping through it. And I'm going to create a variable sort of opposite of last time. What do we allow in a phone number? So 0, 1, 2, 3, all of our numbers. And you could put a +2, right? Because it depends where you're calling from. Now, I need to loop through that phone number. So for every number in the phone number, if number. Now, I can't say invalid, right? Because if the number is invalid, that's great. But I want to check if it's not in the valid variable. So with Python, Python is great. It's just like the English language. I could put another operator in here, new operator. I could say if number is not in variable, then we can print off not a valid number. Right? So it's kind of going in reverse here. Not in. Okay, that word not is doing the opposite. If that number is not invalid, instead of checking if it's in the valid variable. Now if I run this, okay, I can enter a number there. Cool. It just ended the program. It worked. But if I try it again, and let's put a few numbers, and then let's say %, not a valid number, right? Because the %, that's not a part of a phone number, right? So pretty cool. We are using our for loop, right? And we also just introduced the not operator. Now, if you tried this challenge on your own and you did it a different way, because I haven't taught about not yet, that's great, all right? You're going down the right direction. There is more than one way to solve a problem. All right, let's close this off. This is going to bring us to our final 2. In these final 2, we are going to try to use the range function. So We want to create a program that takes a number of guests. For each guest, we want to ask their name and age. If the guest is 18 or older, then we want to welcome the user. Otherwise, tell them they must be 18 to drink. Okay? So, because we're going to be looping through these users with the for loop, I'm going to use the range function. Now, what goes inside the range function as an argument? Because we usually have to put a number. What is our number going to be? Ask yourselves that. So, let's start off. I will say guests. And this is going to be the number of guests. Okay, so enter number of guests. All right, now we can start our loop. And I can say for I, so for each guest, in the range. What is our range going to be? Well, it's going to be however many guests we enter inside here. So I can actually insert our variable guests as the range number. Then for each guest, we want to collect an input. So enter your name. And we want to collect an age. Now I am going to use a few operators such as greater than or less than. So this does need to be an integer, our age variable. So I can say enter your age. There we go. Now we just need to do a check. If the age variable is greater than or equal to 18, then I am going to print off and I want to welcome, I'll put a comma and we can say name. Else, we are going to print off that you must be 18. You must be 18 to drink. Okay, so we are going to run this loop for however many guests are in attendance. Every guest we are going to ask the same two questions to, their name and their age. If their age is above 18 or 18, then we can welcome that guest. Otherwise, you must be 18 to drink. I can run our program, enter number of guests. Let's say 3 guests. The first one, Josh. Let's put an age. Welcome, Josh. The second guest, let's say, is Billy, and Billy is 17. There we go. I get an alert. You must be 18 to drink. Now, because it's running 3 times, it is going to move on to the next guest. So if we say Sarah, and we say she's 20, and then it welcomes Sarah. Right? That is our program working. It doesn't matter if you are under 18. It's not going to break our loop. The loop is still going to run the set number of times that we have in range. Great. Okay. This brings us to our final challenge. Okay. So in our final challenge, a user has 5 chances to log into an account. Now, this is an admin account. So their username is admin, and their password is 12345. We want to print off how many tries it took them to log in. But if they enter wrong 5 times, we are going to print off and say, hey, you are not the admin. Right? You had enough times to try. You're not getting in. You are not the admin. All right? So we are going to loop this, and I'm going to say for I in range 5 times. I want this to run 5 times. And I'm using I here because I just works well with range. We are not searching through a specific word. I am just repeating a task a certain amount of times. So for each one, we have a username. And that is going to be an input. Enter your username. And we also have a passcode. And the passcode, it can be a string. right? So enter your passcode. Okay, if the username is equal to admin, right? That's our first check. We're checking, did they get the correct username? And the passcode is equal to 1, 2, 3, 4, 5, right? So I'm doing 2 checks. Both of these must be true in order for you to be granted access to the account. Okay, so I can print, and I will just print here, welcome admin. Okay, now that's our loop running. Okay, so if the 5 times has passed and they are both wrong, all right, we are then going to basically say, hey, you are not the admin of this account. So I can say if username is not equal to admin, or our passcode is not equal to 1, 2, 3, 4, 5. Then we're just going to print off and we are going to say you are not the admin. All right, so because the user gets 5 tries, we are not going to put this condition inside the loop. It only runs after they've tried 5 times. So I'm going to run it the first time, and I'm going to enter as the admin. So our first prompt, enter your username, admin. Passcode, 1, 2, 3, 4, 5. Welcome admin. Now it's still running, okay? So one way to end this, which we haven't looked at yet, but I want to get out of that loop. I don't actually want it to repeat 5 times if I have already entered correctly. Although the program is working, it should be ending sooner. So after print, I'm going to put a special Python word here. And you've seen me use the word break in the slides and in the challenges. We want to break the loop. Well, we have a word, break. If I insert that there, if I get admin correct and my password, it's going to break the loop. It's going to exit. It's not going to keep running. And that becomes really useful to us. So when I try to run again and it asks me for username and my passcode, I can enter admin, 1, 2, 3, 4, 5. It immediately ends after it welcomes me. That's a great tool. Now, let me try again. I'm just going to say A1, A2, A3, A4, A5. There we go. So I tried 5 times. And it gives me the response, you are not the admin. All right? Great, guys. So that was our intro to the for loop and being able to use that to complete multiple tasks and loop through a sequence of items or loop through something a range amount of times. Use the code that I've done here. Okay, now the for loop we are going to be using a lot more throughout our code. Use this and try to create a few of your own problems. All right, now can you put a for loop inside of a while loop? Yes, you can. Try to create a problem to do so. In the next lesson, I'm going to introduce the first project. And as a challenge, I'm going to ask that you use a for loop in the while loop. All right? So I will see you guys in the first project. All right, guys, welcome back. In this lesson, I'm just kidding. This is not a lesson. This is going to be your first project to showcase everything you've learned so far. I've come up with this idea for a trip planner, aka Kayak GPT, right? Because we book our flights on Kayak, and I want to create a program that helps us do so and gives us ideas. And this project should use everything we've learned so far. Let's dive in and see what I mean. So, I'm going to go over the initial structure of what you should be able to do at this point, okay? Your structure, you should include everything we've learned so far, okay? All the functions, all the variables, all the conditions, all the loops, everything. If you can get everything, that's a big bonus, right? We should have inputs. We should have a main loop. We will be using plenty of conditions, plenty of print statements. As an added bonus, try to sneak a for loop in there somewhere, okay? And your bot, your Kayak GPT, should have at least 5 actions or more. In order to get a really good one going, remember nesting is key. Nest your conditions, all right? I want us to use everything we've learned so far, and you should have a minimum of 50 lines of code, right? Once you get going, that won't be that much. I know it could feel daunting now, but don't worry. Once you get an idea and you get going, you're gonna see how fast 50 lines of code really comes. On the right, I have an example. Now, I am gonna code my version out for you guys in VS Code here after, but this is a general idea, okay? So initially, we have an input, and it says enter 1 to start or 2 to stop. Then we enter our actual program, and everything is housed or nested inside our main loop. And while I have not entered 2 to stop, my loop is going to begin to run. All right? I start off with inputs, for example. Do you have a place in mind? If we say yes, I jump straight to another input, plane, train, or car. And I can do something with this information as well afterwards. If I don't have an idea, okay, I'm going to let my bot help us decide. And it could ask us for a type of trip. Do we want to go to the beach, the city, or on an adventure? And I can go through with my conditions, right? So as you can see here, right, I've nested a lot. I have 1, I have this, I have this. They keep going inside, okay? And that's going to be the key to making a more detailed program. So you guys do have access to the slides. You have access to the code we've used before. I want you to use everything and try to create your own bot. Now, I'm passionate about travel. I love flying. I like things like that. This is why I've made it based around travel. But you don't need to do that. Choose a passion you have. Anything in the world. Could be music, could be art, could be sports, airplanes, anything. And create a bot based around your hobbies and passions. That is going to make for a more fulfilling project. I'll see you guys over in VS Code, and I can't wait to see what you guys have created, okay? Only use my video to help you if you're really stuck. Remember to use the terminal to help you solve your errors if you have any, and remember to nest. Let's head over to VS Code.
Hi guys, I hope you're getting immense value from this course I've put together for you. Just a reminder, remember, I'm not getting paid anything for this entire course. So to help me out, you guys can head over to the platform that I'm paying to host for you and utilize it, engage, get higher quality content from me, and get all those guides. It's still free, absolutely free. It's the first link in the description, right? Head on down there. That really helps me as I release more of these courses to help you guys go from A to Z in Python. And I mean, if you really don't want a course, that's fine, okay? It's still free. I don't know why you wouldn't, but if you don't, Okay, the first link in the description, I'm gonna give you guys that handcrafted Python guide that I made because that guide I made for this course. You're not getting the most of the course if you're not using the guide. It pairs perfectly. That's also the link in the description. You don't need to go to the platform, just head there and get the guide. All right, I hope you're enjoying this content. If you are, please do me a favor, click the like button and subscribe as I have weekly content out dedicated to helping you grow. All right, back to our lesson.
All right, guys, here we are in our first project. Now, if you missed the slides to this project, I recommend going back and watching that video, or even just looking at the slides, as I go through all the things that you should be able to do at this point and that you should really try to put inside your project. Now, in this video, I am just going to be coding out my entire project. And what I've done is I've made basically a travel bot which helps me plan a trip, or it recommends me trip ideas. And at the end, I'm also going to create a raffle, so it allows a user to possibly win something if they win it as well. So I will be talking through parts of this video, but I might go rather quick. If there is any point that I feel I should explain, I am going to break that down for you as well. At this point, if you haven't started your own project yet, you can use this to help guide you through it, but it is good to really challenge yourself and use the terminal to go through, check your code, work through those errors if you have any. But this project is really just about creativity. Choose something you're passionate about and really put that into your project. The more passionate you are about it, the easier this project is going to be and the more fun. All right, so I am creating a travel kayak GPT bot type of deal. All right, and I'm just going to start to go through here. So initially, I'm going to welcome my user. So like welcome to, let's say, I don't know, kayak 3.0. Let's plan an adventure. If I can spell correctly. Okay, there we go. Okay, so I'm going to start things off with, I am going to enter a loop here, right? Because I want my bot to repeat. So I can just say 1 is going to start, or 2 is going to quit. Here we go. While my input is equal to 1, I want to properly begin. And the first thing is I'm going to ask the user if they have a destination in mind. So, do you have a destination in mind? And I'm going to make this lowercase. If that input is equal to yes, so if they already have a destination in mind, then I want to say, we could really say anything here, right? It's about creativity, so it's like, let's plan your trip. Okay. I'm then going to gather a few things. They already have a destination in mind. So ideally what I want is I want to know transport. So are they going to do plane, train, or car? If that input is equal to, I'll start with plane, then I am going to ask for class type. So what fare do they really want here, right? Which fare would you like? And maybe I could put, where am I going at with this? Maybe I could put first, business, or economy. First, business, economy. And I always like to do the 2 dots. And we'll make sure it's lowercase. Cool. So ideally, right, if they are booking on a plane, they're going to be able to choose a type of service. And any trip, I guess we would have our luggage, right? So based on the airline requirements, we need to gather luggage. So enter baggage weight in kilograms. If you use pounds, put pounds, kilograms, kilograms. Okay, so basically, if you guys fly a lot, right, you'll know that in economy, you can only take a certain amount of weight for your baggage. And if you upgrade to business or first class, you also increase the luggage weight limit as well. So I need to check a few things. If they're flying in first or business, the weight, it's not a big deal. But if they're flying in economy and they have more weight than they should, I'm going to warn them and say, hey, you have a bit much here. So I'm going to start off and I could say if luggage is greater than or equal to 21 and their class type is equal to business or their class type is equal to first. So I have a few things going on. I'm using and, or with these three expressions. I'm checking if the luggage is over 21, and I'm checking to make sure that they are in business or they are in first class. Okay. Great. So also if their luggage, so yeah, basically if their luggage is less than 21 and their class type, I can just take this because I'm going to use the same thing. Right. Then I could say you can bring more too if you want. Let's say that. You can bring more if you want. That's cool. Else. I'm just going to throw an else because basically what that means, right, is you're pretty much in economy, right? So you got to be careful that you don't have too much baggage, right? So I'm just going to say warning. You may have too much. There we go. Okay, awesome. So in reality, we have that. I'm going to put an elif in here, and I'm going to say I'm keeping this as a part of this initial condition that I have going. So I'm going to go forward, and I'm going to check if transport is equal to train. So if you're in Europe, right, trains are popular. So you could be taking Europe. So in a train, you also have a seat class option. Okay, so you could have, I'm pretty sure they have things like economy and business. So economy, I'm going to put that there. And we will make sure it's lower. Awesome. Cool. And I can basically say if our seat class is equal to, let's start off with business. So if that seat class is business, you could just say, right, great, more comfort your way. And then else, right, let's just check that they've done everything right. So I'll actually make one for C-class. And I'll say, you save more, right? You save more this way. Then I could put an else in here. Let me create some more space. So else, they obviously entered something wrong because I'm really only checking for economy or business. So if there's a spelling error, I could say, we don't have that class. Or maybe they try typing something different that they're accustomed to. Awesome. And then finally, I'm going to make one more also if. Because our final transport is really going to be car. Now, a car, there's a few things going on. So first off, I could just say road trips are fun. Okay? And I want to get the number of people, because that's going to be important. If we have too many people, then a car might not be the best fit, right? How many people? Okay, so ideally I can go forth and say if the number of people is less than or equal to 5, well, let's say 4. Like, that's comfortable, right? Anything more than 5, that might not be as comfortable. So if the input is less than or equal to 4, then I could just tell them, great, you could rent a car, like so. Else, they have more than 4 people. So generally speaking, you may want to rent something else. You may want to rent a van or minibus. Can you rent a minibus? I'm not sure. I'm thinking of like RVs and stuff now, right? You have more people going on. Okay, so I'm going to come out of there now. So we've checked for the transport type, and you really only have plane, train, or car. I'm going to close off that condition and have an else. So if they enter something else, I could just say we don't have that transport type. That makes sense. Okay, so I didn't incorporate, like, if you're going on a cruise or you want to put that, that's fine, that's cool, right? But I just didn't include that here. So what I've done here in this project is I've really completed the first transport condition, but I'm still having this, right? I'm checking if the destination is yes. So if the person answers yes, it goes through these steps to helping them decide which type of transport would be best used in their situation. But what if you don't have a destination in mind? Well, if you enter no, then I want to start checking for other things. So I don't necessarily need to say if the destination equals no, because it's really a yes or no question. I could just bring that down to an else. Okay, so I could say, I can help you choose a destination. Right, so the bot's job is a destination. And ideally, I want to gather from the user what type of trip are they looking for. Okay, so whatever your dream trip could be, right? So maybe I could say something like, let's say the beach, city, or adventure, which could be considered outdoorsy, right? And I don't want to skip away from that. I do want to lowercase that. Okay, so if our trip type is equal to beach, we will start off with that. Okay, so if it's equal to beach, I don't know, I'll choose a place. I'll say something like, how about Hawaii? And then maybe, right, so Hawaii's huge, right? There's so much to do. There's popular beaches, there's remote beaches. So maybe it all depends on your preference, right? So I could progress with that and I could say something like, okay, so our input, I'm looking for what type of beach do they want to go? And we could say something like, I'll just say popular or remote beach. There we go. Then using conditions, right? So a lot of conditions here. Everything's taking place in one while loop because this is going to keep repeating, right? So this project is based to get you guys really confident in working with conditions and nesting while also including our loops and all the functions we've used too. So if our beach type is equal to popular, right, then I could print off something like, so I've never actually been to Hawaii, but I know the popular beach when you go on Oahu is like Waikiki, right? So check out Waikiki Beach near Honolulu. There we go. Okay, and so I got that if they enter for a popular beach. I could put in here also if the beach type is remote, then we could print off, well, I don't know, head over to Maui. All right, that's a quieter island, all right? And then I'll put an else, and I can say we don't have that option. Cool, so I've checked for the beach type. That was my trip type condition, right? So I'm just gonna progress through now. And I'm gonna say also if the trip type is equal to a city, right? So if the trip is to a city, then I could say, I don't know, pick a city. Head to New York City, if that's your vibe, okay? And in New York, right, there's so much to do. So activity. We kind of want to gather what activity is the person going to be doing. Let me create more space here. So the activity type, I'm going to say indoor or outdoor, because there's a lot to do outside, there's a lot to see inside too, cafes and whatnot. So that's great. So if my activity is equal to, I guess I'll start with indoor, okay, then I could say something like, what is inside in New York besides shopping? There's a lot of good museums. So check out the Museum of is the National History? No, that would be in Washington. Museum. Check out the Met Museum. Right, the Metropolitan Museum. Okay, so check out the museum. Great. If it's outside, right? Like your print statement, guys, don't have to be overly lengthy, right? I mean, get creative, but you don't have to type a paragraph out for your print statements. The project is really about, using your code and your logic, right? It's all about the logic. So using conditions, using our functions correctly, checking for errors, any strings you put in your print, it could be whatever. So if you want to go outside, then we could say relax in Central Park. Else, wrong input. Spelling error. I could say that. Right? Cool. Okay, so I've done city. Now my last one I can say is if the trip type, I believe I said adventure. So if the trip type equals adventure, cool. I like adventure trips. Head out to Yosemite. There we go. National Park. All right. And now we could have like, well, I need another activity variable, but I can't call it activity again because we've already created that one. So your names for your your names for your variables are going to become very important here, right? So don't reuse anything or it alters the state of that variable. So outdoor activity, what do you kind of want to do? You could say hiking or camping, because you can do both. So hiking or camping. If the outdoor activity is equal to hiking, then, well, I've been to Yosemite a while ago, so I could say try hiking Half Dome. That's for the true adventure seeker. Else if your outdoor activity is equal to camping, I'm just going to say check out one of the many camping sites within the park. And I'll say else, and I'm just going to say that that activity is not offered. Okay, very nice. I can now close out the main condition here. So to close out the main condition, I could say that trip type is not available. Cool, so I've used everything so far. The one thing I haven't used is my for loop. So I want this to repeat as a process of the main loop, but I don't want it to be in my conditions because it doesn't matter initially in destination if you answer yes or no. I want to give everyone the opportunity to enter this raffle I have. So I'm going to place this outside of my conditions but inside my loop. So that's one tab in. And I'm going to print off and say, enter for a chance to win a free trip. And I'm going to make a for loop. And I'm going to say for I in range. Now, we've been using one number for range most of the time, right? Because that is giving you, it's going to repeat 3 times, okay? But I'm going to create a range here, and I could do the same thing kind of by doing like 1 and 4. So it's going to run from 1 until 4. And I'm going to create an input, but I'm going to do this slightly different, right? I could create a variable, and I could check that variable in a condition. What we haven't introduced, because the way we can use input and functions and variables, you can do a lot of stuff with them, but we're trying to build up through the foundations, right? So a shorter way that I could use input is I could say if input, and I could actually put that there, right? And I could say, I'm going to enter a question here. So what is the largest desert in the world? So if input, I don't have a variable, it's just going to check that, is equal to your correct answer. So if you didn't know, the correct answer is actually Antarctica. Right? And technically the definition of a desert is dryness, right? So if it's equal to Antarctica, then I could just print off something like, wow, you win a free trip. Awesome. Now that's the end of my Kayak 3.0 bot, okay? But a loop keeps repeating. Now this while loop, while enter equals 1, it's continuously needing the authorization, your permission to run again, unless you want to exit the loop, which is done here. But Python reads top to bottom. Once you're in a loop, you need to get out of it before any other code is going to run. So I'm going to take the same input, and I'm going to put that at the bottom of my code, all the way outside there. Okay, so at the end of my program, it's now asking one more time, do I want to start over or do I want to quit the program now? That is key in this project. If you don't have this, you're never going to get out of that loop. And then once I get out of here, I don't know, I could say, enjoy your trip, like so. Wow. I'm going to zoom out, just one. Okay, so what did I do that in? 74 lines of code. I have a few spaces in here. But I did try and give you guys the challenge of trying to use at least 50 lines. No matter how you did it, you could have kept adding conditions, whatever you wanted to do. 50 lines of code for a project like this, using everything we've learned so far, is quite doable. Great. I'm not going to run this too much. I'll run parts of it, okay? Because there's just a lot going on. There's so many options. So initially, I can say 1 to start. Do you have a destination in mind? I'm going to say yes. Let's plan your trip. Plane, train, or car? I am going to say plane. What fare would you like? Let's go bougie and say business. Enter your baggage weight. Let's say I have 24 kilos. Cool, so I'm going to stop right there. It says, great, you can have more baggage with these classes. I wanted that. It triggered that. But it's still giving me the option to win a free trip. Cool. What's the largest desert in the world? Okay, so I'm going to say Antarctica. If I could have spelled that right. I'll just hit enter to prove that, right? I missed out on the first chance. I can go again. Antarctica, there we go. Wow, you win a free trip, okay? Now it's still going. How can we get out of that, right? What was the key that we looked at in the last lesson which enables us to get out of that? So I can just go here and I can say break, and that would immediately take me out of that. Now I'll run it one more time, and instead of saying I do have a destination, I'm going to say no, I don't. So do you have a destination? No. I'm going to say adventure, hiking. There we go. It says try hiking Half Dome, right? There's endless options. Okay, I'm just going to stop that there. Okay, awesome, guys. So hopefully you've come this far. Hopefully you have a project and you were able to truly get a grasp on all the foundational points that we've learned so far. As we begin to progress more and more throughout the course, I'm going to be introducing more advanced topics which are going to allow us inevitably to create games in Python. I will see you guys in the next lesson. Alright guys, welcome to lesson 9. Throughout our course so far, we've used pre-built Python functions throughout our program. These include print and input and all the other ones we've used so far. But in this lesson, we are going to be looking at creating your own functions that you can reuse throughout your program. Let's dive in. So far, you guys know these functions. Now, you should be able to express at this point what each of these do and why we would use these. Okay, so a beginning, right? Our print function, it prints off data that we, as the programmer, can read. But we can't do anything with this data yet. Our integer function, this converts a string to an integer. Our string function converts an integer to a string, And in our loop lesson, we introduced the range function. And we can use this to repeat a number of times. We have the len function, which is short for length, and this returns the length of a string variable. And then finally, we have input. And our input function allows us to collect data from a user, which we could store in a variable. So, what is a function? Well, a function is a piece of reusable code with a unique name. We can call this function in other parts of our code. Now, in this lesson, I'm going to begin to introduce new terms, such as call. When you call a function, you use the function. So, how do we create a function? Well, we need to define a function. And here in this block that I've created, I have an example of what that would look like. To create and define a function, we need to use Python's def keyword. Def is define. We then have the name of our function. Now, remember, we do not use uppercase and we do not use a space. If you want to use a space, instead use an underscore. And this name we give our function, it must be a unique name. You cannot use any special Python word as the name of your function. For example, you could not name your function print because print is already a function within Python. Once we name our function, every function has a set of parentheses. We must include those. And then a function, when we define one, is followed by a colon. Now, inside your parentheses, we have what's called a parameter. You may define a function without parameters, but a lot of the time, you are going to want to give your function data it can use. So a parameter we define here. And I'm going to get into this very soon. Whatever code is inside your function, that will run when you call your function. And then finally here at the bottom is how we would call this function I've made. We do not use the word def to call a function. We just use the name of the function, our parentheses, and then any arguments. Now, if your function has parameters, you must have arguments. Arguments is the live data you are giving your function to use. So if you have 2 parameters, you must also have 2 arguments. If you do not have any parameters, you do not need to have any arguments. All right, here I've broken that down a little more. Now, our test function, we are giving it our unique name. And briefly in the last slide, I introduced parameters. Now, a parameter is essentially a local variable. And I'm going to dive into local variables very soon. But a local variable is a variable you can only use within a function. And then finally, our arguments are down here at the bottom. And this is the live data that we are passing into our function to be used. All right, so let's begin here. I'm going to move myself down just to clear up the space there, okay? And here we go. So I've created a function called personInfo. And I have said that I'm going to give this function 3 parameters: name, age, and nationality. When I call this function, all it's going to do is it's going to print off welcome, the name that I give it, you are, the age I give it, and then you are from, and then your nationality, or you are. Okay? Although we define this function at the top, and Python reads top to bottom, this does not do anything because we are only defining the function. In order to use this, we must call this function somewhere throughout our code. So, in our code here at the bottom, I am beginning with an input, and this input is going to be an integer, and it's stored in the variable number. I'm asking for an amount. I then have a for loop, and I'm saying for I in range number. So whatever my amount is, that is the number of times my for loop is going to run. Every time my for loop runs, I am asking for 3 pieces of information from the user. We are asking for a name, an age, and a nationality, all of which are collected through an input. These variables are then passed down to our function. And in the last line, we are calling the function that we defined at the top, person info. And all of the data that we collected through input is being given to our function. Our function has 3 parameters. It must have 3 arguments. Our data is taken from the function call at the bottom, and it is then passed up to our function. We can then use that data in our function to print off what we need it to. Okay, great. So, what would this really look like if I gave it data? Well, here we are. So, I enter in my input. I enter Josh as the name, age of 25, and American. This information is going into my function, and it's being passed up into where we defined our function. Our code is then ran, and the output in our console would be, welcome Josh, you are 25, you are American. Right? So I've created something that I can use anywhere we want within our program. All right. I'm now going to introduce a new operator, okay? And this operator is the return operator. And return is used to get back a value which we can use throughout our code. Now, return works similar to print, except print, we can read the value, but we cannot do anything with that value. Return, we cannot read that value, but we can do something with that value. So, before I move on and I explain what's happening in our code, I'm going to dive a little bit deeper into our local and global variables. So, in plain English, local means near you, right? And a local variable is only accessible inside of something, like a function, a loop, a conditional statement, and we cannot use this outside. So I can't use it outside of my function or outside of my loop. And the opposite of local is global. And in English, global means worldwide or everywhere. So a global variable can be used anywhere in our code. I can use it outside, but I can also use it inside of a function or a loop. But it's important to note that you must create a global variable outside of everything. All right, so in my function that I have defined, my function's name is total points, and I am giving it one parameter, game score. Inside this function, I have a variable called points. But if you remember from our loops lesson, this points variable is actually going to be a counter variable. So every time my loop runs, I am able to increase the value of this variable. Okay, my loop runs, and my loop is inside of the function I've defined. And my loop is running while my game score is not equal to 0, right? This parameter right here. Okay, so if that parameter is 0, this loop ends or this loop breaks. And every time this loop runs, we are checking to see if game score is greater than or equal to 5 and game score is less than or equal to 10. If that's the case, I am going to add 2 to my points counter variable. In my other condition, I'm just checking if my game score is greater than 10 and my game score is less than or equal to 20. If that's the case, we are going to add 3 to our counter variable. At the end of my loop, I then have game score again, and this is an input. So I can continue to enter a game score until I enter 0. Then my loop is going to break. It's going to stop. Upon the loop's completion, we are going to return the variable points. Specifically, we are going to return whatever value points is at when the loop ends. And then I could use this data. Okay? Now remember, this function is not going to run until I call this function. So, I collect a score through input, and we convert this input to an integer. My function, I am not necessarily calling because it is the value of a variable gain points. My function will not run until I use gain points. My score input I am giving to my function as an argument, and it is being passed up here as my parameter. Okay? They do not need to have the same name. Okay? The parameter that we have at the top will be given the argument when we call the function. Okay, 2 things are happening. I'm printing off my points variable, and I am then calling my function, right? Gain points is a variable. I am printing off that variable. And that's going to print off the value of points because I'm returning that value. But I'm going to get an error. Remember, we talked about local and global variables. Points is going to trigger an error because points is a local variable. I cannot print out points anywhere outside of where I defined my function. In order to fix this error, we just need to delete it, right? We can't have points there, all right? My code here on the screen would run normally, allowing me to enter a game score and increasing the value of points. Once I end my loop, I can return the value of the points variable, and that would be printed off here when we print off game points. Pretty cool, huh? All right, let's take a look at another example of creating functions and returning a value from that. Okay, so before I jump in and explain our function, I am going to introduce a new function. This function is a pre-built Python function called float. Okay, so far we have 2 functions for working with numbers. We have the integer function, and now we have the float function. It converts a string to a decimal number. Okay, so if you want to use 2.3 or 8.5, that is not an integer. An integer is a whole number. If we're working with a decimal number, we would use the float function. And you can nest the same way. I can put input inside of float, and then my input becomes a decimal number. All right, so on the left-hand side, I have defined a function called good deal. And this function has one parameter, cost. When we call our function, we are checking if cost, whatever number I give here, is greater than or equal to 50 and cost is less than 150. If it is, I then created a local variable called response, and the value is this is a good deal. Also, if cost is greater than or equal to 150, my response becomes overpriced. Otherwise, anything else, my response is cheap, buy now. Once our condition runs, I can then return the value of our response variable, which I can then use on the outside. On the outside of that function, we have a block of our code. And this code starts at the top. We collect two pieces of information. I collect store, a store name, and then I'm collecting the cost. And this cost is going to be the item cost, which can be a float number. In our third variable, res. Now, res is a programming term that's short for the word response. So res is value is our function good deal. And our cost we are giving as the argument to our function. Remember, we are not calling the function here. I must use my variable res in order to trigger my function. In our print statement, we are now printing off the name of our store and then our response. Okay? Now our response, our res, remember it's going to be one of these three things. Okay? Because I am returning one of those three things. I then have a condition, and I can actually use whatever response I get in a condition to check something. If my response is equal to this is a good deal, I can print off buy before it's too late. So let me kind of rephrase that. If my response, if I get the response this is a good deal, which means my price is greater than or equal to 50 and it's less than 150. It's going to return this response. And if that's the case, I can print buy before it's too late by checking it through my condition. Amazing. All right, to recap a few things here, okay? I've highlighted all the important things that we have here on the screen. So cost is our parameter. And this parameter is acting as a local variable which I can use throughout my function. I then return a response. And this response we have throughout our function as well. And I can use this value in other parts of our code. Over here in the right-hand side of our code, we have res, which is a variable that I've created. Res is short for response. The value of res is our function with our argument cost. I then print off the store name and I print off res, which is going to give me one of the responses from our function. I can then check if my response, if res is equal to this, I then can print by before it's too late. Now guys, it's important to know that you will be creating many functions throughout your programs. You can call a function that you've made within another function, right? If you make two functions, you can use one of those functions in the other function you made to do something. So maybe one function is calling the other function, and that's the only time it's being called. If that was the case, in reality, you would only need to give an argument to one of your functions. That function that you give your argument to is going to call and use one of the other functions that you've defined. All right, great guys. So I have given us 3 code examples. We are going to head over to VS Code. And before I give you guys any tasks, I am actually going to run these 3 code examples in VS Code to show you what's happening and what their output is going to be. I'll see you guys over in VS Code. Alright guys, here we are in VS Code. As I mentioned in the slides, what I've done first is I have put the 3 examples from the slides into VS Code so we can take a better look at what's happening. And if you haven't noticed, this is going to be a longer lesson because functions is an important topic and yet it is a slightly challenging topic. So VS Code will be broken down into 3 different videos. In this first video, we will look at the 3 examples that we had in the slides. In the slides, our first example, we defined a function called personInfo. And personInfo is taking 3 parameters. These 3 parameters are given to our print statement, and we're able to print off whatever values we give them. We have a variable number, which is going to be an integer input, and then we have our for loop. And this loop is running the number of times we enter inside input. All right? Every time our loop runs, we are collecting 3 pieces of information before we call our function that we define. And then we are giving it 3 arguments. These arguments were collected here. All right, I'm going to run this, okay? And you may have noticed that I actually decided to use the capitalize function because, well, name, it should be capitalized. And nationality, that should also be capitalized as well. When I run it, my terminal is going to open. And it's going to trigger our first question. Amount, which is our number input here. So I'm just going to say 1. Enter first name. I will say Josh, I will say 25, and I will say American. When I click enter, it's going to call my function, and it is going to print off everything that was in our function. So, welcome Josh, you are 25, you are American. Okay, so we are calling it here. That information is now going back up to our function and it's going to run. All right, let us take a look at our second example that we had. In the second example, we had a function called total points and we gave it 1 parameter, game score. We also introduced a counter variable. So every time my loop runs, we are able to increase this counter variable depending on what our input is. At the end of our function, once we break outside of our loop, we want to return the value of the points counter variable. In our code, we collect the initial score, which is given as our function argument. We are not calling this function yet because it's held in a variable. When I print off total points, and then I print off or call my function gain points, it's going to tell me the number of points that we returned in our function. Okay, so I'm going to run our code. Okay, I can make this a little smaller for us. Right there would be good. Our question pops up with a score. So my first score, I will say 5. My loop is running. Okay, and if you really want to see that right, our first question was enter the score. We see that here. But now it's saying enter the game score. And this is actually our input inside of the function we defined. My next score, I will say 20. I will say, not 20 again, let's say, I'll say 2. 18, 4, 6. And then I'm going to say 0. There we go. Total points, and it returned 10. That is what was being printed off here in our last line. Okay, it was going through our conditions, checking if our game score input is greater than or equal to 5 and less than or equal to 10, I increased my counter by 2. If that game score was greater than 10 and less than or equal to 20, I increased my points by 3. Once our loop was done, we returned the total number of points. Nice. All right. In our last function that we had, we defined a function called goodDeal, and goodDeal took cost. We go through our conditions, and we are checking what the cost was. If it's greater than or equal to 50 and less than 150, we have a response variable that's equal to a string. This is a good deal. Also, if it's greater than or equal to 150, our response variable is overpriced. Otherwise, our response is cheap, buy now. Once our condition runs, we return a response. In our main code, we collect 2 different inputs. Store, so we can enter a store name, and the cost, and we can enter the cost of an item. And then we have a response variable, res. So res is equal to the function goodDeal, and we're giving it a cost argument. I can then print off my store name and one of our 3 responses, and then we can check if the response that I got back is equal to this is a good deal. I'm going to print off buy before it's too late. Okay? And remember that here I have the int function. How do I convert an input to a decimal number? Well, remember we introduced the new one called float, and I could convert that to a float. All right, I'm going to run this. Okay, let's make this a little smaller if I can. There we go. Enter store name. I'm going to say Apple. Enter item cost. Let's say 200. Boom. We get the Apple store name, which is printed off store, and then our response we're getting is overpriced because the cost that I entered is greater than 150. It's giving me my response overpriced. Let's try again, and let's try to trigger our condition here at the bottom. So I'm going to run it. I will say Apple again, and then I'm going to say 75. There we go. I have my store name. This is a good deal. And then I triggered my condition because that was true. My response was equal to this is a good deal. So we got buy before it's too late. All right, so we just looked at the 3 examples that we had from our slides. I'm going to head into the next video And this is where I am going to give you the tasks for building your own functions. Let's head over to our next video. All right, so the challenges begin. Here we go, guys. I have put together 4 tasks for creating and defining your own functions. These should be a challenge, but break down everything you've learned so far. We've learned conditions, we've learned loops, we've learned other tools that can help us achieve creating a function. Really, all we're doing is we're taking what you've learned so far and putting it inside of a function. So, if you guys are up for that challenge, pause the video here, read through these 4 tasks, and try to complete these on your own. All right, I'm going to begin, and I'm going to start off with our first function. Okay, so in number 1, let me zoom in. Okay, there we go. We want to create a function that accepts a score as a parameter. If the score is 0 to 50, we print below passing, improve your grade. If the score is 50 to 70, print barely passing the class. If the score is 70 to 90, print you have a passing grade. Otherwise, you are one of the best in the class. We are going to use an input to collect the score, then call the function. So, let's begin with creating our function. How do we define a function? Well, we use our def keyword. I'm going to call my function grade, and I said I'm going to give score as a parameter. 2 dots to begin our function, and everything now is inside of our function grade. So I'm going to print off a string first, and I'm just going to say your score is, okay, and then I'm going to create a condition. So I'm going to check if score is greater than 0 and score is less than or equal to 50. If it is, then I'm going to print off what we see up top. So below passing, improve your grade. There we go. Also, if our score is greater than 50, okay, I'm not going to say equal because this is equal to 50. Okay, so if it's greater than 50 and let's say score is less than or equal to 70, then I am going to print off what we have up top. So I want to print off barely passing the class. Okay, let's continue on our condition. So if score is over 70 and score is less than or equal to 90, we will print off our next one. And our next one is you have a passing grade. Okay, so I'm just taking that from the top. Otherwise, anything else, we are going to print off you are the best in the class, or you are one of the best in the class. So I want to put that there. Okay, so our function is defined. I'm done with it. All the future code needs to go outside against the wall. It's not a part of our function. So I'm going to collect an input. I could just call this score, okay? And this is going to be an integer, and this is going to be an input. So I'm just going to say enter your score. And then I need to call the function, right? To call the function, do not use the word def again. We only use that when defining. We can just type our function name grade. And inside, you must give it an argument because we have a parameter. My argument is going to be score. If I run my code, We are asked for a score. I will say 82, enter. Your score is, you have a passing grade. Okay? I'm printing off, then it's going top to bottom. I have a passing grade because my score is between 70 and 90. All right, that is our first one. Very nice. Okay, so right here, I'm not putting grade in a variable. I'm just calling my grade function. Right? It's going to run as soon as Python reads that line of code. All right, I'm going to turn off this function. I am going to go down to our second function, challenge. All right, so back to me liking flights again. Okay, let me move up. There we go. So we want to create a function to add on extra flight charges. The function takes a base fare as a parameter, then asks if you want to upgrade. If yes, we want to add $90 to the initial base fare. Excuse me, $99. The function then asks if you will have baggage. If we say yes, we want to add $35 to the base fare. Before returning the price, we want to add tax of 0.08%. Then we can return the price. We then print off the grand total after all the extras and any tax that we have. So let's create a function. I'm going to define it, and I'm going to call it flight charges. And, well, let's begin with me spelling the word flight correctly. Okay? And we are going to give it a price. So this is basically our base fare. I'm going to give it a starting point. The first thing we do is we're going to ask if we have an upgrade. And our upgrade is going to be triggered by yes, right? So would you like to upgrade? Okay. I can say if upgrade is equal to yes, then we are going to take our price, which was given as a parameter, and I want to add $99 onto the initial price. Okay? I am then going to ask for baggage. And I just want to ask the user if they have baggage. Will you have baggage? If our baggage input is equal to yes, then my price, we want to add $35 onto that price. All right, so if we say no, it's not going to add that price, we keep the base fare. Now before I return this, I want to add tax onto everything. So I could create a variable called tax. And initially, I want to take my price and I'm going to multiply it by 0.08%. All right, that's just going to give me the additional tax price. I can then add back on my price at the end, and we can return tax. Okay, that is our function completed. We can then do some things to call our function. So initially, let's gather a base price. Okay, so here is the price that will be given to our function. So I'm just going to say enter the base fare. Okay, there we go. All right, and then I'm going to have a variable. Let's call it grand total. And that is really going to be the value of my function. So flight charges, and basically it tells me here I need a price, right? I need an argument. So my argument can be my price, like so. I'm then just going to go through and I'm going to print off grand total after tax. And whoops, I'm outside there. I am just going to print off my grand total variable. Okay, so let's run it. I'm going to run it, and our base fare, let's say our base fare is an even $200. Would you like to upgrade? Yes, I would. Will you have baggage? Yes, I will. There we go. So grand total after tax is going to be $360.72. Right? It's adding on 99 and then it's adding on 35 before adding tax. I'm going to run that again, and this time I'm going to say no to both of those. So enter base fare, let's say 350. No, I do not want an upgrade. No, I will not have baggage. Okay, so after tax on the base fare is $378, right? Pretty cool. So I can pass in that argument and use that parameter price as like a variable, a local variable, and I can add on to that value before returning the final value in my function. Nice. Okay. Let's move on to challenge number 3. All right. So let's give a little bit of space here. All righty. In challenge 3, we want to create a bank balance function, and it will accept a balance. So start thinking. What is that? It's our parameter. If the balance is greater than or equal to 500, we want to return true. Otherwise, false. That's all the function's going to do. So I'm actually just going to start on the function before I continue reading. So I'm just going to say, okay, so bank balance, and that is going to take a balance. Okay, so then if my balance is greater than or equal to 500, I can return true. Else, I can return false. Okay, nice. The function's done. I then have, outside the function, we want to ask for the number of bank customers and loop through depending on the number of customers. All right, so how can we do that? We can use a for loop with our range function. Every time the loop runs, we want to ask each first name and their current balance, and then print off if they have enough funds, so true or false. If the function returns true, we want to print off no need to worry. Else, print off your account is low. All right. So let's just call it bankers. Let's say it's going to be an input that will be an integer. So I can say number of bank customers. Okay. We then begin to structure our loop. So for I in range, our range is going to be the bankers. Okay. For every banker, we are collecting a first name. We don't need to do anything with that except just enter the first name. And then we are collecting a balance. Okay, and this balance, let's actually make it a float, right? Because a person could have a float as a bank balance, which is most common. So enter their bank balance. Cool. All right. I don't just want to call a function. So I'll create a variable response. And response is going to be my bank balance. And I need to give it a balance, which is the input that we just collected. Okay? Inside that for loop, I'm going to print off a few things here. I'm going to say enough funds in. I'm going to put a space because I'm going to be adding two strings together, not a comma. And I'm going to say first name. Okay? And then I can say plus apostrophe S. Okay, so if I say Josh's or Susan's, I want to add that apostrophe S to it. And I can say account. And then really I'm just returning true or false. Now this is a different type of data. So instead of adding them, I'm going to use my comma to separate the data types. Okay? And then all I'm doing inside the loop still is I'm saying if my response is equal to true, I'm going to print off don't worry, enough funds. Else I can print off your account is getting low. Okay, I want to show you guys something real quick. So I've been emphasizing this whole time why we use double quotations instead of one quotation. I'm going to go to this line and I'm going to show you why. So if I put this as one quotation, because I have an apostrophe in the word don't, the only string is here. All the rest of my text, it's not going to identify as a string because I'm using an apostrophe. My start is at the beginning and my end is after the N. That's why if we have apostrophes, it's going to cause an error. And the easiest way around that is to always use double quotations, and that way you can use apostrophes in your strings. All right, I'm going to now run my code. So initially, we're going to ask for the number of bank customers. I'm going to say 2 this time. The first one can be me. Bank balance, let's say 780. Cool. Okay, so it triggers. Enough funds in Josh's account is true, and then it runs my condition, and it's checking if my response is equal to true, which we have here in the bottom. And it says, don't worry, enough funds. Then it's asking me for the second person's name. So I'll say Sally. I'll say Sally has 200. Okay, I have different answers. Enough funds in Sally's account is false. Your account is getting low. All right, so we did a lot there. Our function is rather short, but we're returning a value of true or false, and then we're using that to check our response to see what we returned. Did we return true or false? Amazing, guys, almost there. All right, this brings us to our last challenge. So, in challenge number 4, we want to create a mortgage function that accepts a number to determine if someone is eligible for a mortgage. If they have $50,000 or more, we are going to return instant approval. If between $20K and $50K, print you need approval. Otherwise, print not approved for mortgage yet. Okay, so I'm just going to start by creating that function before I move on. Okay, so let's say we have a function called mortgage, and it's going to accept a number, which is how much cash you have. If your cash is greater than or equal to 50,000, then we are going to print off instant approval. Okay? Also, if our cash is less than 50,000 and our cash is greater than or equal to 20,000, then I'm going to print off, what do we have here? You need approval. Okay, so I'm going to take that. Okay. And then else, you are less than 20K. So I'm going to print off, you are not approved yet. Like so. Cool. That is our function complete. Okay, so really, if you're over 50K, then you can just print off instant approval. If your cash is less than 50K and over 20K, you need approval. Otherwise, you are less than 20K, right? So here's if you're over 20. All right, so outside of our function, we are now going to collect an input of how much cash that person has. right? So I can have them enter cash. So I can say deposit amount, okay? And I'm gonna create a variable. So like total balance. And this is gonna be a counter variable. So every time I enter deposit amount, I'm gonna increase this counter variable. And I could say while cash, right? Because I wanna create a loop that ends with 0. And our input, which I've just made, is collecting our deposit amount. So every time a deposit is entered, this is stored in total variable, and the function is called. Once the loop ends, we print off total deposit amount. So while cash is not equal to 0, because it's an integer, then I can take my total balance variable, and I'm going to add whatever I entered from input to my total balance variable. And then I want to call my function. And I'm going to give it cash. That's my input, right? So that's being passed to it. I can then take this, right, by asking for another input, and then I can print off a string. So I can say total money requested, and I'm gonna say total balance. That's my counter. Cool, let's run this. So let me go through. The first amount is gonna be 10,000, not approved for mortgage yet. So how much more do I wanna deposit? 5,000, not yet. Let's say 25,000. You need approval. Cool, I'm gonna say 0 to stop. Total money requested, 40,000. Amazing, guys. Okay, those are our first 4 starting challenges. I am now going to give you 2 bonus challenges in the next video. And these are going to be slightly harder, but we are going to be calling functions inside of other functions. Let's head over to our next video. All right, here's our final video for working with functions. Now, these are going to be the last 2 that we have, but these ones I've put in their own video because we are going to be creating multiple functions, but we are going to call functions within other functions. So, in our first one, okay, well, in the first 2, really, if you guys want to give it a try, here would be where you can pause and give them a shot. In our first one, we want to create 4 different functions. The first 3 will be called terminal 1, terminal 2, terminal 3. When one of those functions is called, it prints off which terminal to go to, then calls the main function again. The main function should ask, is your flight budget, domestic, or international when called? And this will be the first function that you will call. And on the bottom, I have put which function goes to which type of flight. So the budget airlines are terminal 1, domestic terminal 2, and international is terminal 3. So I'm gonna start off and just create our terminal functions. So we have terminal 1. It is not going to take a parameter. I don't need to. Okay, and I'm just going to print off departing from terminal 1. And maybe I'll even say here budget, just so we can see that. And then I'm going to call the main function. So we haven't created a main function yet, but maybe I'll call my main function once I define it. I'll call it flight check. Now for now, it's going to tell me that there's an error. That's fine. Okay. And then I want to have 2 more functions like this. So I want to define terminal 2. That'll be another function. And I'm just going to take these two from function 1, and I can say departing from terminal 2. Terminal 2 is going to be a domestic flight, and then we call the main function, which will be flight check. And then our last terminal is going to be terminal 3. And then we can take again. So you see, guys, that I am going to have a main function called flight check. And what I'm doing is I'm actually just calling that within these other functions. Right? So I have 3 functions, but they don't do anything. Okay? I haven't called any of them yet. But that's what I want to do now. I want to create my main function, which is going to ask for an input. And the input is going to be budget, domestic, or international. And I'm going to call one of these 3 functions based off that input before going back to our main function. So let's create it. Let's say flight check. Flight check will not take any parameters either. And I'm going to have an answer. So answer equals input. And inside here, I can just say budget. Let's do budget, domestic, or international. And I will ensure that it's all lowercase for our condition. And then we can make our condition. So if our input is equal to budget, I want to call terminal 1. All right? Also, if our answer is equal to domestic, I would like to call our terminal 2 function. And then our other option would be international, and I will make an expression for this. So I'll say, instead of just saying else, I will say international, and then I will say terminal 3. And what I could even do here is I could put an else, and I could just say else. You could print off something like there is no other terminal. Okay. Now, in order to get this to work, all I need to do is call our main function, so flight check, right? And by calling flight check, it's going to run inside, ask us an input, and then it's going to be able to call the other functions. Okay? So I'm going to run it. Okay? So our flight check. Now I will start off, I will say budget. There we go, departing from terminal 1. So it's calling the terminal 1 function, and it tells me the budget. And then it recalls our main function again. So you could go through, right? Terminal 2. If I say 4, there is no other terminal. And it automatically ends, right? So I don't have a loop here, but it is going to keep repeating until I enter something that there is no other terminal. And then that would end that function, right? So we're calling functions we made within other functions. All right, very nice. And that brings us to our final challenge. So in the final challenge, I've actually put together a really popular one. Making a BMI calculator. And this is a popular challenge that's done in a lot of different programming languages, and it's a good learning tool as well. So let's create a first function, and its job is going to be to calculate our BMI and return those results. Okay, so I will create one called calculate BMI. And this is going to take 2 parameters. It's going to take weight and height, because we need those to calculate. I can have one called calculation, and that's going to be equal to our weight divided by height times height. I can then return those calculations to be used in other functions. Our second function, I want to basically check and show the results. And I will call my calculate BMI function within show results, which means I will be needing two parameters again of weight and height. And I can create a variable called calculate, right? And that's going to be equal to my return response. So here I can call my function that we just made, and whatever my parameters are, they will be passed into this, right? So I give my arguments to my function, which has my two parameters, and then these will then go into the arguments of my calculate BMI function. Cool. I can then make conditions, and I can say if calculate is less than or equal to 18.5. So I am doing this in kilograms, right? So if you guys want to do it in pounds as well, that's great. Go on. I don't know the exact calculations for pounds, all right? But you can go on and just put those numbers here instead. So if my return response is less or equal than 18.5, you are considered underweight. Okay. Also, if my return response is going to be over 18.5 and it is less than or equal to 25, that is considered a normal BMI. Okay. Else, anything else that you're given, you would be considered overweight. There we go. So I've made two functions. Okay. Calculate BMI is called and used within my show results function, and it's held as the value to my variable calculate. So this calculate, the value will become whatever we return in calculate BMI. Our next steps is we want to create a loop for the number of people there are, which means we need to collect how many people there are. And this is going to be done through an int input. And I can say enter number of people. And we can structure that by using a for I in range loop. And our range will be however many people that we have. For each person, we need a weight. Now, weight is going to be a float input, right? Because it's going to be a decimal. So enter weight. Our height is also going to be a float. And it's because we have a possible decimal entered for your height as well. So I can say enter height. Okay? And then for these functions, I want to then call my show results function, and I want to give it my weight and my height. The two inputs that I collected right there. All right? So when I run, I should be asked people, and then it's going to run that many times by calling our show results function, which then is going to return our calculation that we collect inside calculate BMI. Okay, so we're running. I will say two people. The first weight, let's say 70 kilograms at a height of 1.95 meters. Underweight. Okay, let's try this again. Let's say you weigh 100 and you are 1.9 meters. You are overweight. Right? So I'm calling a function within another function. Amazing, guys. We've worked through a lot with our functions and creating them. Try to be making your own. Give parameters, give arguments, and do something you're passionate about because that makes it easier. I will see you guys over in our next lesson where we will introduce the new topic of modules. All right, guys, welcome to lesson 10. In the last lesson, we looked at defining and creating your own functions to reuse code throughout your programs. In this lesson, we are going to be working with modules. Now, long story short, a module is extra Python code kept in a cloud, right? So we don't have access to the cloud unless we import the cloud. And that unlocks a bunch of other Python functions and libraries we can use throughout our program to help us solve problems and complete what we're trying to build or do. Let's take a look at what I mean. So, a Python module, it's extra code to complete special tasks that we can import into our code to use in our projects. And all of these modules come with functions. And these are pre-programmed functions. So you don't need to define your own, right? It's kind of like all the other built-in Python functions we've learned. Print, input, int, right? Those are pre-built functions. And anything we import from the cloud, they also come with pre-built functions to achieve special tasks. Now, there are endless Python modules, but on the screen here, I have just put 4 different Python modules. And 2 of these we are actually going to use throughout this course. So I'm going to go through these modules, and the first one being the random module. And this allows us to work with random numbers in Python, right? It allows the computer to generate a random number, for example. We have the pandas module, and the pandas module is for working with different types of data. So, for example, you could give it a CSV file, and you could go through this file to search for specific data and break that data down. We have the Pygame module, and this is used to build 2D games in Python, which we are going to see later in our course. And this is actually a great module because it reinforces everything that we've been learning and will learn in our course to really put your skills to the test. And the last module I've included is the NumPy module. And this is used for working with data analysis in Python, right? And then on the bottom here, right, we have the built-in Python. So everything we've worked with so far, that just comes with Python. Anything else we want, we need to import into our code to be able to use. So, how do we import a module? Okay, now I'm going to use the random module as our example here, and we will use this in the next lesson. But importing a module, no matter what it is, it works the same way. We have 3 ways we can import a module or components of a module. Now, number 1, we can say at the top of our code, import and then the name of the module. And this is best used when you're learning how to use modules and how to use a specific module, which I'm going to show you why shortly. And this connects the entire module, but you still need to state which module it's coming from, which can be a bit tedious and it can add a bit of extra code to your program. Number 2, we have our second import method. We have from the random library, I want to import the shuffle function. So instead of importing the entire module, I am importing one specific function from that module. And this is great when you're working with larger modules. So it doesn't overrun your system. It doesn't make things go slow. And all this is doing is importing one function, which in this example is called shuffle, from the random module. And in our last way of importing, this is probably the most popular and it's the easiest way. But you should not do this with any really big library because that could overrun your system. We have from random import star. And what this literally translates to is from the random library, I want to import everything. Okay, so everything that comes with that specific library, in the example random, I want it all so I can use it in my program. Okay, so let's look at how to create your own module and how to get this in our code. But more importantly, why is that useful? Organizing our code with modules. What I'm going to do first is I'm going to move me down here. Okay, so creating your own modules is great because it structures your code and it organizes it into different files. And we can store all of our functions, for example, in a separate file, like here, and I can import this to my main file and still have access to all of my functions. And this allows for a cleaner main file, and it allows us to structure it much better. Okay? So far, every lesson, what I've been doing is I've been creating a new Python file for each lesson. If you've been doing that too, great. You're already on the right path to creating your own module. In the left, I have a Python file that's called functions.py. And inside the file, I have defined 3 functions. I have print name, print age, and print country. But now remember, these functions are not doing anything because I have not called them. In the functions.py file, we are just creating them and defining them. Now, in my main py file, this is where all the code really runs. And the first thing that I'm doing is we're importing the functions module, right? So from the functions module, I want to import everything. The functions module is the name of the module that we created. Now, in my program, it's going to run like normal. It's going to print, hello, welcome. It asks me for 3 inputs, and then I am calling the 3 functions that I made in my functions.py file. And it's going to run the same way. But this is allowing us for cleaner code and more readable code as well. All right. We are going to head over to VS Code, and I'm going to use a few of the functions that we learned in the last lesson, create a module for those functions, and import those so we can practice how to better structure our code before moving on to any of the fun Python modules. I'll see you guys in VS Code. All right, here we are in VS Code. In this lesson, we introduced creating your own modules, which helps us structure and organize our code in a better manner. We looked at 3 ways to import from other modules into our main file. So, on the screen, I want us to begin with refactoring code we made in the last lesson of functions. And I have our BMI calculator, and I have the multifunction terminal challenge we did as well. If you guys want to try this on your own, pause the video here. All right, I'm going to jump into the first one, and I'm actually going to delete the second one for now. Okay, so currently I'm in a file called bmi.py, and this is going to be, for all intents and purposes, my main file. We want to create a module for our BMI calculator that we did in the last lesson. Our functions should be stored in a separate file from our main file, which I'm in now. And I only want you guys to import the function you need in order for your code to run into this main file. All right, so which of the 3 import methods did we learn that you can do that with? So, in a separate file, okay, I have all of the functions we did in the last lesson. We don't need to code. We can just use the code we programmed in the last lesson to split them up and create modules. Before I do that, I need to create a new file that's going to store all of my functions. So in the top left, I'm going to create a new file, and I'm going to call this BMI functions, giving it that pi extension. Okay, I can close that, not needed. From our BMI calculator, I'm going to copy and take those 2 functions, and I'm going to put them into this new file I just created. This is my module. Now, I'm done with this module page. I'm going to close out of it. I can take our main program code, and I'm going to put that into my new main file. Now, this is all we need for it to work, but I do need to import the one function we need. The one function we need is show results. And this is the function that actually calls the calculate BMI function. So I don't need both, I just need the one. At the top of our screen, we are going to import the show results function. So we can do that by saying, from our BMI functions module, I want to import our show results function. Okay, so I'm going to this new module that we created, and I'm importing this one function to use in our code. If I go and I run, all right, it's going to enter the for loop by asking us for number of people. I'm going to say there are 2 people. The first person I'm going to say has a weight of 75 kilos. Their height is going to be 1.85 meters. They have a normal weight. My second person can have a weight of 55 and a height of 1.45. That person would be considered overweight. So my code is working exactly how it did in the last lesson. But now we refactored it. We structured it in a way to make it more organized and much more easier to interpret and read. Amazing. All right. I'm going to close out my terminal. I actually created another file for the second task I originally had. In our last lesson, our other bonus challenge was creating 4 functions, and this was the terminal challenge. We created a main function which checked a condition, and that called either terminal 1, terminal 2, or terminal 3. So what we want to do here is we want to create modules for that challenge. So what we're going to do is we are going to create modules for our multi-function terminal challenge, just like the last lesson. All of our functions should be stored in a separate file. And you can use any of the 3 ways to import that we learned. All right, so start thinking about what methods did we learn to import. You can use any of those. In our main file, where I'm at now, we want to create a loop to run the flight check function. And before we get in that loop, we're going to ask the user if they want to check their flight. If they say yes, we are going to call the function we need. If they say no, you can print something off. And our loop only stops when the user enters quit. All right, so let's create some modules. We can go up and we can create a new file for our module. I'm going to call it terminal.py. We don't need that anymore. From our previous challenge, we can take everything we did, because they are all functions. And I'm going to place those into my new module, which is terminal.py. Great. I can now head back to our main file. And in our main file, this time I'm going to import everything. So I'm going to say from terminal, that's the name of my module. I want to import everything. And that's going to gather all those functions and bring them into this file. Now we're going to create an input that we can use for our loop. So I'll just call it question. And this is going to be equal to an input. And I'm just going to say here, would you like to check your flight? And you can make it lower if you want to. To begin our while loop, I will say while my input is not equal to quit, then every time the loop runs, I want to check if in that input they entered yes. If they did, we can call our flight check function, which is defined in our module terminal.py. I'll say else, and for my print here, we can just say you did not say yes. Okay? And remember, with the while loop, we always need a way to break out of it. And a really good way is taking your initial expression, in this case it's our input, and placing that at the end of the loop. That's it, we're done. I'm going to run my code. Our first question is going to pop up and ask us, would you like to check your flight? I will say yes. And then our next question is coming from our module, right? In the module, if I go over to it, it's now asking this question here. Is your flight budget, domestic, or international? So I'm going to say domestic. And it says your flight is departing from Terminal 2. Okay, I could try it again and budget. It's departing from Terminal 1, right? Anything else that would end and it would bring me back to our main file. Would you like to check your flight? Quit. And that would end our program. We have broken that down to 8 lines of code. All right, very nice. All right, so I'm going to turn this off, even though I don't quite need to. Okay, and I'm going to bring us over to our challenge that I've put together. So this is a lot. I encourage you guys to pause the video here, read through my task, and try to find a solution on your own. If you're up for it, pause now. Okay, so in our challenge for modules, we want to create a program to determine the salary for full-time and part-time employees. We will have 2 functions, one function for full-time, one function for hourly, and these will be held in a separate file or module. The hourly function will accept hours worked with a rate of $25 per hour. In that function, we are going to multiply their hours worked with their rate, and we're going to return that value. Okay? So I'm going to begin on that one, actually. I will go over and I will create a file calling it functions.py. Okay, so our first function was for a part-time function. So I could call it part-time. And this function took the number of hours worked. It took a time, right? So hours. They had an initial rate of $25 per hour. So variable equals 25. And their paycheck is going to be based on the time they worked multiplied by their rate. And then we can return that paycheck. right? That was it for the part-time. Okay, I'm going to give them like 10 hours. I would do 10 times 25, and that would result in a paycheck of $250. Okay, on to our second one. The full-time function will accept EXP, or experience, for years worked. They have an annual starting pay of $25,000. If they worked from 2 to 4 years, they will get a 1.5x raise and a bonus of $500. If they worked from 4 to 10 years, they will get 2x their pay and a bonus of $1,000. If they worked over 10 years, they get a 3x raise and their bonus will be $1,500. Anything else, they do not get a raise and their bonus is only $200. All right, so I'm going to head over into my module and I will create a new function called full-time, and it's going to take experience. We know that their annual salary starts at $25,000. I'll create a variable at the top for their annual salary. And then we just need a few conditions. And I can say if their experience is over or equal to 2 and experience is less than 4, all right, then their annual, right, well, not really an annual, we want to add 1.5x onto that. So I could just create a variable called extra 1.5, and they receive a bonus of 500. All right. Also, if experience is greater or equal to 4 and experience is less than 10, they get 2x their salary, and their bonus is going to be 1,000. I'm going to put also if experience is greater than or equal to 10 years, it's a lot of time, they will essentially triple their salary, and their bonus is going to be $1,500. Anything else, they don't really get an extra. So you could do this. You could just say extra is equal 1. 1 times the annual salary stays at that. And then they only get a bonus of $200. Okay? And that's my condition. So it's going to take my annual salary, and I have my experience, which is passed in as our parameter above. Throughout our condition, we are checking what their experience is. Finally, in this function, I can take my annual variable, right? I'm going to say annual initially, I need to multiply it by our variable extra. So annual times extra, right? And that's going to give them their pay raise. And then I can add on their bonus at the end. After I get their new annual salary after their raise, I'm adding on that bonus. And finally, I can conclude with returning their annual pay. Let's see here. I missed an equal sign, so I'm going to throw that in. Experience is greater than or equal to 4. I'm going to throw that in. Okay. Back in our main file now, okay, I want to import from there. So I can say from functions import star. That brings in the functions that I just made. And in our main program, we want to create a loop to start and quit the program. I'm thinking as like I'm a bookkeeper, right? So maybe a count. And I could say it's going to be an int input. You could just do an input, right? And we could say like 1 is going to run the program or 2 is going to quit the program. While our input is not equal to 2, then we're going to gather the employee's name and the type of employee they are. Are they a salary or hourly employee? So let's gather the name. So employee equals input. And we can say name of employee. Okay. We will ask for employee type. And employee type is also going to be an input. And we can ask here salary or hourly. And for this one, I might want to make it lowercase because that'll be our condition. Great. Now, jumping into our conditions. If the employee type is hourly, it's going to ask for the number of hours worked and use the hourly function as the value to a variable. So I want to start using the functions we have in our module. If employee type is equal to hourly, then I'm going to ask for the time worked. So how many hours did they work? So hours worked this month. Let's say that. Okay. I can create a variable called pay, and I want to call the part-time function that we made in the module. And as the argument, I'm going to give it the time input that we made. If I say I worked 10 hours this month, it's passed into the part-time function. Also, if our employee type is equal to salary, well, that's slightly different. We want to get their years of experience. So I could say years on the job. Right? Because I'm in a condition, the variables are only applying to the condition. So I'm going to keep with the same variable pay. But this time, I'm going to call the full-time function and pass in my experience. Anything else, I can just print off, you don't have a job, ... Okay? Once my condition is done checking, I want to give back the employee's name and their expected salary. So I will create another print, and I'm going to say the employee, okay? I'm going to put in a string, and you could say salary of, or whatever you want to say there, and then pay. And then, because we're in a loop, I'm going to take this and I'm going to paste this at the end of the loop to ensure that I'm able to get out of it. Okay, and that concludes our challenge. All right, so let's give this a try. I'm going to run. And I am going to run it. So 1. Name of employee, Bob. Bob is a salaried employee. Years on the job, we can say 5 years. Right, there we go. So Bob, salary of, he will now get $51,000 a year. Okay, I'm going to run that again. And this time I will say Jason. He is an hourly employee. Hours worked this month, let's say 55. There we go. So this month, he's expecting $1,375. I am multiplying 55 by his hourly rate, which was $25 to get that. Okay, and I'll just say 2 to quit. If you were able to keep up with these challenges, you should be feeling pretty good. We've done a lot so far, and it's only going to get better and more challenging as we continue to work on. But you guys have a great foundation that we're building on, and we're only going to continue building. Well done. I will see you guys in the next lesson. All right, guys, welcome back to lesson 11. In the last lesson, we learned how to create your own modules in order to structure our code in a more efficient manner. Now, in this lesson, we are going to introduce the random module. It'll be the first module that we will import, which already has functions for us to use throughout our program. Let's dive in. In this module, we have 3 popular functions, and these are the ones that I'm going to introduce for us. If you guys want, you can go to Google and just Google the Python random module. there are plenty of other functions which you can import and use in our code. These are just 3 of the most popular, and we will focus on using these in our programs. In our first function, we have a function called random. And if you were to call this function, it's going to generate a random number from 0 to 1, or more specifically, 0.999, etc. In our second function, we are going to be using this quite a lot. We have randint. And if I were to break this down for you, it would be 2 words, randint, or random integer. Randint accepts 2 arguments, or 2 numbers. So in this example, I've put 5 and 10. And what this is going to do is it's going to generate a random number from 5 to 10. Every time you call this function, it's going to give you a new random number between these 2 integers. You could put anything there. You could put 1 and 100, 20 and 80. It's up to you to decide. And the last function we will be looking at later on throughout our course is called shuffle. And shuffle allows you to shuffle a list or mix it up. It's just like if I gave you a deck of cards and I say, hey, can you shuffle up this deck for me? It would do the same thing. Once we introduce more advanced topics like lists, we will incorporate the shuffle function. Let's see how we can use randint. So at the bottom here, I have just put 2 lines of code. I have a variable called random number, and the value of this variable is randint, which is going to produce a random number from 0 to 100. When I print off my variable, the output in my console is going to be a random number. In this example, I've said the number is 56, but every time you run your program, that number is going to change. It could be 20, it could be 82, anything in between 0 and 100. Okay. Before we can look at any code, we need to remember the 3 methods we spoke about in order to import a module. In the first way, we can import random. Now, import random, it does import the entire library, but you still need to tell Python where is this function coming from. In the example, I have a variable called guess, and the value of guess is going to be a random number from 5 to 10. But randint, we need to link to the random library. So random.randint. While this does mean you need to type more code, this is also a good way when you're learning how modules work. It can better help you understand your code and which function is coming from where. The second way is if we need to import one function from a module. In this case, right, I'm saying from the random library, I want to import the function randint. And instead of importing the whole library, I am just taking that one function I need for my program. If we were to create code for that, I'd have a variable, and the value of the variable is randint. The third and final way, which is the most popular, is I could import the entire library from the get-go and make it ready to start. I would be saying from the random module, I want to import everything. And the structure of this would be the same as the previous import. I can create a variable and the value is randint. Very similar to the way that we imported randint in the previous import. All right, let's take a look at some code on how this would actually look. So, in my example, I've created an example that we're all used to and it drives us insane, but it does happen. An airline needs to decide which flight to book overbooked passengers on. The program is randomly assigning one of 3 flights to each guest. Guys, anytime that I say we need to randomly do something, I want you to immediately think about the random module, because most of the time that is what we will use to achieve so. So we start off with, from the random library, I want to import random. I only need that function, so I'm only going to import that function. All of our imports we want to keep at the top of our code. In the second line, I have a variable passenger, and the value of passenger is an input. So we can enter a passenger's name. If we want to quit our loop, we would enter quit into our input, right? So while passenger is not equal to quit, our loop will continue running. Every time this loop runs, my variable flight number is being updated with a new random number from 1 to 3. I then can print off the passenger's name, their flight number, and whichever random number my variable gave me. We then end our loop with asking for another input. Remember, we always need a way to escape the loop. If we don't have a counter variable, the second most common way is you would have another input here at the end of our loop to recheck our expression. If I were to break this down further for us, it would look something like this. Okay, we start off with our imports, our loop runs until quit is entered, the flight number variable is holding that random number, which is changing every time the loop runs. And then finally, I can print off the passenger's name and which random flight they are assigned to. All right, in the challenges I have prepared in VS Code, we are going to be using random, and I have created a few tasks for us to work through. Let's head over to VS Code. Here we are in VS Code. In the lesson, we introduced the random module and 3 functions that come with this module. In today's challenges, I want us to really be working with the random function that comes from random. I have prepared 4 challenges. I want you guys to pause the video, read through these challenges, and give them your best shot. They should be challenging as well. If you're struggling, you can go back through the slides or use your terminal to help you find your errors and fix what you need to. I'm going to begin here with number 1. If you want to give these challenges a try, pause the video here. All right, number 1. I will give us some space and I will zoom in a little bit. I want us to be using the 3 import methods that we learned. So in the first one, I'm going to say import random. Next up, we are creating a mini lottery program. I will assign a variable a winning number and another variable a random number. We then can show the random number with print and check if the winning number is equal to the random number. I will print you win a free trip. Otherwise, sorry, you didn't. I have imported random. Next, I will create a variable for my winner. Pick any number you want. I will then create a variable that is going to be equal to random.random. I need to say which library it's coming from because how we're importing it is import random. So I want it to produce a random number from 1 to 500. I can put that like so. I will then print off, and we will print off winning number and my random number. At this stage, I'm ready for my condition, and I can check if my current, which is my random number, is equal to the winner. If it is, we will print off you win a free trip. Otherwise, we can print off and say, sorry, you lost. Like so. Let me run my program and let's watch what happens. My terminal fires up. Okay, so the chances of me getting the correct number are very small. It's a random number. So the winning number is 271, sorry, you lost. I could run that again. It's changed the winning number because it's choosing a new random number. Again, a new random number. Right? So now that's us seeing how that can actually work. So Randant is deciding for us. Good. Let's close the terminal out. I will turn off all of this code, including my import, and we can go down to number 2. Number 2, we want to create a program that assigns passengers to 2 different flights. I'll ask the user if they want a new flight. If their answer is not no, the program continues. Read that part again. What do we need in order to achieve that? I'll create a variable for the random flight number. If the random flight is equal to 1, I'll increase a counter by 1. If that random flight number is equal to 2, I will increase another counter by 1. At the end of the loop, print off the number of passengers on both flights. Okay. To begin things, let's try the second import method. So from random, I would like to import random. I want that one function from random. I now need 2 variables because I'm going to have 2 different flights. And these will act as counter variables, which I can increase as my loop runs. Next, I'm going to create a while loop. So I could call this ask. It's going to be an input, right? So I need this input for my while loop as my expression. What we can say here is we can ask the user, would you like to book another flight? I will make sure that this is lowercase and begin our for loop. So while ask is not equal to no, and that's our keyword there, I then want to create a random flight number. So this is very similar to us working through the slides. I can say flight number is random, and it's going to be one of 2 flights, so 1 or 2. I will then print off the passenger's new flight number. So I will say flight number, and we can also give it the random number, which was our flight number. All right. I can then create my condition, and I can say if the flight number is equal to 1, I want to increase our flight counter of the first flight by 1. Else, the other random number must have been flight 2. There's only 2 options. So I want to increase that counter by 1. At the end of my loop, we want to make sure we have a way to break out of it. So let's take our input again. And finally, I can print off 2 things. So I'll say number of passengers on flight 1, and we will put in our counter variable flight 1. I will then copy that print, and we can change it to flight 2, like so. Let's run our program a few times. When the program runs, it's not really looking if you entered yes. It's looking for anything besides no. So I could say yes. It says flight number 2. Would you like to book another? I will just start to enter A. And you see how my random numbers are changing. I will now enter no. There we go. Number of passengers on flight 1 is 7. And the number of passengers on flight 2 is 3. Every time the loop ran, it decided on a new random number. And most of the time, we got the number 1. 3 of those times, we got the number 2. Brilliant. Okay. Closing that out, turning off my code, we are going to move on to challenge number 3. In challenge 3, I would like to create a guessing game. So I will create 2 variables, one with a random number and the other with an input. If the input is too low, print too low. If the input is too high, print too high. Otherwise, print congrats, you got it. Pretty straightforward. Let's begin. I will say from random import star this time. That's our 3rd import method. We then create an integer input because we are checking for numbers here. And we can say guess a number between 1 to 10. I can then create my condition. If my guess is less than a random number, I need to create that random number as well, which I could do right here. I could say random number is equal to randant, and I will say 1 and 10. I can now use that variable here in my condition. So if guess is less than random number, we want to print off too low. If the guess is greater than the random number, we are going to print off too high. And I want to put an else in here, so I'm going to change this to elif. So else, print off, you got it. If you're not too high and you're not too low, it's equal to that correct number. So, wow, you got it. Like so. Let's run it and let's watch what happens. First up, guess a number between 1 and 10. 4, too low. I could try it again. I will say 7, too high. Now, I'm seeing a problem here. The problem is it's only allowing me to do it one time, and then I have to run the program again. That doesn't make very much sense. I'm going to refactor this program to allow us to do that until we get that correct number. This is the challenge in number 4, refactoring the program. In challenge 4, I would like to improve it. So we want to add the ability to continue guessing until we get the right number. We should be thinking about loops here. And once the random number is guessed, we print congrats, and the number it guesses, it took the user. That's important. So how many tries did it take the user to get the correct number? Let's begin. From random, I would like to import everything again. That's the easiest way for this library. I will create a variable just like last time, and we can say int input because it'll be an integer, and I can say enter a number from 1 to 10. I will then create my random number variable with the value of randant, holding a random number between 1 and 10. All right, now begins the loop. We are going to be nesting loops in order to achieve this. While our guess is not equal to the random number, I would like my loop to begin. But every time this repeats in a way, it's going to change the value of that random number. I do not want that to happen because I want to continue to guess until I get it correct. I will create a variable, you could call it, let's just call it x. And the value of x is whatever the random number was that first time. I then have a counter variable because I want to store the number of tries it took the user. It doesn't matter if the user got it on the first try. They still took one guess. So my counter starts at 1. Now that I have two stationary variables, I can use that data in another loop. So while the random number is not equal to guess again, if my guess is less than my random number, we will print off just like we did before, too low. Also, if our guess was greater than the current random number, we can print off too high. And for each of these, I'm increasing the number of tries. So you could say here, tries plus equals 1. And for this one, tries plus equals 1. Like so. Okay. At the end, I would like to ask my input again. This will be asked inside the child loop before I print off two final statements. I can print off congrats, you got it. And I will also print off the number of tries. So like it took you tries. Like so. So take a look at our code. Are there better ways to do this? Absolutely. There are more than one way. There is more than one way to solve this. But I'm trying to break down these lessons for you guys, which it may be a bit longer, but I want you to be able to easily read and understand what's happening here. Let's run it. It will begin by asking us for that random number. I will start with 2. So I entered 2. It automatically broke. It didn't tell me anything, which means I got the random number. I'm going to run it again. Let's enter 5. Too high. Okay, so 5 is too high. I'm going to say 4. Too high. 3, 2, 1. Right there we go. So the random number was 1. Congrats, you got it. It took you 5 tries. Great, guys. That was us working through the random module. As a challenge, we will work on this later in the future. There's always a chance for that. But as a challenge, I want you guys, I'm not going to make a video for this. I want you guys to make a rock, paper, scissors game. You are playing against the computer. You can enter rock, paper, or scissors, and the computer is going to randomly choose one as well. Use a loop and use conditions to see who wins. And this is a popular exercise of creating rock, paper, scissors in Python, using loops, conditions, and the random library. I'll see you guys in the next lesson. In this lesson, we are going to be looking at another Python beginner-friendly module, and this module is the time module. Anytime we get working with the amount of time that has passed, we want to start to think about the time module. So imagine creating a stopwatch or a countdown timer. We would use time to do so. Let's take a look at the two functions we will use in our time module. The first function from this module is actually called time. Now, time is a strange function because it's going to return the number of seconds since the beginning of the epoch, which means it's going to return the number of seconds that have passed since January 1st, 1970, which is a lot of seconds. So for example, if you print time, it's going to return the number of seconds that have passed since this date. And as the time that I'm recording this, that is actually 1.68 billion seconds, right? So that's really long. We don't usually need all of this, but we can do equations to get the number of seconds that have passed in our program by changing this value. The next function is called sleep. And sleep is like a way to delay your program for a number of seconds. So if I said sleep 5, your program would wait 5 seconds before running. Here is an example of how we could use time. Now, this is actually some code for a stopwatch that we will create in VS Code. We start off with importing time, and the way I've done it is from time import star. I can import everything. We ask for an input from the user, as our stopwatch can only do two things. I can start it or I can stop it. And then my loop is going to run. So while my stopwatch is not 0, it's going to check if the stopwatch is equal to 1. If that's the case, time begins. And we begin this by creating a variable that holds the value of time. So when Python reaches this line of code, time begins. And yes, the time would begin at this long number. Once we end our stopwatch by entering 0, we then have another variable called endTimer, and this also holds the value of time. Now, this will be a new updated version of time with however many seconds have passed since this. In order to get the number we're looking for, we need to take the end time and subtract that from the start time. And that would give us our total of the realistic value of the number of seconds that have passed since our stopwatch began. Here it is in a bit more detail, okay? So when the timer begins at start time, we are starting on this long time, and I've underlined the last 34 seconds. If I allow this timer to run, the value of time is going to change by 30 seconds. So in order to actually get 30 seconds, we need to subtract the end timer from the start time, which would look like 64, or 1.68 billion in our 64 number, minus the start time. And that would produce the output that we're looking for, which is 30 seconds. And finally, I'm going to introduce a new function. So in Python, there are many times that we need to round numbers down because we don't want to deal with long decimal numbers most of the time. Usually, we just want 1 decimal or 2 decimal numbers. So we need to shave this number down. And good practice for this is using time because it's producing such a long decimal point. Round is actually a built-in Python function that we haven't addressed in the previous lessons because we haven't had a need for it yet, but now we do. How round works is round function takes two arguments. It takes the variable of what do you want to round down, and then it takes an integer. So this integer will be the number of decimals you want to keep after we round it down. If I were to structure this out, we have our initial variable total time, and the value of that was the time function. I could create a new variable called updated time, and the value is round, and I'm going to round the total time down to 2 decimals. If I put some code together for that, I could set it up like this. And I've done it in 2 ways, right? So the first time, we rounded down to 3 decimal points. And our output would cut everything off except the last 3. If I wanted to round it down to 1 decimal, I would just have to change the second argument to 1. And that would shave the value down even further. All right, so far in this lesson, we have introduced the time module. And 2 functions with the time module are the time function and the sleep function. We can import these the same way we import any other module. One additional function that we just introduced was the round function, which allows us to round down a number. Let's head over to VS Code and put the time module to work through a few challenges. I'll see you guys in VS Code. I have created 3 tasks for you. One of them is going to be very similar from what we saw in the slides of the stopwatch, with more added bonuses. We have a countdown challenge, and then we also have a challenge that calculates a download file size and how long it will take based on a user's internet speed. If you're up for a challenge, pause the video here and give it a shot. All right, jumping into number 1. Let's create some room on the screen. So, number 1, we want to create a timer very similar to the one in our slides. The user can enter 1 to begin or 2 to end. Once the timer is complete, we want to print off the time that has passed, rounded down to 1 decimal. I will begin right there. So, let's import time. So, you can choose one of the 3 ways to do so. From time, import star. I will create a timer input. You could do this with just an input or an integer. It's completely up to you. 1 begin, 2 end. There we are. I want to make a loop to repeat because the loop will only end when I choose to end the stopwatch. So while my timer is not equal to 2, this loop begins. I then also must check if I entered 1, because I could have entered anything, but the stopwatch only begins when I enter 1. So if timer is equal to 1, I want time to begin. So let's create a variable called start timer. The value of this variable is the time function. Every time my loop runs, this is all it's doing. It's updating this timer. So I always want to have at the end of my loop our question to check and make sure that we haven't chosen to end it yet. This is not in my condition, it's in the loop. Outside of my loop will be our end timer variable. Python only executes this code once we get out of the loop, which means this will not begin until I enter 2 to end my loop. We then need to create a total because we need to do some math. And I need to do end timer minus our start timer, like so. Now that we have the total amount of time that has passed, we are able to print off rounded down to the nearest decimal. If you guys want, you could also convert this to an integer just to be safe. Most of the time, time is producing an output that is equal to an integer though. So let's say print, and in my print I will say time that has passed, our total variable, and then I will say seconds, like so. So let's give this a try before I move on with this current challenge. We are going to begin. I will say 1, enter. Now I'm just here waiting. I'm not doing anything. It's not telling me anything. Time is just passing. I'm ready to end my stopwatch, so I will enter 2. There we go. Time that has passed 11 point all this seconds. Remember, we want to round down to the nearest decimal. In our print statement, I can use the round function. The round function takes 2 arguments. What do you want to round down and how many decimals do you want? I would like 1. I'll run this again, and this time, I'll just say 2 to end now. There we go. Time that has passed, 2.6 seconds. We just built a stopwatch. All right, let's imagine you're in like a race. I would like to then check if it was less than 10 seconds and award whoever it was 3 points. If it's between 10 to 15, award them 2 points. Anything else, they get 1 point. We will then show the number of points that they were awarded. We should be thinking about how we can do this, and you should have a pretty good idea at this stage as well. Counter is equal to points. If the total was less than 10, wow, good job. They are going to get their points plus equals 3. I should be saying point because that was the name of the counter. Make sure it matches. Also, if our total is greater than or equal to 10, and our total is less than 15, then their points is going to be increased by 2. So point plus equals 2. Anything else, it means it was over 15 seconds. We are just going to give them 1 point for that. Too slow. I will then print off, and we can print off, you were awarded, let's try that. You were awarded, and I would like to insert my point here, so point. Like so. I'll run the full program this time. Let's try and go for 3 points, so keeping it under 10 seconds. Give it some time. 2 to end. There we go. That was 4.2 seconds. I was awarded 3 points. Great, guys. Our first time challenge has been completed. Let's turn this off and progress on to the second challenge. Our second challenge, we would like to create a countdown clock. So think New Year's Eve. For this, consider using a loop with a counter variable. I can use this as my expression. Every second, I would like to print off the current second, and when it ends, I would like to print off your countdown finished after how many seconds. This is slightly opposite to a stopwatch. And instead of using time, I won't actually be using time. What was the other function that we learned with this module? That's what we'll be using. So I'm going to say from time, import star. I then create a variable called like countdown start. And I would like to be able to enter a number. So if I enter 10, my countdown will start from 10. If I enter 5, it would start from 5. So we have an integer here. So enter a starting number, like so. I then want a variable that's going to hold the value of whatever I enter into this input. So if I enter 10, this new variable should be equal to 10. To do that, I could just say countdown is equal to countdown start. So whatever I enter into countdown start is given as the value to this new variable called countdown. Now our loop can begin. While. We want it to keep repeating. While this new countdown is greater than 0, it will continue. Every time this works, I would like to print off the current number it's on. I can then subtract 1 from my countdown. So if it's 10, it's going to print 10. 10 minus 1, it would go to 9. Before my loop repeats, I would like it to wait 1 second. I want it to sleep or delay for 1 second. Once this loop ends, and it's going to end once we get to 0, it will automatically break. I can just say something like, your countdown finished after countdown seconds, like so. Let's run it. I will enter, let's say 10, and just watch it go. There we go, ticking down our time from 10. Once we get to our final one, there we go. Your countdown finished after 0 seconds. That's a problem. What was done wrong? Well, countdown is being updated every time this loop runs. So initially, yeah, countdown is 10. But because it's changing, it's telling me after 0 seconds. I don't want to print that off. Instead, I would like to print off my countdown start. That way it saves that value. And this time I'll do 5. It'll count down from 5, and then ideally, we are going to see it print off. There we are. Your countdown finished after 5 seconds. Great. We are going to use a chunk of this code here in the final challenge, which is going to be slightly harder. Let me close this. I'm going to turn this off just because I would like us to be doing this again. Repetition is key. We want to create a program to calculate the time it takes to download a file. We ask the user 2 questions: file size in megabytes and internet speed in megabits per second. Convert the file size to megabits. So if you don't know, 1 megabyte is equal to 8 megabits. Then calculate the download time. Display the number of seconds the download will take, and use our countdown timer to display the download process taking place. Cool. We can finally end this by printing off download complete. If you guys would like to read through that again, this is a longer problem. To begin, we will import time. So from time, import star. I am then going to gather a file size from the user. This will be an integer collected through an input. Our question here is, what is the file size in megabytes? That's what we're after. Next up, I need the user's internet speed. So I can say internet speed is equal also to an integer that we will collect through input. So for here, just ask, what is your internet speed in megabits? I'll put it like this. So per second is what we're asking. Great. Now what we need to do is convert the file size to megabits. So to do this, I could just take my file size, I can multiply it by 8, right? 1 megabyte is equal to 8 megabits. That's done for us. That's been converted. We now need our download time. So what math expression can we do to get our download time? Well, our download time is going to be calculated by the file size divided by our internet speed. I'm trying to put spaces here for readability. Let's keep these two variables together. We will print off the estimated number of seconds. So time to complete download. And inside here, we will just put our download time. And I'll probably put seconds, like that. That makes it better. Let's use a loop now. So I would like to use a loop very similar to before. And I would like a variable for this countdown to be, so my loop can check if it's greater than this countdown, or if this countdown is greater than 0. Currently, download time is a very long decimal number. So we don't want the decimal. I would like to round it down for these purposes. So my countdown will be the rounded down version of my download time. From here, we can begin the loop. As long as this is greater than 0, I would like to print off where I'm at on my countdown. I would like my countdown to -1, and it will sleep 1 second. Once the loop ends, we would like to print off download completed. I'll run this. Let's say I have a file size of 65 megabytes. My internet speed is 45. Time to complete download, that wasn't rounded down, but our timer is rounding down. It's set 11.5 seconds. When this completes, download complete. Pretty cool. If you wanted to improve that, you could then round down your variable here. Maybe if you want to give it a decimal, I could include that in there. I go to run it again, let's say 44 megabytes. Let's say I have that speed. There we go. So I've rounded that down now to 11.7, which is easier on the eyes. My program is still running how it should. Once we get to our ending point here, our download is complete. Well done, especially if you followed along in this module. Any of these challenges you completed, you should be feeling pretty good. If you were able to get 3 of them on your own, amazing. As we progress forward, we are going to be entering some advanced topics here very shortly. Keep up the good work. I'll see you guys in the next lesson. All right, here we are in lesson 13. Welcome back, guys. This is going to be a big new topic for us as we introduce objects in Python and we start working with object-oriented programming. And this is one of the really powerful tools in the Python language, is creating and working with objects. Now, I want you guys to imagine, okay, there are a family of 4. In this family, they all relate to each other, but in their own way, they're all special. Well, object-oriented programming is kind of the same. Each object could relate to the same family, but they each have their own special properties that make them special. So, let's take a look here at our first example and breakdown. An object is a single similar item from the same group, but each object has its own properties and special characteristics, right? So up here I have car, and you can imagine car as a family. Specifically in Python, it is a class, but we will get into that later. Now, car, all of these are cars. They all come from the same family. And at the end of the day, it doesn't matter. It's a car. Now, all of these cars, they all share some of the same properties and values. They all have 4 wheels. They all have 2 doors. You could carry on to say they all have headlights, right? And be more specific. They all share similar things, but they each have their own unique properties as well. In my first picture, right, I have a blue car, and this car is a convertible. You could also say this car is a vintage or collector's item. Those are special attributes that only the first car has, but it's still a car. In our second car, I have a Lamborghini, and this is yellow, and it's a luxury car. It's a sports car. It's the fastest car of the 3, right? All of those are special attributes that only this car has. And then our final car, right? The thing that sets this car apart, you could consider it a vintage car, and it's a black car as well, right? So they all share similar things, but there are still attributes that set them each apart individually, and they are each their own object. So, other examples of objects. If you imagine in each of these boxes, so box 1, 2, and 3, we have like a family, and the family would be computers. But in the computer family, there are children, or each of these could be objects. We have MacBook, Windows, and Linux. But still, at the end of the day, if I ask you, do you have a computer? You would say yes or no, because it doesn't matter which one of these you have. You still have a computer, although each of them are slightly different. We have animals, right? And there are so many different types of animals. Cats, dogs, birds, tigers, bears, elephants, right? Now, each of these are very special and different in their own way, but they are still all animals, okay? And the same would apply for games. I could go on endlessly here, right? Everything in life has a family. It has a class of some sorts. And there are genres in that class. There are members in that family, right? So we have RPG games, shooter games, single-player games, but they are still all games, okay? Here's our example, right? So animals is what we would call and we will call a class, but it's basically like a parent. And the cat and the dog and all the other animals, they are all like children, or more specifically, they are all different objects coming from the same class. While they all come from the same parent, animals, they all have unique names and unique attributes that set them apart. We have 3 examples here, all right? So I want you guys to start thinking about classes. And the class is like the parent. And the children are like all the objects. And there can be many children in one family, just like there can be many objects in one class. Working with and creating objects. Before we learn how to create an object, we need to address 2 new terms. Each object has properties, and each object is controlled by what we call methods. A property, simply put, is a variable. I'll say that again. A property is a variable. The only difference is it is a variable in a class. Okay? A method, also simply put, is a function. A method is a function. That's all it is. But what makes it special is a method is a function in a class. So if I rephrase that, a property is a variable in a family. A method is a function in a family. On our left, I have property examples. Okay? Now the property for each of these are all the same. It's speed. But the object for each is different. We have airplane, we have car, we have boat, right? The first part is just like we are creating a variable, and every variable has a value. Well, a property is very similar. Every property has a value. So the airplane speed, the value is 500. The car speed is 50. The boat speed is 35. They are all the same properties, speed, but they are linked to different objects, airplane, car, and boat. And here we have a few examples of methods. Now these are just functions, right? So they should look the same. If you were to define a function called fly and you called that function, it would look just like that. It would have fly and then there would be a set of parentheses. But in order for a method to work, it must be linked to an object, right? So fly, I cannot just call and use the function fly. I need to link it after an object. So airplane.fly. And that function, that method would run. Car.drive, boat.sail. Okay? All the properties and all the methods must be linked to an object, and this is done after we create an object. Okay? So take a look here. If there's a key takeaway from this, please remember, a property is a variable in a class. A method is a function in a class. And they must be linked to an object in order to work. All right, let's take a look. I'm going to introduce a new module soon, and this is going to help us to understand how objects work, how we create them, and how we use properties and methods. So, here is a picture of 9 turtles. At the end of the day, it doesn't matter. They are all turtles. They are all from the same family or class. But they all have different appearances. And these different appearances are our properties. And each turtle may have a different action. These actions are our methods, our functions. So one turtle could move faster than the other. One turtle is red, one is purple, one is green. All right? They're all turtles, but they all do different things and they all look different as well. So down here in the bottom, I have an example. If I were to have a property, right, turtle color, its value is red. Okay, that's going to be the property of the first turtle. If I wanted to tell the turtle to do something and link a method, I could basically say, hey turtle, I want you to move 20 steps, right? Move is linked to the turtle object, and he would move 20 steps. So, how do we actually create an object? Now, you're going to hear me say 2 different terms. I'm going to say object a lot because I view that it's easier to understand. But technically, an object is an instance. It's an instance of a class. It's an example of a family member. And an object is equal to a class. All right? So here's a brief example. We always start with creating an object. Give it a unique name, right? An object is basically a variable, and the value of that variable is a class. So give it a unique name. Now, as I just said, an object is equal to a class. In this example, what we are going to be working with is the turtle class. Now, I've gone so far to tell you that everything must be lowercase in Python, with one exception, a class. A class is always capitalized, and it is always followed by a set of parentheses. Okay, so an object, right, its value is a class, and a class capitalized in a set of parentheses. Now that we've created this object, I can now use this object to change its properties and to give it methods or actions to do. I can take the same object, black turtle, I can set the color of this object to be the color black. I could tell my black turtle object I want it to move forward 50 steps. Okay, this is going to do an action. This is a method, forward. This is going to change its appearance. It is a property. So, if I were to put that into some code, before we jump into creating our own objects, our own classes, you guys should have a really good basic understanding of how objects, properties, and methods work. And there is no better way to do this than something called the turtle module. Now, the turtle module, it may seem like you think it's for kids. Well, it is fun. It does allow us to draw things and do things in Python. But it is a true hidden gem when it comes to working with objects, properties, and methods. And it reinforces everything so that when we go into creating our own classes, you're going to have a much better understanding of what each of them are and how to use them. So, in our code, we are going to use something called the turtle module. And to import the turtle module, just like our previous importing through our random module and the time module, I can say from the turtle module, I want to import absolutely everything. Okay, so from turtle import star. Once we have turtle going, I then can go through and create objects. Now it's good to keep your objects grouped together, right? If you're declaring all these properties to an object, it's good to keep them together. I have 3 objects. My first one is red turtle, and an object's value is a class. So red turtle equals turtle class. Purple turtle equals turtle class. And orange turtle equals turtle class. I now have 3 objects, but currently all of these objects are the exact same. They don't have anything that sets them apart from others until we assign a color to each of our turtles, right? So red turtle, I'm going to give it the property color with red. The purple turtle is going to have purple, and the orange turtle is going to have orange. Now remember, a property must be linked to an object in order for it to run. Okay, before we do any challenges or tasks using turtle, I need to show you guys some of the most common functions, methods per se, and properties that you will be using in this module. I'm going to go through a bunch here, okay? While you're completing your tasks, it would be helpful to have these slides open that you can refer to, or you can also pull up the documentation for the turtle module online. Now, I'm going to go through them all, okay? All of my objects have the same name, okay? But you would be giving different objects names after you create multiple objects. So imagine turtle as like red turtle, blue turtle, black turtle, okay? If you want to change the speed of a turtle, of your object, you can say speed and give it a value of an integer. If we want to change the color, you can use the color property and you give it a string. You can pretty much use any color inside this module, okay? If there is a color with two words, like light blue or lime green, you can use that. And because the value of the property color is a string, you would use a space. So like lime space green. And just make sure it's a string. You can change the shape of your object, and that's a property, right? It also takes a string. And there are actually 5 different shapes that you could use. You could use turtle, you could use a circle, triangle, square, or an arrow. The default shape is actually a pointer, okay? You don't need to give it a shape, right? But trying to make each object unique, it might be a good idea. You can change the width of your turtle, and it takes an integer. So how thick is the line it's going to be? In order to get the object to move forward, you can say forward and give it a number of pixels to move forward. You could also say backwards, okay? And that is also a method, a part of this module. When we want to turn our object, we use left and right, and both of these are methods. And inside the method, you give it an integer. This integer is a degree, so we should be thinking about geometry at this point. If I ask you to make a square, and your object goes forward 100, it needs to turn left or right. How many degrees are in the corner of a square? Well, the answer is 90. And 3 more methods that are going to be useful in your challenges. So, for example, your object, if I were to draw a grid, your object is always going to start in the middle of this imaginary grid, okay? And that middle has the coordinates of 0, 0. But maybe you don't want to start in the middle. You need to pick your object up, move it to a new location, and put your object down before you start to move again. So, Turtle has 3 other methods. Pen up method. And this allows you to pick the turtle up off your paper, or pick your pen off the paper. We then want to go to a new location. And go to takes 2 arguments. It takes an X and a Y. So where do you want your new position to be? If you're not familiar with using coordinates, this module is going to help a lot with that as well. And as we progress into creating games in Python, you will need to have a basic understanding of coordinates. After you go to a new location, you need to put your pen back down on the paper before you can start doing anything. And this is the pen down method. I've put the steps here in order, all right, if you want to be moving your objects. But before we move anything, you must create an object and give the object your starting properties, like color, shape, or width. You can then change the object's position using these 3 steps in this order as well. You pen up, you go to, and then you pen down in a new position. And then you are able to give your object commands or actions to do. All right. Here are your challenges for Turtle. You guys can really do anything you want. If you want to be an artist and draw cool things, draw pictures, go for it. Use this as a learning tool, okay? Draw something really detailed with multiple objects with different colors. That's going to be incredibly helpful to you as we enter our next lesson when we start creating your own classes. Now, your challenges. I want you to draw a hexagon. just like here in the picture. And you can actually see here is what your turtle will look like if you do not give it a shape property. So draw me a hexagon. Number 2, I want you to try to draw the same hexagon, but this time I want you to only use 3 lines of code to do it. In the first one, it probably took you a lot more, right? It probably took you, at least 12 lines of code. But in the second one, I want you to do it in 3 lines of code. I want you to think about the for loop here. You can use a loop to repeat tasks for an object. In challenge 3, I want you to draw 3 triangles at the same time in different locations. So kind of like here, okay, except there's 4 triangles, and they are all in different locations, and they are all different colors, which I'm going to mention here shortly. Program 2 functions which your turtle object can use. All right, so I want you to make 2 of your own functions, and I would like, when these functions are called, to have your object do something unique. And then number 5, try to use a conditional statement like if, elif, and else to draw something that's based on an input value. So for example, if input equals car, draw a car. If input equals square, draw a square. Now, if you are trying to recreate this image of the 4 triangles, you may notice that the colors are all solid colors. It's not just a line. In order to do this, there are the begin fill function, which you can use as a method, and the end fill method. You want to state before you start drawing to begin fill. Once your shape or object is complete, you want to call the end fill method. And this is going to allow your object to be a solid color. The very last line of code you should have is exit on click. If you do not have this, once your object is done drawing, it's going to immediately vanish. If you wanted to stay on the screen to see what you did and what you could improve on, if you just say exit on click, it is going to stay on the screen once your object is finished. All right, let's head over to VS Code. You see the 5 challenges. I want you guys to try to recreate these, and I will be joining you in doing these challenges. I'll see you in VS Code.
I hope you're getting immense value from this course I've put together for you. Just a reminder, remember, I'm not getting paid anything for this entire course. So to help me out, you guys can head over to the platform that I'm paying to host for you and utilize it, engage, get higher quality content from me, and get all those guides. It's still free, absolutely free. It's the first link in the description, right? Head on down there. That really helps me as I release more of these courses to help you guys go from A to Z in Python. And I mean, if you really don't want a course, that's fine, okay? It's still free. I don't know why you wouldn't, but if you don't, okay. The first link in the description, I'm gonna give you guys that handcrafted Python guide that I made because that guide I made for this course. You're not getting the most of the course if you're not using the guide. It pairs perfectly. That's also the link in the description. You don't need to go to the platform, just head there and get the guide. All right, I hope you're enjoying this content. If you are, please do me a favor, click the like button and subscribe as I have weekly content out dedicated to helping you grow. All right, back to our lesson.
Welcome back, guys. As you can see, I'm not in VS Code right now. Let me explain why. For this lesson, we have introduced objects and working with the Turtle module. Yes, Turtle does work in VS Code. You can use it there freely. When you run your program, an additional window will pop up and display. I am using a free website called Replit. And what Replit does is it allows you to run code on a website. And this website, it's basically like VS Code, but instead of downloading an application, we can do it right here on the web. When I run my program, you're going to see a live display on the same page here. So, I have put together 5 challenges for you with working with objects. I already asked you to do these during the slides, and I showed you 2 examples. If you haven't done so, pause now, read through these, and give objects a shot. All right, I'm going to start with number 1. Number 1, we wanted to create a hexagon, and the drawing needs to stay on the screen when it's done. For each of these, I want you to focus on working with objects. So create an object. I will start off by saying from turtle, import star. I want to import everything. My turtle, I don't have yet, my object, right? So I could just say T for turtle. If you want to type turtle, that's fine, but I just have the one object. And my object is equal to a class, turtle. I now need to give it instructions. So I can say, I want it to go forward 100. What do I want it to do after it goes forward? Well, to make a hexagon, I need it to now change directions a number of degrees. And the degree for that would be 60 degrees. If I run this, let's watch what actually happens. There we go. You can see the drawing appear on my screen. But that is only one wall, so I need to repeat this. So a hexagon has 6 sides. I could just say 1, 2, 3, 4, 5. I run this again, and we are going to see a different drawing. There we are. Okay, so that's our turtle on the screen. That's our object. And that object just completed a task for us of what we told that object to do. Pretty cool. All right, let me turn this off. I will keep my import on, actually. I can just keep reusing that import. In the second challenge that I asked you guys to work through, we want to complete the same task as above, but I want to use a loop this time. I had too much code. That was 12 lines of commands telling my object what to do. With Python, we can automate things and make them more efficient. That's what I want to do here. I also made 2 more notes. The object must have the width of 5 and a color of your choice. If you notice that your object did not stay on your screen after the first one, mine did, and that's because I am on Replit. On VS Code, most likely it just closes the window automatically. For it to stay on the screen, your last line of code, it should be exit on click, or you can actually say done, not don't. I want to say done. Either of those would do the job that I'm asking you to do. Okay, so same tasks as above. I don't have an object anymore, but turtle is still imported from the previous challenge. I would like to give this object a property, a width of 5. I would like to give the property to my object of a color. I will say orange. I've assigned the 2 properties. I can now give it instructions. So, how many sides are on this hexagon? There are 6 sides, which means my loop is going to repeat 6 times. Every time my loop goes, my object is going to go forward 100, and my object will turn left 60 degrees. Upon loop completion, you could say exit on click, your object will stay on the screen. Let me run mine. Go over to my output. There we go. So my two properties of width and color are applying or are being applied before the turtle begins drawing. And then the object is drawing the hexagon using a for loop. Instead of 12 lines of code, we've done that with 3 lines of code. It's much more efficient. I can do that with multiple objects. Alrighty, let me turn this off. And that brings us on to our third challenge. Our third challenge, slightly more, but it gets us working with multiple objects. And this is the key takeaway from this lesson. In the next lesson, we will be creating your own classes and your own objects. So get comfortable working with and creating multiple objects. Challenge 3. We want to create 3 objects. Give them each the same width with a different color. I'll start with that. I still have turtle imported from the top. So I'm going to have 3 objects. I will say turtle 1, that makes the most sense, is equal to turtle. Turtle 2 is going to be an object. And turtle 3 is going to be an object, like so. Each of these objects have the width of 4. Let's say 4. I didn't give you a number, you can choose one. I can just take this, right? And we just need to change our objects. So all of them now have the width. Each object needs to have a different color property. So let's start with purple. I can now use that to create other ones. My second object can have one of lime green. If you're using a 2-word color, because the property is a string, you can give it that space. And my third object is going to be, let's just say red, like so. All right, I've created 3 properties. I've created 3 objects. And I've assigned all of them the same width with a different color. Great. What we want to do is we want to make sure, so I want to draw 3 triangles in a column, which means I need to move all of these triangles, or else they would be drawing in the same position, not creating a column. Let's move them before we draw. So to move, we can say, objects, we want them to pen up, all of them. I don't want them to start where they're at. So it's like picking your pen up off a piece of paper. I'm going to lift up my pen, and then my objects, I need them to go to a new set of coordinates. My first object is going to go to negative 150x. You can play around with these values. You don't need to match my values. My first object will go to this position. My second object, I have concurred, it will go to this position. And my third object will go to this final position. Making sure that I change the name of my objects. Okay. Our objects have moved. We now need to put them all back down on the paper. You can't draw, or it's not going to draw anything if we don't put it back down on the paper. Great. All of them are ready to do something. Okay? It's important to note that I asked you to make sure they are a solid color when they're done. So before we even need to draw, before you even draw, we need to say we are going to call the method I mentioned called begin fill for each object. And this tells the objects that, hey, we are going to fill in using a solid color. I want to start doing that. For each object, we can just do for I in range 3, t1.forward, so that's my object. He can go forward 100, and he can go left 120 for a triangle. Within that loop, I could actually copy this, and I could paste it 2 more times, just making sure that the objects are also changed. Great. Our objects are drawing. The last stage in order to get them to be a solid color is we take that object and we need to say, okay, you can now fill the object. We can end the fill that we were doing, like so. Who remembers the final line of code that we need? The final line of code, you want it to stay on your screen. You could put done or exit on click onto that screen. Let's run it. Go over to my output. There we go. All right, so in a column, we have 3 different objects. They all have different properties and values, but they are all drawing a triangle. Great. Let me turn that off. That was a lot more code. So I hope the understanding of objects is starting to click. An object is equal to a class, and they can all do different things. Great. Moving on to number 4. We would like to create 2 functions. One function draws a square, the other draws a triangle. Each function takes 2 parameters, an object and a size. Create your object, then call both functions, giving them the correct arguments we need. Ensure they are not drawn on the top of one another. That's important. And the drawing needs to stay on the screen. So, creating 2 functions. I said square and triangle, so let's just make a function called square. It's going to take an object, which will be my turtle, so t, and it's going to take a size, so a length of one of the sides. Those are my parameters. Remember our functions. We're giving parameters. When I use this, I will need arguments. So let's say for I in range, I'm making a square. It's going to have 4 sides. My parameter t is going to go forward the size number of times, whatever I give that in size. It's going to go left 90. That's my function. It's done right there. I'll create another function for a triangle. And I will essentially do the same exact thing. This time for I in range of 3. The object that I give my parameter is going to go forward my other parameter times, so size. If I say 100, size is 100. It will go forward 100 pixels. Then left 120 for a triangle. Our 2 functions have been completed. I'm done with those. Let's come outside. I now need that object. So I can say t equals the class that we're after. And let's just draw the square. So let's just call the square function. It takes an object, which is my t. I just made that object. And then I'll say 75 as the size. If I run this, we are going to see a square being drawn with each side as the length of 75. If we call triangle, objects, let's say 45. There we go. Let's run that. Output. They're not on top of each other. It is inside of it, right? If you wanted to go to a different position before you draw the next function, you would do that right here, right? You could go to a new position as well. Right, so pretty cool. Creating functions that we can call and give an object to a function to do a task. Amazing. That brings us to our last one. I'm actually going to use these functions in the last one. Number 5. We would like to refactor the code from above. Create an input asking what shape would you like to draw. If the user enters square, call the square function. If the user enters triangle, call the triangle function. Otherwise, print, we do not have that ability yet. I'm also going to put this in a loop, and I can keep repeating as well until I'm done. Let's create an input called ask equals input. And I'm just going to say square or triangle, making sure that it's lowercase. I would also like to have my 2 functions. So I'm just going to take them. If you guys want to make more functions for more shapes, you should. Let's turn these back on, like so. Okay, there we are. Brilliant. So while our input is not equal to, let's say, quit, if our input is equal to square, then I would like to call the square function. So square, I don't have an object yet. I can just create my object up here and say turtle again. And if I wanted to be more specific, I could actually do this. I could create an input for size, and I could say enter the size. And then as my parameter, instead of 100, we can say size. Oops, what just happened there? There we go. Awesome. I'm going to say else if ask is equal to triangle. Then I'm going to get the size again, the input. And I can call the triangle function, giving it my object and my input as the parameters. Else print shape not here. To end the loop, let's put our ask function at the end of it. Make sure it's in the loop but not in the condition, like so. Let's give it a run. I'm going to begin here in console. Square or triangle? I'm going to say square. Enter the size, 150. I can go back to my output. You guys will not have to because you will have a window up here. There's my square of that size. In the terminal, if I type triangle, I type 80. We will see a triangle drawn on the screen now. Pretty cool. And finally, I'll just say, I think quit is what we said. Quit, that ends the program. We did a lot. We started with nothing in basic objects. We have now gotten to the point of creating functions and giving an object to a function to use with a method. What is a method? It is a function in a class. We also give parameters as the value, the argument for the method. We took these functions that we made and we used conditions like we have in the other lessons. If the condition is true, we call these functions allowing our object to do something. Very well done. We are going to head over to the next lesson. In the lesson, we are going to introduce creating your own classes and objects, and we will be back in VS Code. I'll see you guys in the next lesson. Welcome back, guys, to lesson 14. In the last lesson, we introduced objects, methods, and properties, which is the first step in object-oriented programming with Python. In this big lesson, we are going to be creating your own classes and objects. Now remember, a class is like a family. They share some of the same properties, but also have their own unique properties. From the last lesson, we looked at this image. Our class, our family, is car. Each car is its own object. All of these cars share some of the same properties, like 4 wheels and 2 seats. But they also all have their own unique properties as well, like color or style of car. There can be many objects which all come from the same class, and they all have their own unique properties and actions or methods. Creating an object. So, an object or an instance, the value of it is always a class. So an object is like a variable that's equal to a class. And the class is always capitalized and always ends with a set of parentheses. In the last lesson, we had our object red turtle, and the value was the turtle class. Working with classes and building them, it's going to be the same, except we are going to be using our classes now. Up first, we need to talk about something called the constructor function. All right? Now, I want you to imagine a blueprint of a house. In the word constructor, it relates to the word construction. Construction is used to build something. This function, called the constructor function, is used to build things in our class, and we need that. It's a method that is automatically ran when an object is created. It creates an instance of this specific class. So every time you create an object, the first thing that's going to run is our constructor function. And the constructor function is called init. And the syntax needs to look exactly like this. So init starts with 2 underscores, our word init, and it ends with 2 underscores before our parentheses. We must use this as our constructor function. And this will be the first method, the first function in any class we decide to make. Init, it really means initialize. And initialize really means start. And that's what's going to be happening with this init function. To structure out our class, I'm going to move myself down a little bit to clear up the space. We use the keyword class, and this allows us to define or create a new class. The class keyword is followed by a class name, so it's like naming a function. We give our class a name. And remember, this class name must be capitalized. It's followed by a set of parentheses and a colon. The first method in our class is our constructor function, init. And inside init, we always begin with the word self. Inside any method in a class, we always begin with the word self as well. And what self allows us to do is it allows us to use the properties and the methods that we define in this class anywhere we want in the class. It's almost like turning them from local to global variables that we can use anywhere we want within our class. After self, we give it all the parameters we need. And this is basically where we are creating variables. So any variable I'm going to create is going to be passed into parameter. And the parameter is then becoming the value to our property. Remember, a property is a variable. It's a variable in a class. So this would be our property name, and the value of our property is whatever we get from our init, whatever we create as a parameter. And we will give it live data when we create an object. I then have a second method, and this method is called class details, and you must begin with the word self in order to make this method more or less a global method. So you can use it anywhere in the class, and you can use any of the properties you made in that class as well. So this property is doing nothing in here, but I could print out whatever the value of this property is in another function. Outside of our class is where we create our objects. And an object's value is always a class. So it's equal to our class name with all of the arguments. I want you guys to start recalling how we create functions in Python. It works very similar, where when you call a function, you give it arguments. And these arguments are given to your function as parameters, which you can use inside your function. A class is working the same way. We give it arguments when we create our object, and that's given to our init function as a parameter, which allows us to use them as the value to a property. Let's take a look at an example. Right, our variable in our class is a self.property. You won't call it self.property, you would give it a unique variable name. All right, so here's our first live code example. Now, I've created a class called agent. Agent is capitalized. Our constructor function is always the first method at the top of our code. And I'm giving it 3 parameters, name, health, car. These parameters are passed in as the value to our properties. This class is not doing anything currently because I only have our constructor function in it. Then, outside the class, I have created 2 unique objects. And the value of these objects, it is the same class. But the arguments we are giving are different for each object, for each person, right? The spy is James Bond. His health is 100. And the car he's driving is a Jaguar. The villain, our next object, is Ethan Hunt. His health is 40, and he's driving a Ferrari. So I'm creating 2 objects from the same class. Breaking this down even more, all right? So I've highlighted the key important parts here, right? All of our parameters are given as the value to our properties that we named. Self.car, it holds the value of car. Whatever we pass into our car parameter from the arguments, that becomes the value of the property. We use properties just like we do for values. Let me move me up a little bit. All right. In this class, I have defined one method, and this is called player info, or the agent info, giving it the keyword, the first parameter of self. Now, I want you to imagine self as a key. It unlocks all the properties and methods to allow us to use them anywhere throughout our class. We never use the word self outside of a class. So it's essentially turning everything global within that class. So here we are even further. I've just addressed what's happening in the class. Then we have our 2 objects, spy and villain. They each have different arguments. These arguments are passed up into our init constructor function. and they are given as the value to our parameters in that order. So for example, James Bond is in the first position as name. 100 is in the second position like health. It must go in that order as well. When I want to call this function, because it's a method, remember every method must be linked to an object. If I just say player info, it's not going to work because it's in a class. I need to link player info to my object. When Python reaches these two lines of code, the output in our terminal would look like this. It would start with, welcome James Bond. Your health, 100, car choice Jaguar. And it would do the same thing for our villain, Ethan Hunt. That was a lot of knowledge, guys. A lot. We learned about a constructor function. What is our constructor? It's init. Init, as well as any other method, always begins with the first parameter of self. And this acts like a key that unlocks all of our properties and any methods we have so we can use these anywhere we want in our code. The properties work just like variables. I can use these properties in other methods as I wish. We can create as many objects as we want as long as the object's value is our class. We must give it 3 arguments because inside our constructor we said there will be 3 parameters. In order to use any method, our methods must be linked to our objects we want them to be linked to. Let's head into VS Code and start creating your very own classes. I'll see you guys there. Alright, here we are in VS Code. Now in this lesson, we have learned how to create and build our own classes. And these classes hold properties and methods. We also introduced how to create your own objects using these classes. On the screen, I have 3 different challenges, all of which include creating your own classes, methods, and objects. I want you guys to pause the video here, read through, and give these a try. Alright, jumping into our first one. We are going to start nice and easy and build our way up to more challenging classes before we lead into our next lesson. I'll apply some space here, and I'm also going to zoom in once for us. There we are. Alright. In the first challenge, we want to create a class for animals with properties name, pet, and sound. We will create a method called speak and print the sound of the animal. And we will also create a method called pet info and print off all the pet's information. Let's begin by creating our class. Who remembers our keyword we need in order to declare a new class? This keyword is class. Giving our class name, we always want to make sure it's capitalized. A set of parentheses and a colon. Now, in a class that doesn't inherit or get anything else, we don't actually need these parentheses, but we can take a look at that in further lessons. Now we build our constructor method. The constructor method is called as soon as a new object is created. In this constructor, what we looked at is init. Now inside init, we always need to give it a key, right? And this key is our keyword self. anything inside of a class, we need to use that word self. I will now give it our 3 parameters. I've set name, pet, and sound, all of which will be passed to init once we create an object. Inside init is a place for us to store all the variables, all the properties we will use throughout this class. We need to declare 3 properties because we have said there are 3 parameters. So declaring a property, self.name is going to be the name of this property, and the value of this is going to be our name parameter. I will do this for our other 2. We have a property called self.pet, and we also have a property called self.sound. Like so. All right, our init constructor function is complete. That's all we need for this one. I now want to create a method called speak. So a method, simply put, is a function in a class. I can call this speak, and I will give it the keyword self. This method does not require any other parameters to work. As soon as I call it, the code inside is going to run. But we must use the word self to unlock this method, so to speak. Now, I'm going to print off, and all I'm going to print off is the sound property. So anytime I call speak, the sound we give our object is going to print off to our terminal. Next up, we want to create a method called petInfo and print off the pet's information. So I will create one called, let's call it petInfo, giving it the parameter of self, creating a print statement here. I will say, because I want to include all 3 properties in here, so I can begin with my as a string. I will say my pet has the name, self.name, and then I would like to include the sound in there. So I could say something like, they make the sound, and then our property self.sound like so. So I'm using all 3 of the properties we've created in our constructor inside petInfo. Great. Our final 2. I'm going to create 2 objects with different values. So I will begin with creating an object dog, and the value of this object is our class animal. I'll also make one now for cat, and I can use the same class. They are both animals, they are different objects. What is the first thing I need to put in here as an argument? If you forget, always go up to your init constructor and check the 3 parameters. I need a name, a pet, and a sound. So the name for my dog is going to be my dog's name, Champ. I will say dog, and I will say woof, woof as the sound. For the cat, I will say Toby. I will say cat, and I will say meow. I've created 2 different objects. If you run your code, nothing is going to happen. We haven't used these objects yet. I want to call both methods with our objects. So, although we've created a function, it's not a function, it's a method, it's in a class. If I just say speak, like a normal function, and I run my code, I am going to be presented with an error. Let's bring our terminal down some. There we go. Line 25, speak, name error. Name speak is not defined. That's true. Python can't find speak. Where is it? It's in my class. In order to get our methods to work, they need to be linked. So I will say dog.speak. Our speak method is linked to our object dog. I can also say cat.speak. When I run this, we now see woof woof and meow. let's call our other two methods. So dog.petInfo and cat.petInfo, like so. Let's run again. There we go. My dog has the name Champ, they make the sound woof woof. My cat has the name Toby, they make the sound meow. We are linking our methods to the objects we created by defining our own class. Pretty cool. We are just getting started. I will close out of my terminal. I'm going to turn off this class, and I will move on to number 2. Some space. All right, in number 2, we are working with the NBA. We need a class called player. This class will have 3 properties, name, score, and team. But team is initially set to empty. How can we do that? I want you to think about that. We didn't introduce it, but team needs to be empty. It's still going to be a property. We will create a method called showStats. This will print off the information about the player, and create a method called selectTeam. This will ask for an input and set the value of the team property. Let's jump in. I'll create a class, and it's going to be called player. I will build my constructor, giving it the first parameter of self. Then we have name, and then I have score. I will have a team property, but because it's initially set to empty, it's not going to run when init is ran. So I'm not going to put it as a parameter. I will go forward and create my 3 properties. I will say self.name is equal to name, self.score is equal to score. Now I need the team, so I will define a property here, and I'm going to give its value of one of 2 things. You could do like an empty string and put something in it. You could also say none, and that means there is no initial value for this property. Moving on, we will create a method called showStats. So let's define a method. Let's call it showStats and give it self. This will print off the information about the player. I will print off, and I'm going to start with player as a string. We can give it self.name, so who is the player? I will print off here my average points. And here we could say self.score. And our last one, we will print off our team, although the initial value will present as none. That's fine for now. That method has been built. We're good. Our final method, we will create a method called selectTeam. So I will begin with calling it selectTeam, giving it our parameter. Make sure self is lowercase. This will begin by asking us an input. I want to ask the question of enter your team name. So enter the team name, like so. I'll give a space there. I can then change the value of my self-team property. Currently the value is none, but I can now say, hey, self.team is now equal to our input team, like so. Brilliant. Let's create an object for our player. So I could say player equals our class player. If you have more than one player or you would like to play around with this, give your object an actual basketball player and put their name there. Player takes an initial 2 arguments. The first argument will be the name. I will say Steph Curry. The second one is going to be a score. I will just say 9. I have my object. I will now display his stats. If I run this, we are going to get all 3 of these ran, but you'll notice that team comes up as none. Let's run it. There we are. Player Steph Curry, average points 9, team is none. Okay. I would like to assign him to a team. I'll go down. I'll take my object and I will call the select team method. Then I will also call show stats again because I would like to see the updated version at this point. Let me run it. There we are. Initially, we called the first show stats method. It's displaying team none. Then we're calling select team, which we see here at the bottom. Enter the team name. So Golden State. Enter. It then calls our final show stats method. Player Steph Curry, average points 9, team Golden State. We have updated the property from none to our input value. Amazing, guys. I will close my terminal. We will turn off this class player. I will proceed on to our final one. In the final one, this will require us returning a few things now and getting a bit more complex with our class structures. We are building a class to find the perimeter and area of a rectangle. What parameters do we need to solve this? We will create a method to print off the basic information about the rectangle, a method to calculate the perimeter, then return the value, a method to calculate the area, returning the value, and we will also create a bonus method, and this will shorten the length of the rectangle. It'll take one parameter and return the updated parameter. Okay, I will start off by creating our class. So class, I could just call this rectangle. It's what we're trying to make here. With our constructor function, giving it self. In order to build a rectangle and do these calculations, we need a length and the width of what the rectangle will be. That means we will justify our two properties of length and width, like so. Okay, that is all we needed for our constructor. Up next, we will print off the basic info of this rectangle. So we will give it self. I will then print off something like a rectangle with the width, let's say length, self.length, and the width of self.width, like so. That's all this method is going to be doing. I then need a method to calculate the perimeter of this rectangle. And I will return this value once it's calculated. So I will create a new property. And this property is only used or created inside this method. It's not a part of init. It's not needed to start this class from running. The value of this, we need to calculate the perimeter. So I can take my property self.length, we will add it together with our self width. We then need to multiply this by 2. That finds the perimeter of this. I can then return our perimeter, which is held in the property self.perimeter. That's it. All right, our first one there is done for the equations. Our next one, I would like to calculate the area of this rectangle. So to find the area, we just need to multiply the length and the width. So let's say self.area is equal to self.length multiplied by the width, returning our area property. Brilliant. Now the last one. We are going to be giving a parameter to the last method because I want to be able to shorten the length of this rectangle. So by creating a new method. I will call this one update. Self, it is going to need another length. To update this, we will create a property called, let's say, updated. The value of this is self.length, and that's the original length, minus our parameter length, multiplied by our width, like so. I can then return my new property, updated. Our class is built. It has 4 methods, not counting our constructor method. Going forward to our last ones, we want to gather the length and width through 2 inputs. Create an object giving it the arguments we need, which come from our inputs. We will print off the basic information, the perimeter, and the area of the rectangle. We can then ask the user for an input to reduce the length of the current rectangle and call the update method. I can begin with, let's say, a equals int input. I'm doing this because it needs to be a number to do any type of math. I will say enter the length. I can take this and I will also need an input for my width. So enter the width, like so. We can now create an object. I will create an object called rect. It's equal to our rectangle class. The rectangle class takes 2 arguments, length and width. I can say A and B because those are coming from our input. I will call the printinfo method. This will print off all the basic information about our rectangle. Because I am returning the other values, I can't just call the method. I want to print it out. So I will print off here, and here I will say something like perimeter. I can now say rect.calc perimeter and call that method. I will do one more print and I will say area. Here I will say rect.calc area, our method. Let's run this how it originally is. So running, we will be asked for a length and width. I will say a length of 8, width of 3. There we are. Rectangle with the length of 8 and the width of 3. The current perimeter is 22 and the area is 24. All right, let's update the value. Let's update the area of this rectangle. I'll close this. I now need a new input because this method update takes 1 argument. Self is not an argument. We don't use that outside of our class. So I will say C equals another input that will be an integer. I will say enter the number to subtract from length. There we are. We can then have another print and we will say updated area. We will call rect. We will call the update method. Update takes 1 single parameter. This parameter is going to be our length, which we collected through C, our input. Brilliant. Let's give this a try. So let's run the initial application. We are prompt with our first 2. This time I will say 10 and 3. We have a current perimeter of 26. Our area is 30. I now want to make my length shorter, so I will subtract 2. It will be 8 and 3. There we are. Our updated area went from 30 to 24 after we subtracted 2 from the length. Great, guys. We have just built your first 3 classes. Experiment with this. Give it a try. Create a class of your own that does something you want to achieve. As we head into the next lesson, we are going to be looking at more advanced class concepts and how we can use multiple classes to work together. I'll see you guys in the next lesson. Welcome back to our next lesson. In our previous lesson, we introduced the concept of defining and creating our own classes, creating methods and properties along with it, then creating an object we can use throughout our program. In this lesson, we are going to be looking at superclasses and inheritance. I mean, who doesn't love inheritance? What do you think of when you hear the word inheritance? Chances are it's going to apply to a superclass as well. Let's jump in. Going back a few previous lessons, we saw a very similar diagram. We have a class called computers. Originally, I said all of these were objects, where they could all be objects. If I have a class computers, I could make an object for MacBook, Windows, and Linux. And the same applies for animals and games as well. All of these could be considered objects. But what if animals is a class, but it's a superclass, it's a parent class, and cat, dog, etc. were all objects? We could create a class for each animal as well, taking key data from the parent. I could have a class called cats, and it would take data from the parent animal. Here is that broken down a bit more. Many times we need to transfer the properties and methods from one class to another class. In programming, this concept is called inheritance. So if I have a superclass called computers, I could create a child class called MacBook. It would inherit certain properties and methods from our parent class, but it would also have properties and methods that only the MacBook has. The same applies for animals. If animals was a parent class, we could have a child class or a derived class called dogs. We can create one main class that all other classes can use or inherit from. Just remember, the children inherit from their parents, but also have attributes and actions of their own as well. Here we have it broken down. It applies for everything in life because I could do this for most things that we have in this world. All Ferraris are cars. Doesn't matter, right? Cars is like the superclass, the parent, and Ferraris is a child of cars. All dogs are animals. That's true. All sofas are furniture. And all jeans are pants. All of these are true. Jeans is very specific, but at the end of the day, jeans are still pants. In Python, we have two types of inheritance. Let's take a look at our first one. The child class is given new actions. These actions are our methods, our functions in a class. But new properties are not given. That's one type. We do not need to create a constructor function within the child class. We can inherit and use the parents init function if we do this type of inheritance. Our second path for inheritance is the child is given new properties along with new methods. If we go this route, we need to create a constructor function within the child class. We also need to activate the parent constructor so we can continue to inherit all the original properties and use them within our child class. Let's take a look at how this would look in action. How we create a child class. You're going to hear me say child class a lot because I view that it's easier to understand. A child class is really called a derived class, and that parent class is called a superclass. Creating a child class that only needs new methods, I have here below. When we make an object, an instance of a child class, the superclass constructor will be called and used in the derived class. So I'm not defining any new properties, just new methods. We don't need the init function in a child class. It's going to take all the properties we defined in our superclass and allow us to use them here. We create a child class the same way, using the class keyword to define a new class, give the child class a specific name. This time, inside our parentheses, we will put the name of our superclass. This allows us to inherit everything within our superclass. Any method in the child class we can define the same way we have been doing. You would define a method, always giving it the keyword self to start, and if the method requires any parameters, you could assign those here as well. Our other path to creating a new child class and giving it new properties looks slightly different. In our example here, we are creating a child class, but this time it has new properties. We create the class the same way with our class keyword and the name of our class, also giving it our superclass. We then have our constructor method, so def init, giving it the keyword self. The first few parameters inside init that's within our child class need to be the same parameters from our superclass. Any new parameters that we wish to introduce to this child class would follow those parameters. Now, we need to activate our superclass and basically say, hey, Python, I want you to unlock and use every property within my superclass so I can use it in my child class. To do this, we need a special function, and this function is super. Super is linked to our init function as well, so super.init. What super allows us to do is it allows us to inherit all the methods, but more importantly, all the properties from the superclass, our parent class. When we create an object of the child class, the superclass constructor will still be automatically called and used, allowing us to unlock those original set properties that we defined in our superclass. Inside our super init, we need to put all the original parameters we had in the superclass. If you look at my color coding, everything in green is from our superclass. We have our superclass name, but we're also passing in all the parameters that we originally used in our superclass. Any new parameter that we are creating only for the child, we can then create a new property with the value of these new parameters. Anything that follows are the methods that we define and create specifically for the derived class, our child class, to use. Take a look at this slide. If you need to, pause it and try and interpret what's happening here. if we create new properties for our child class to use, we must create another constructor. In our constructor, we need to activate all the pre-existing parameters and properties from our superclass. We do this with using the super function linked to our constructor function, passing in all the parameters we used in our superclass. Here is a live code example of inheritance. This is root 1. We are not defining any new properties. We are just defining new methods. Therefore, in my child class, which I have called spy, we don't have init. I just have two methods inside this class. On the left, we have our class agent again. We have our constructor just like before, and we have our three properties we've created here. We also have our original method, player info. That's great. That's our superclass. That's the parent class. I then made a derived class called spy. And as the superclass, I passed in agent. So agent is going into our spy class, and it's acting as the parent. We have one method called spyTalk. It'll print off my name is and the name of the spy. And we also have a method called shoot. Shoot is taking one parameter, bad guy. This bad guy is actually going to be an object we give to it. And we can say if bad guy health and also if bad guy health. I'm going to break this down for you even more so we can really see what's happening here. All of our properties, we can use these in the child class because we are inheriting from our superclass. Our method shoot is taking a parameter bad guy. When we call this method, this argument that we will give our method is going to be an object. If the bad guy's health, the health is coming from here, is greater than 0, then I want to subtract 20 from the bad guy's health. I can then print off the bad guy's name, has lost, and the bad guy's health. We created two objects. I have James Bond. He is equal to the spy class. I create Ethan Hunt. He is equal to the agent class. I then call the method that's coming from our superclass, player info. So JamesBond.playerInfo would print off welcome, James Bond. Your health, 100. Your car, Jaguar. Then I'm taking my object, James Bond, and I'm calling the shoot method. Shoot is coming from within our child class. The bad guy, I am giving my object, Ethan Hunt, as the bad guy. We will take a look at this in our coding challenges in VS Code. But I'm passing an object into the shoot method. So originally Ethan Hunt's health is 50, but every time we are subtracting 20 from his health because he is our argument. He's going to this method and we're using his value as an object to run our conditions against. Keynote, guys, we never use self outside the class. I'm going to say that a few times. I've said that before, but we never use self outside of our classes. This was the first path to inheritance. We did not define any new properties. Let's take a look at the second route for inheritance. More specifically, this is becoming when and how we use the super function when we create a derived class. Here is our other example. This time, I am creating new properties in the child class spy. So I need to have my constructor function, def init. I am passing in all the original parameters that we had in our superclass. Then I am allowed to justify and create two new parameters. First up, we activate super. So super.init, I am basically saying to Python that all of these are coming from my superclass agent. My final two parameters, we can create two properties for these, and their value will be those parameters. Now, inside our method spytalk, I can say my name is self.name. This is coming from our superclass. But then our next print statement, I am based at agency and location. These were defined within this child class. We are initializing the properties from the superclass by using the super function, as well as creating two new properties that only this child class can use. If I were to break that down even more, here's what's really happening behind the scenes. All of our original properties, just like before, are being passed into our child class when we say super init. The first three parameters match the three parameters coming from our superclass. All the additional parameters we can define after we tell Python our first three superclass parameters. Then we create our properties within our constructor function. When I create my object, James Bond, because he is using the spy class, he needs to have 5 arguments this time. Up top, we have 5 parameters. So James Bond 100 Jaguar, London is location, agency MI6. I then call the spytalk method linked to my object James Bond. The output in our terminal would say my name is James Bond. I am based at MI6 in London. Pretty cool. So we can create one parent class that has most of the properties and methods that we will need. I can then create as many derived classes as we want, and all these classes can inherit from our superclass parent. These child classes can also have properties of their own, not just methods of their own. Let's head over to VS Code and check out more about how inheritance works with our classes. I'll see you guys there. Here we are in VS Code. In this lesson, we introduced inheritance and how we can inherit classes to work together. I have prepared 3 challenges. On the screen, you can see the first 2 challenges. If you want to give these a shot, pause the video here, read through, and give them your best try. Okay, I'm going to jump into number 1. We will begin easy, and as we progress forward, it's going to get more challenging as well. Let's take a look at number 1. We will use the animal class from our last lesson. We will create a child class called fish, or choose one that you would like to do. Create a method called swim. If the sound is equal to none, print I am a fish, because fish do not have sounds. Otherwise, print, are you sure you're a fish? Create a second method called ocean. Ask the fish which ocean they are from, Print off, for example, Nemo is a fish who lives in the Pacific Ocean. I will then create an object and call all 4 methods. Now remember, the superclass came with 2 methods. We are now creating 2 more methods in a child class. Let's jump in. I'm going to begin this one by coding out the entire superclass animal again. I can begin by creating my class, animal. Inside animal, I will create my constructor function, passing in the keyword self. We have a name, a pet, and a sound. These are the 3 parameters. For every parameter that we tell init it's going to have, we must create properties around these. A property always starts with the word self, and the value is that parameter. So self.name is equal to our name parameter, self.pet is equal to our pet parameter, and self.sound is equal to sound, like so. We then had 2 initial methods. We had the method speak. Every method we create in the class must have our keyword self, and we can print off the sound the pet makes. I will then create our final one that was called pet info, and inside pet info it was just giving a biography about the pet. So I could print off something like my pet, so self.pet, has the name of self.name, and they make the sound of self.sound. Now I will need to justify my comma break in here as we're working with different data types. And there we have it. This was the class we built in the last lesson. I now want to create a child class, and I said I will call this class fish. I must give it my superclass now because I want to inherit all the properties as well as my methods. Inside the parentheses, I will say animal. I will not create another constructor in this challenge because I don't need to. I'm inheriting the properties that I need from our superclass. So in this child class, all I need are the methods which are going to apply to the fish class. The first method I wanted to make was called swim. And I would like to check if the sound of the pet is equal to none. If it doesn't have a sound, it's a fish. If it has a sound, it's not a fish. I will create a condition, and I will say if my sound is equal to none. If that's the case, I can print off you are a fish. Otherwise, they made a sound. If they made a sound, the chances are that they are not a fish. You must not be a fish. Like so. I am using my property that we created and we inherited from the superclass within my method in the child class. This brings us to our second method. In my second method, I wanted to call it ocean. And ocean is going to ask which ocean are they from. So I could say like region. And this will be our input. I will say here enter an ocean. Like so. Once I collect this input, I could return something like so. I would say something like self.name is a, what are they? So self.pet, that could be the pet. Then I could say something like who lives in region, ocean. So region is coming from my input. The other two are properties, and they are coming from our superclass. Great. We constructed our superclass, we created a derived class. The superclass is essentially our parent, and the derived class is a child of the parent. They are inheriting everything from the parent, but they also have attributes and actions of their own. I will now create me an object. I will call it Nemo. Nemo is equal to our fish class. I need to give the fish class arguments, but if we notice, I don't have init in the fish class. What are my parameters? If you ever forget, go and find init, which I'm inheriting from my super. These three parameters, I need to match them. So the name, I will say Nemo. The pet, I will say fish. And the sound is none. They have no sound. I'll begin by calling the first two methods, so speak, and I will also call our pet info method. I will run this, and the first two methods from the superclass will run. Here we are. So speak is giving me back none. Then I'm printing off the basic information about my pet. My fish has the name of Nemo, and they make the sound none. Great. First two are working. I would like to call the next two methods which we created in the child class, fish. Nemo.swim. Then I will say Nemo.ocean. Just to clear up the terminal a bit, I'm going to turn these off for now to just call the new two methods that we have. They are linked to our object, Nemo. Let's run this. Swim is going to execute first in our condition. In the condition, I'm checking if the sound is none. We gave it the argument of none. It's printing off my response, you are a fish, at the top. Then it's calling our ocean method. The first thing to occur in this method is an input, enter an ocean, Pacific. Then it takes that input as well as two of our properties and it prints off that statement. Nemo is a fish who lives in the Pacific Ocean. Great. We took what we had from last lesson. We expanded that by creating our own derived class, child class called fish. Our object Nemo can unlock any of the four methods that we built in either class because it's inheriting from our superclass, and it also has the two methods of its own. Pretty cool, guys. Great job. Let's move on to number two. For number two, I will turn this off and then clear up some space. Number two, we need a superclass for vehicles. So in our slides, we have the example that all the vehicles on the road, a car, a truck, a van, it doesn't matter. They're all vehicles. Our constructor needs any basic car info. So the make, the model, the year, and the price. We will create a method to check if the make is a Ford, Chevy, or Tesla. I may have missed one. If so, return American made. Otherwise, return imported. I'll create a method which returns the vehicle model. I will create another method that checks if the car year is greater than 2000. If so, I will return car from the 21st century. Otherwise, return this car is old. Our final method in our superclass, we will create a method that accepts a max price you're willing to pay for this car. This method checks if the car price is under your budget. If yes, return within your budget. Otherwise, return over budget. In my steps, I'm not giving you direct answers, as I want you to be thinking about what we've learned and how we can implement this. But going through every task one by one is going to help you complete these challenges on your own. Let's start with our superclass. Our superclass we will create. We don't know it's a superclass yet because Python can't see that, but we know that I will use this as my superclass. We will create our constructor in it. We must give it our 4 parameters. We have the make, we have the model, we have the year, as well as the price. For each parameter, I will create a property. The value to all of our properties, remember that they are equal to our parameters in the class. There we are. Here are my 4 properties that I will use to construct everything with. Our first method will check if the car is a Ford, a Chevy, or a Tesla. If it is, I will return American made. So let's create a method. I will call it getMake. Giving itself, that's all this one needs. If I'm beginning with a condition, I am going to use some logical operators here. So if the self.make is equal to a Ford, or our make is equal to a Chevy, or the make is equal to a Tesla. Our logical operators I'm using is OR. One of these must be true in order for this condition to be true. I would like to return, all I want to return is a string American made. Else, I would like to return imported, like so. Great. In our second method, we would like to get the model and return the model. That's all we want to do. So let's call this method similar to the first one, getModel, and I can return self.model. Great. Our second method. Our third method, I want to get the year. If the year is greater than 2000, I can return 21st century car. Otherwise, I will return this car is old. So our method, going with our naming conventions, getYear. If the year, so I'm taking my property self.year, is greater than or equal to 2000, I can say, I can return 21st century car. Else it is less than 2000, I can return this car is old, like so. Great. And this brings us to our final method. In the final method, we want to be able to give this method a max price of which you're willing to spend for a car. If the price of the car is less than the max price, I can say, you're good to buy it. Else, it's too expensive. It's out of your budget. So giving our last method the name of getPrice, giving it self as our keyword, our first parameter, I will then create a parameter called max price. I can create a condition to say if the price is less than our max price. That's great news. I can return goodbye within your price. Else, I will return over budget, like so. Great. We have our superclass with 5 methods in there, including our constructor method. The other 4, 3 of them are going to return a value once they check a condition, and the getModel method is just going to return the model if we choose to call that method. Great. Going up, I want to create a child class for the style of the car. This class accepts a superclass and also has a parameter of its own for number of doors. Create one method. If the parameter is 4, I will return family car, otherwise return sports car, because generally that's how it is. Your car has 4 doors, it's a family style car. If it has 2 doors, it's a coupe, it can't fit a family. I will construct our child class down here. I could call this style if I wanted. Any name would also work. I will give it the superclass of vehicles and continue on. Because I am creating a new parameter, I need to have init inside as my first method. Self. Do you remember the first 3 parameters that come next? In this case, it's going to be 4. It's going to be the 4 that we justified in the superclass. We have the make, I have the model, I have the year, I have the price. Then I would like one of my own. So here I'm creating a new one, num doors. How do we activate our superclass so I can inherit everything from it, specifically these properties? Here is where we will use our super function. The super function is linked to init. Inside init, you don't necessarily need to put the keyword self here because we are within the constructor function which already has self. What you do need to put is what are you trying to inherit from the superclass? I want the make, I want the model, the year, and the price. Then I'm left with my final parameter for which I need to create a property for. So self.numDoors is equal to our parameter numDoors. There we go. I'm inheriting all the properties, but I'm also creating one of my own. Now is the time for any methods we need. I just need one method in here. In this method, I could say get doors, I suppose, giving it self. If our property of numDoors is equal to 4, I will return a family car. Else, I will return sports car, like so. Great. Our classes are done. Generally speaking, it's a good idea to have your classes at the top of your code. Afterwards, all your additional code will go, such as your objects, your loops, other functions you may have that are not a part of your class. I can then create an object. I'm going to create a few here to kind of play around with this. I'll create the first one, and I will call the first one truck. And this is not going to use my child class, just my superclass. The make, I can say Ford. I will say F-150 as the model. The year, let's say 1999. And the price, let's say 15,000. Like so. Then, remember, because we're returning everything, if I just call these methods, we won't see anything in the terminal. We need to print off our response. So in our print here, for example, if I wanted to get the make, I could call my method getMake within here. If I wanted to get the price, I could call getPrice. What does price take? Well, we said price will take one argument of max price. So what is the most that you're willing to pay for a 1999 F-150? If I put 12,000 here, I'm going to run my code and let's watch what happens. There we are. American made, it's a Ford truck, but it's over the budget. The budget, the truck was 15,000, I said 12,000. It's too expensive for me. So our first 2 methods are working, and I made an object that only uses our superclass. It's not using that child class we just made. Let's create another object. Let's say car this time. And let's say car is going to use our child class. I will say here Toyota I can say, what's a Toyota car? Camry. Camry. There we go. In this case, a year, I will say 2001. Price, I will say 9,000. And number of doors, there are 4 doors. Because I'm using the child class has 5 parameters, including the number of doors that I need to give it. Let's print off now, and I'm going to take my car object. I can take my car object, and I can say get doors. Let's run that. This will output for us, and we will see family car. The first 2 are still coming from our truck. I left those turned on. The only method that the car object is calling is get doors, and it's checking if it has 4 doors or not. This car is a 4-door car. Great. Wonderful. And for our last one, let's just make a sports car. Let's inherit or use the style class. I will say Lamborghini Aventador. It is going to be a year of a 2022. The price, I don't know, they're expensive. I'll say 350,000, and there are 2 doors. Okay, we now have 3 objects, truck, car, and sports car, although sports car currently isn't doing anything. So let's do a few things with it. Let's get the make. Sports car dot get make. Let's also get the price. So sports car dot get price. Let's say I can spend 400,000. That's a lot for a car. Print sports car. I would like to also check the number of doors. Is this a family car? I will turn off the other ones so we can just see how sports car is running. Running our code. We see that it is an imported car. Goodbye, it's within my price. I said 400,000, the car is 350,000. And then it's returning sports car because there are only 2 doors. Great, guys. Amazing. Well done. This brings us on to our last one, which you have not seen yet. But we are going to do something very similar to what we looked at in our slides. If you guys would like, pause the video here, work through this one on your own. Remember what we talked about in our slides, and really try to do this without looking at the slides. Although if you need help, you can refer to those slides. Great. I will jump right in. We will be creating a class for our agents, James Bond and Ethan Hunt. Our superclass is going to take the name, health, and car, and our superclass will have a method that prints off the agent's information. I will just begin with this one. Class agent. In our class, creating my constructor of init. Self, name, health, and car. Each of these we are creating a property for. Okay, there we go. I would then like to have a method for, say, agent info. All this is doing is it's printing off 3 things. I can say welcome, self.name. I can take it to the next step and we will say health. I'll put 2 dots there, a colon to separate that out. We can say self.health. Then our final one is going to be our car, so car choice. There we are. This is all the superclass has in it. So if we call an object with the method agent info, we should see all the agent's info printed out. I will create these two objects before I create our child class. Our first one is James Bond. Currently, they both will use the agent class. I will give the first one the name of James Bond. Health, 100, car, Jaguar. Great. Next up, we have Ethan Hunt. He is another object who is using the agent class. His name, Ethan Hunt. His health, I'm going to put at 40, and the car will be a Ferrari. For each of these objects, which let's change it to James Bond, I would like to get the agent info. When we run this, we are just going to be greeted with all the basic agent information that we put as our arguments. There we go. Welcome James Bond, Health 100, car choice. We also have Ethan Hunt's information here. Great. We also have Ethan Hunt's information here. Great. Let's now construct our child class. Going up, create a child class called Spy, and this inherits everything from the parent class. Add 3 additional properties of agency, location, and killed. Killed is set to false. Think about how we've done that before. Killed is a Boolean value. It's initially set to false. Let's jump in. All right, let's make our child class. I will create a new class called Spy, inheriting the agent superclass. I have a few new properties I want to introduce. Therefore, we have our constructor within our child class as well. The first 3 parameters will be name, health, car. Then I also want to have the agency and location. We also want to have the killed, which is initially set to false. Because the value is set to false and it's a Boolean in the beginning, I will not state that in my parameters. I will initialize everything with our super function. Inside that init, I will say name, health, and car, like so. We can then create 3 new properties. So agency is equal to agency. Our location is equal to location. And the last one, I can say self.killed, but the initial value is false, like so. There we go. Our child class is beginning to come to life, and we created our constructor method, inheriting from the superclass, as well as creating 3 additional properties. Brilliant. Let's go up a little bit here. Ethan Hunt will be the bad guy, as a note, okay? We create a method to assassinate the other agent. This takes 1 parameter. It will take an object. I will give an object to this method when it's called. If the enemy's health is greater than 0, I will subtract 20 from their health. Print off who has lost 20 health and print off their updated health level. If the enemy's health is less than or equal to 0, the killed property becomes true. Printing off the enemy name is dead. Great. Our property inside of the child class. We will call this assassinate. Giving it the first one as self. Then we need a bad guy. Who are they attacking? This bad guy is really going to be an object here. If that object's health is greater than 0, we want to attack this bad guy. So bad guy.health minus equals 20. I am subtracting health of 20 from the other object who we are attacking. I will print off the bad guy name. We can also say here a quick string. Has lost 20 from their health. Like so. We could print off something else. I could say here bad guy name. So whoever that is going to be has a health level of, then we would like their new health after they've been attacked. Great. If their health is less than or equal to 0, self.killed is now equal to true. I can then print off their name again, and we will say here is dead. Also, why not just say self.killed to show that it is true? Great. There is our two classes, our superclass and our child class spy. Going down, I've already created the two objects that I will be using. But there's something else I want to add in here, and I want to see if you guys can do it. Going up to the explanation of the problem. Create two instances, one for James Bond and Ethan Hunt. I've done that. Call the method to print off the agent's information, then wait 5 seconds. While Ethan Hunt's health is greater than 0, both objects call the assassinate method to attack. After every attack, the program should wait 2 seconds before the next attack. How can we do that? I want you to think back when we introduced modules. I will go up here and I will say from time import sleep. We will use the sleep function from the time module. Down here with our objects, we've done the first two. After we have the agent's information, I want to sleep 5 seconds. Then I can make our while loop. I will use Ethan Hunt only because he has less health currently, and we can see that. So while his health is greater than 0, I want this loop to run. Now I want James Bond to assassinate Ethan Hunt, but there's an issue. Both of our objects are using the superclass. Let's change that so both of our objects are using the spy class. While I'm up here, I also need to give new properties to my objects, new arguments, because we have 2 new arguments that I would like to pass in, an agency and location. They were just taking the original 3 from the superclass. Now I need to have a few more. So James Bond, his agency is MI6. He's based in London. Ethan Hunt, I'm going to say he's based at the CIA, and his location is, let's say, Dubai. There we go. I've updated both objects. They are using the spy class, and they all have 5 arguments that I have passed into them. Returning to my loop now, I can take my objects, James Bond, and I can call the assassinate method. Inside assassinate, who is he attacking? So James Bond attack Ethan Hunt. I'm giving that object to this method. I'll do it the other way around now, and I will say Ethan Hunt attack James Bond. And remember, after every attack, we would like them to sleep for 2 seconds. All right, let's run and see our code in action. The first output we are going to see is the agent info. There we are, our agent info. It's going for 5 seconds, then our loop begins. Watch Ethan Hunt's health. There we go. Initially, Ethan Hunt has lost 20 from their health. It updates their new health. Remember, he starts on 40. The first attack, we took 20 from that health. And then he attacks James Bond. That health is being updated. The final attack, he lost 20. His health level is now 0. Ethan Hunt is dead, true. Our property self.killed became true, returning that value. Pretty great, guys. Very well done. We have worked a lot with objects and classes in the last 3 lessons. As we proceed and get closer to the introduction of Pygame in your final projects, we will use classes heavily throughout that process. I will see you guys in the next lesson. Welcome to our next lesson. In the last few lessons, we have learned a lot of advanced concepts with object-oriented programming in Python, creating objects and classes. Let's tone it down just a little bit before we start introducing our final projects. In this lesson, we are going to introduce the concept of lists and working with lists in Python. A list, simply put, is a list of things. It's the same for Python. When we look at a list, it's a way to store ordered data of different data types. Here you have a list. I have a variable, and the value of this variable is what we call in Python a list. Creating a new list, we can do this in 2 ways. The first way is our variable and then a pair of empty square brackets. The next way is we could also use the list function in Python. The list function specifically declares a new empty list. But no matter what, every list we have in Python, we will still use the square brackets. That tells Python that, hey, this is a list. In our list, I have all of these different, what we will call elements. Each element is separated by a comma. All of these elements are within those square brackets. Here's an example. I've taken the list from the last slide. This list is a list of different ages, random ages that I've put together. You can see that the lowest age is 16 and the oldest age, or the greatest, is 57. We have our variable that's holding the list of ages, and all of these numbers, as I mentioned previously, they are elements in a list. Down below I have a table. I have my elements and I also have an index. Now remember from our time working with the for loops, index means position of something. So, number 25, age 25, is at position 0. Remember that in programming starts on 0, not 1. Although, yes, we have 7 elements in this list. The first element is 0, the last element is 6. If I want to get specific or certain elements from this list, we need to get the position of the element. So down here, I take the name of my list, which is ages. We give it the square brackets, and inside the brackets, I need to give it an index. So if I print off ages 3, it's going to go to the 3rd element in my list, and it will return whatever is in that position. If I say ages 1, it goes to the 1st element in that position, and it would return 43. Key point here, if I want the last element of a list, your list could have 100 items, 50 items, doesn't matter. If you want the last element, you can say -1. That will return the last element of your list. We use these square brackets to justify the index in a list. Let's take a look at some code of how this would work in action. Here we are. I will begin with our example. In this example code, we create a program to loop through to allow us to add multiple ages to our list. We can then check if the age we entered is already inside our list. If it is not, then we want to add the age we entered to our list. Once the program ends, we can automatically sort our list from smallest to greatest. That is how this code would actually look. Now, you're seeing a few new functions and a new operator in this code. I have in our code in, append, and sort. Let's jump into what those actually mean and what they do. We have our list, and the list, as before, is named ages. And that's defined at the top of our code. This list only has 4 elements, 18, 34, 55, and 23. We then collect an input, so enter an age, and our input will be an integer. Our loop can begin while our input is not equal to 0. This loop runs. Every time this loop runs, it will check if our input age is in our list ages. In is a new operator, and it allows us to check if something is in something else. So if age in ages, I would print off you have already entered that age. Otherwise, we want to add that new input to our list of ages. We can do this by using the append method. Append in English, it just means add. We can add an item to our list. We start off with our list name. We link our append method. And the argument inside is what do we want to append? So I want to append our input to my list of ages. Ages append age. Our loop will run because we're asking for our input again until we enter 0. Then the loop breaks. As soon as our loop breaks, we have this, and this is new. I'm taking my list name ages and I link sort. I want to sort my list of ages. Now sort is a pretty cool method because it does not take any arguments. It does this automatically for us. And sort will automatically sort a list either from A to Z or least to greatest if you're working with numbers. Finally, we print off the list of ages in your list and we insert our variable which holds the value of our list. Pretty cool. So take a look at this. We have introduced in operator, the append method, and the sort method. We will use these a lot anytime we work with lists. At the end of this lesson, I will show you an additional few that we can work with as well. Here is another way to look at that. So, in this example, to begin, I'm actually using the list function this time. And remember that it is generating a new empty list. This is where for loops really become powerful, as a for loop is meant to go through an element or a variable. And remember, when we introduced for loops, we worked with variables and strings, but I did tell you a for loop is great for going through lists. We are now on that topic of lists. At our code, we have an age input. We can enter an age. I also have 2 of these variables. What are these variables called? Think about that. We begin our while loop. Every time the while loop runs, we have a for loop. For input in list. We then have our conditions. Let's break it down slightly further. Here we are. So our two variables initially were our counter variables. We will increment these every time our loop runs if a certain condition is met. Our for loop here, I have put a literal translation. I find these really helpful. What it says is for every age in my list. It's going through my list and it's checking for every age. If the age is less than 18, we increase the minor's counter variable by 1. Also, if that age is greater or equal to 70, I increase the senior's counter variable by 1. When our condition runs, at the end of our loop, it doesn't matter the age. We add that age to our list of ages before asking again. What's happening is it's allowing us to use our current index, our current position in our conditions to check if something is true. Age for I in range, for I in ages. Age is like I. It's the current index of our for loop. Where is it at? What position is it at in our list? So we have looked at two ways of working with lists. We introduced the in operator, which we are seeing right here. We saw it in the last one, if age in ages. I'm now using that with our for loop, and we're going through each element in our list. We introduced append. An append is how we add an item to a list. Great. Let's take a look at one final way of how we can generate a list. Let's head over to our next video. Our last way to generate a list is we can generate a list from a single input. Instead of making a loop and having to continuously enter a new number, I could have one input enter all my numbers and generate a list from that. Ideally, I can split an input into a list without having to loop. Let's take a look at how that's done. We have a new method again. A lot of new methods are coming out, especially since we started working with classes. We have the split method. Split allows us to split a variable and use each piece to generate a new list. Each of these pieces would be an element in our list. In this brief example, I have a variable called alphabet. An alphabet has A, B, C, D, E. Each of these letters is separated by a space. That's great news for us. I can take my alphabet variable and I can say, hey, Python, alphabet is now equal to alphabet.split. And I am splitting anywhere a space is found. If I print off alphabet, this is actually a list now. It would look like list of letters, and then it would have our list down here, with each letter as an element in that list, because we split wherever we had a space. Breakdown of how this would work. I have two ways put on the screen currently. Split takes one argument. Where do you want to split your list? If you're working with strings, then this should be a string. I have a string inside there because it's quotations, but then I have a space in here. So everywhere that I find a space here, it's going to split and use each element as an item in my list. In our next way, I'm working with one long number. I have a variable, and in this variable, it's just 0 and 1. If I were to split that variable, and I want to split it everywhere that there's a 1, then it would generate a list for us. Our list would look like this. We have 3 elements. I don't see the 1 anymore because that is where I split my list. Remembering that split takes one argument. Where do you want this to split? That will generate a list. In the first example, because Python reads top to bottom, this first one does not apply anymore. Alphabet has become a list. In our second option, binary does not apply anymore. It has become a list when we called the split method. Here's the list that we worked with earlier, but this time to generate the list, I'm using the split method, so I only need to have an input one time. Originally, I'm collecting it from my integer input, and I'm entering the ages with a space. I then take my input, and I create a new variable which updates the value. And here I am splitting my ages input anywhere I have a space. I then have my 2 counters just like before our for loop. Now I can begin to go through ages because it has been turned into a list. For every age in my list ages, if the current age that I'm on is greater or equal to 70, I can increase my counter by 1. Also, if the current age that I'm on is less than 18, I can increase the minor counter by 1. Finally, once the loop goes through my entire list of ages, I will print off the list of ages, and I can also print off the number of seniors and the number of minors. We use our index, which is our position in the list. We use our index age from our for loop. Every time the loop runs, it checks if that index is a senior or a minor. Because I'm splitting, I don't need to use the append method here. It's automatically generating a list from one input for us. Great, guys. That is our final way to create lists. Let's take a look at a few things we will see along the way while you're working with lists. Here is everything that I've talked about over the last few minutes. All of these are the methods and the ways that we've learned while we're working with lists. You may see one new one that I didn't have in any examples. The opposite of append is remove. So append, we add an item to a list. Remove, you can remove an item from a list as well, just by linking remove to your list. Take a look at these before we head over to VS Code. When you're ready, I'll see you guys there. Welcome, guys, to VS Code. In our lesson, we have introduced lists and how to work with lists in Python. We learned 3 different ways to work with them and create them. In this video, initially I have 4 challenges for us to work through. I've also included a bonus challenge at the end, which we will see very soon. If you're up for a challenge, which I hope you are at this point, pause the video here, read through, and give these a shot. Okay, I'm going to begin with number 1. At this time, I will zoom in a little bit for us. Number 1, Create an empty list, then ask the user for an input. Enter the name of a fruit. You guys can get creative here if you want to do something else too. That's fine. While the input is not quit, add the input to your list and ask the question again. Once the user enters quit, ask the user to guess a fruit. Loop over your list. If the guess is in your list, print congrats, you guessed correctly. Otherwise, print sorry, that's not the correct answer. Great. Let's begin with our list. So I will create a list called answers. You can use either of the ways we learned. Here I will use the list function. Then I need an input. So fruit equals input. Enter the name of a fruit. There we are. While fruit is not equal to quit, my loop will continue to run. Every time it runs, I would like to add the input to my list. What is the keyword to add something to a list? Append. I can take my list, answers, and say append. What do I want to append? I want to append my input fruit. I then will ask the same question again, so I can place that input in my loop. Great. My loop is done. After we append all these different fruits to our list, we would like the user to guess. And we want the user to guess specifically a fruit, so guess a fruit, like so. We want to loop over our list. How do we loop through a list? We don't want to use the while loop here. Our for loop. For answer, for every answer in my list answers, I want to do something. If my guess dot lower, I could say that because I haven't checked per se yet. And instead of doing that there, although I could do that, let's just convert this to lower. If our guess is equal to our answer, then I will print off congrats. You got it. And what's happening here, guys, is this is looping through. And what this is translating to is for every fruit in my list fruits. The first time this runs, it's going to be on the first fruit. So if my guess is equal to the first fruit, it would print this off. Then if I got that on the first try, I don't want it to keep going. I want it to end. Else, we could say here, sorry, that's wrong, like so. All right, let's give it a run. First up, we need to append fruits to our list. So I'm going to enter a few. Enter the name of a fruit. Apple, dragon fruit, pineapple, strawberry. There we go. I will say quit. I'm done entering. So in my list, currently I have apple, dragon fruit, pineapple, strawberry. I will guess a fruit. My first guess, I will say blueberry. Sorry, that's wrong. What's happening here is it's actually repeating that 4 times because my loop is still in the process of running. It didn't instantly break. In order to get that to break, we could also put a break here that when it hits else, it's immediately going to stop. I'm going to run that again. And this time I'm just going to enter 2 fruits. I'll say apple and blueberry. Those are the 2 in my list. I'll quit. This time, let's say pineapple. There we go. Sorry, that's wrong. We broke. I have another break statement here. If I were to get that correctly, then it would print congrats, you got it. So I'll add apple to the list. We'll add blueberry to the list. I will say quit and then guess apple. Congrats, you got it. Cool, our first challenge is complete. Let's proceed on to the second challenge we have for working with lists. Going down to number 2, we want to create an empty list for capital cities. Ask the user to enter a city. As long as the user doesn't enter 0, the program continues. Check to see if their input is already in the list. If so, print you have already entered the city. Otherwise, add the city to your list. When the loop ends, sort your list before printing off your sorted list of capital cities. Great. Let's begin by creating a list, and because this is a new empty list, I will use the list function. Then we will collect an input here. I will say enter a capital city. Converting this to lowercase. While our input is not equal to 0, string, because our input is a string, then I want to check if the input is already in my list. So if city in my list cities, it's already there. I would like to print off you have already said that city. Else, we can take our list and we can append the new input city to that list. Our loop has ran. I want the loop to continue. I will add our input at the end. Once we're done with that loop, I would like to organize my list. And remember that we have a new method we introduced that automatically does this for us. We can take the name of our list, cities, and I can say sort. And that will automatically sort the list for us. I will then print off list of capital cities, and then my list, like so. Great, I'm going to run through. I'm going to enter a few capitals here, and then let's see what we get as our output. First capital, let's say Berlin, Hanoi, Beijing. What's another good one? Washington, D.C., I guess. Bogota. There we go. I will enter 0 to quit. Now notice that my capitals are not in alphabetical order. Now they are. List of capital cities, and then it prints off my list. Each of those capital names is an element in that list. Beijing is at position 0. Washington, D.C. is at position 4. Because Python starts on 0. Good work. Alrighty. I will turn off challenge number 2. We are going to roll into challenge number 3. We want to enter the basketball players in one input with a space between each name. I want to create a list from this. I'll create a variable to find the length of the list. I can declare a new empty list as well for teams. So I'm going to check these two. We're actually making 2 different lists. Loop through each player and assign them to a random team from 1 to 3. Ending with looping through the numbers of players and print off their name and team number. Okay, slightly more challenging now. What do we need to do here? Well, the first thing I noticed was the word random. So that must mean I need to do something randomly. Let's say from random import star. I now have access to all the functions in the random library. I would like to say players, and players is going to be an input. I will say enter each player. What we want to do is I want to create a list from this. What method did we learn which allows us to create a list from a single input?
Well, let's take our players, and let's say players equals players dot split. I'm going to split that every time there's a space. What I could also do to make this more efficient, I could take my split method and link it to my input, kind of like we do with lower. Now that I have that, I would like to create a variable to find the length of this list. So I will say here player amount, and that is equal to the length of players. Players is going to be a list because we are splitting this input everywhere with a space. Instead of having multiple inputs, I have one. Each name I have, I'm giving a space between that name. This generates a list. I am now getting the length of this new list. Moving on. We will create a list for teams. And I can use the list function here. We don't have that yet. I will begin to go through every player in my list. So for every player in my list players, I would like to assign them to a random team. So I'll create a variable. The variable is equal to random. And I said there is going to be 3 different teams. Now I can append this random team to my list. What to do here? Team.append. Random team, like so. Great. That loop is done. So I have a list. I'm going to do this out like this. Let's say Bill, Bob, John. That's my list of players. Then I have a list of a random team. So I'm going to say 2, 3, 1, like so. What's happening is I have 2 lists here. Bill is in position 0, which means he will be the first player when this loop runs. He is assigned to team 2. My loop runs again. The second player is Bob. We are appending Bob's team to the team list, so Bob is on team 3. That's what's happening here. I'm working with 2 different lists. Let's create a for loop now. I want to go through and repeat however many players I have. So for I in range. I want to repeat this. If I have 10 players, I want to repeat this 10 times. What do I put in here? Well, we got the length of our list. If there are 10 players, it's going to repeat 10 times because that's how many are in our list. Every time this runs, we would like to print off the player and the current player I'm on. So I'm going to say I. And remember, I is index or position. And that position is taken from our for loop here, for I, for players. And that position is taken from our for loop here. Great. Then what I would like to do is I would like to print off the index that matches the team as well. Great. I'm going to go through and run this, and let's watch what actually happens here. Let's go through and let's enter each player. So each player, let's say Josh space, Bill space, Aaron space, Sally space, Jenny space, Al. Enter. There we go. Out of our input, I generated a list, which we can't see that list, and then we generated another list for team. Each of our people, each of our players, they have been assigned to a random team. You can see that I'm on team 2, Bill's on team 3, Aaron's team 1. All of us were assigned randomly to that team. Pretty cool, huh? Working with 2 lists, working with the random library, and printing off the index, the position in the list as well. All of these are good challenges. Great. Moving on to our fourth challenge. In our fourth challenge, I gave you a list, and the list is actually here. I want you to use this list. If you want to change the names or the scores, that's fine. We then create a counter variable. So I'll actually just start. I'm going to just take this, put that there. I have my list made. Create a counter variable. Okay, I will create a counter variable. We are going to be calculating the average. So this will be used to find the average score. You should know how to find the average score of something, and that's what we'll do in this challenge. We want to create a loop to loop through our list and get the score from each person. Ooh, interesting. We have our string, but all I want is the number at the end. How can I do that? Your mind should be spinning at this point. The clock should be ticking. Your mind should really be thinking at this point. This is a good, tough challenge. So I have each element in the list, but within each element, I just want the last part of it, the 5. Let's loop through our list. So for every score in our list scores, I want to get a score. And so I will call this X. I will say X is going to be an integer. Now I need to access the element. I will say score. That's the current position I'm on. And I want to get the index of that. So the length of the score minus 1. Remember that minus 1 takes the last part of a list. In this case, it's going to take the last part of our string. Great. My average, we now want to increase by X. So all this is doing is it's going to add together all these scores. 5, 4, 3, 3, 4. That's what's happening every time this loop runs. Once our loop completes, in order to find the average, we need to take our average and divide it by the length of our list. To do this, I can say average divided by equals the length of our list scores. Another way to do this, right, is average equals average divided by the length of our list scores. So both of these are doing the same thing. You're taking your average counter and dividing it by however many elements are in your list. That gives you the average. This is the same thing. It's like saying plus equals, which we have been using. I'll delete these. And then finally, we will print off the average score, print off your average variable. That's it. Great. Let's run this. So I'm going to go through and let's see what our average is. Our average is 3.8. Okay, let's change this. Let's say Billy has, let's keep 5. Let's change that to a 5. Everyone has pretty good scores. Let's run that again. There we go. Our average score was updated. We split through our list and we got the last character from each element. And this element we converted to an integer and we added that integer to our counter variable average. Very well done. This brings us to our bonus, which you have not seen yet. I will let you guys pause the video here. Read this bonus. This is quite challenging. I've also given you a clue. This is called a notation. If you want to read up on notations first, I suggest you do so, and you can read what's happening here as well in order to solve this problem. Pause the video here for a tough bonus challenge. Okay, I'm going to jump in. For our bonus challenge, create a function that takes a list as a parameter. If the list is 0, return none. Otherwise, the function calculates the average of the numbers from the list. I will begin with that. I'll create a function called calcAverage. This will take a list of numbers. If the length of that list is equal to 0, I will return none. If the length of the list is 0, it means the list is empty. There's nothing inside. Else, I want to return the average of the numbers from that list. How can we do this? We need a quick way to add everything together. At this point in our course, you should be doing a lot of research on your own outside of this course. Many of you may have come across a few functions that we haven't used. One of these functions is a very basic Python function. It's called sum. It allows us to add things together. So I can put my list in there. It's going to add together every number in that list. Then I will divide it by the length of that same list. Moving on. Create a loop to run through the length of your list. Generate a new list every time the loop runs with the current index of your list. Call the function and give it the sublist, which we have here, and then print off the average grade. So what's really going to happen, guys, is your code is going to run a lot of times. And the first time it runs, it would go like 0. The second time it runs, it's going to go 0, 1. The third time, it's going to go 0, 1, 2. Every time the loop runs. Every time the loop runs, it's also going to calculate the average with the numbers currently in that list. Let's jump back in. Let's say for I in range for the length of my list. So I want it to repeat for however many numbers are in my list. I don't have a list yet. So number list is equal to create a list and put some numbers in it. So let's say 2, 5, 6, 4, 3, 1, 7. I want it to run for however many elements are in my list, number list. This is going to run 7 times because there are 7 elements here. Now we need to create almost like a new list, a sublist per se, and this sublist will be called number list because it's a new list generated from my current list. What we're going to say here is I'm going to make a notation. I'm going to say I, that's the current index, plus 1. I'm adding 1 to our current index. Every time the loop runs, it's creating a new list from this. I then need the average. The average is going to be equal to my function. In my function, I will give it a list, and that's going to be the sublist that we just made every time this loop is running. Every time the loop runs, we can print off something like the average of our sublist, is, and our final step here would be our average, which is going to be average. Done. Okay, let's run it. Let's watch what happens. Keep a close eye on my terminal. There we go. Okay, so it starts off with the first element in my list, which is 2. And it calculates the average, which is currently 2. My loop runs again, and it adds the second element, which is a 5. And then it updates our average. And you can see that my list is growing with every line. The final conclusion is our average is 4 of our entire list. That was quite a bonus challenge. If you got part of it, if you got all of it, very well done. That concludes our lesson for working with lists. I will see you guys in our next lesson.